Hey everyone, and welcome to the MERN Full Stack Crash Course. This course is going to teach you how to build full stack web applications using the MERN Stack. From the front end to the back end, we'll cover it all. In this first episode, we're going to go over exactly what the MERN Stack is, what each technology does in the stack, and we're going to break down exactly how this course is structured. The MERN Stack is one of the most popular and efficient frameworks for building full stack web apps. The acronym MERN stands for MongoDB, Express, React, and Node. Each of these plays an essential role within the stack, and in this course, you're going to learn exactly how we can utilize all of them to create amazing web apps. Let me explain what each of these technologies is responsible for, starting with React. React is a JavaScript library used for building front-end web applications. If you open up a web app built using the MERN Stack, everything you're seeing on the page is built with React. All the pages you can route between, all the little buttons or images on each page, all the styling and everything else is done with React and a little CSS. Basically, everything a user sees on a web page is built using a React frontend. In this course, I'm going to assume you have at least a basic understanding of React. If you don't, I'd highly recommend watching my full React course first. That way you're not having to learn React on top of all the backend stuff. The next two technologies I want to talk about are Express and Node, which come as a package deal because they're both used to take care of the server aspect of our code. Node.js is a JavaScript runtime environment that allows you to run JavaScript code on your machine. However, Node is also used to run a server for your backend code. We could just use Node by itself to take care of all of our server functionality. However, it can get a bit messy, and that's where Express comes in. Express is a framework for Node that makes it easier to work with a server. Express is a framework for Node in the same way that React is a framework for JavaScript. Sure, we could just do vanilla JavaScript and get rid of React, but that would make things a lot harder. The Express framework makes it easy to write backend code for your app, set up API routes, and do all sorts of other things you may need to do with a server. In the context of MERN, Express builds backend routes that your frontend can interact with. The routes are HTTP routes, and this is how we're going to connect our frontend with our backend. Last but certainly not least, we have MongoDB, which takes care of the database aspect of our application. MongoDB itself is a database, meaning it's somewhere where we can store all of the data we need for our application. It's a NoSQL database, meaning data is stored in a format similar to JavaScript objects, which makes it very easy to work with in JavaScript. On top of that, it's arguably the most popular NoSQL database in the world and has tons of support and documentation behind it. When you hear the terms frontend and backend, just know that frontend is referring to building the actual website using something like React, and backend is referring to running and interacting with the server as well as the database. In that case, React is the front end, and then the other three, being Mongo, Express, and Node, are all involved in the back end. Full stack web development, which is what we're learning in this course, encompasses every single one of these things. You need to know how to work with a front end framework like React to build web pages, a back end framework like Express with Node to handle all the functionality behind the web pages, and you also need to know how to interact with the database in order to be able to create, read, update, and delete data. Let's imagine we have a blog website, which will actually be the project we build during this course. How and where do each of these technologies come into play? So a user first navigates to the website. The landing page they see is built in React, as are all the other pages they could possibly navigate to. All the buttons, all the interactivity to go between pages, etc. It's a blog website, so users need to see blog posts, right? Therefore, in the code, React makes a request to the server that Node.js is running to grab all the blogs so they can show them to the user. Specifically, it requests data from one of the routes that Express has set up. Express receives this request and, using some backend code that has been written, goes and grabs the blogs from MongoDB because that's where all the blog data is stored. MongoDB then returns all of the blog data that was requested to the backend, meaning to Express, and then Express subsequently returns this data to the front end, and then that data is displayed on the React page. Now, the user who navigates to this site is able to see all the blog data. This sounds like a complicated process, but this all happens most likely in the span of milliseconds, and the user or client can't really tell what all has happened behind the scenes. So, the next time you go to a web page and you see a loading icon on the page for a second or two, just know that that's because they're making a request to the server, and then the server has to go and grab data from the database and then return that to the front end. Now that you have a basic understanding of the MERN Stack and how each technology helps build a web app, let's outline everything we're going to cover for this course. The first episode after this one will be about getting our MongoDB set up. You'll learn how to create a free database using a tool like MongoDB, how to connect it to your app, and how to use the MongoDB library to access this database whenever you want inside your code. After that, we'll set up the server using Node and Express. You'll learn how to spin up a server on any given port and how to connect that server to MongoDB. Next, we'll dive deep into Express and write most of our backend code. you'll learn how to create express routes, which is how we can connect our front end to our back end. Inside of these routes, you'll learn how to create, read, update, and delete stuff from our database. Once all of that is said and done, we'll finally dive into the React code. You'll learn exactly how to call backend functions in React and how to use React tools like useEffect to load data from a database onto your page. Then we'll spend a couple of episodes fleshing out our React pages to ensure we have all of our functionality that we want in the context of having a blog website. Next, you'll learn how to do user authentication in a full stack project. This means being able to create user accounts that we can store in our database. You'll learn how to encrypt passwords for the database, how to store user information, and how to disable site access to those that aren't logged in. The last major thing you'll learn is how to handle media like images or video in a full stack project. You'll learn how to upload images to a database system, how to retrieve them, and how to connect them to a database like MongoDB using other tools. In the very final episode, you'll learn how to make a site look nice and presentable using Tailwind CSS, which is a CSS framework. You'll learn about some design principles, and you'll get a good idea of what it looks like to style a front-end site. With all that being said, I hope you're ready and excited to get into this course. There's a lot of stuff planned for this course, and it's taken me a while to flesh all of it out for you guys. Let's get you on the right path to becoming a full-stack developer. Take care, everyone, and I'll see you in the next episode. Hey everyone, and welcome back to the MERN Stack crash course. In this episode, we're going to create our React project using Vite, and after that, we're going to start with the backend by setting up and configuring MongoDB. The first thing you'll need to do before we get started is ensure you've installed Node.js. To install it, head to nodejs.org and install the latest version. Node is the only program we'll need to directly install onto our computer because all the other technologies we can install as packages. When you install Node, it'll automatically install NPM, which stands for Node Package Manager. NPM is what allows us to install all the external libraries that we're going to need. We'll use it to create our React application with Vite, and we'll also use it to download the Express and MongoDB drivers. Once you install Node.js, it should automatically add itself to your path, which allows you to call Node from the command line. If you're on Windows and you want to double check this, go into your Windows search bar and type Edit Environment Variables. This little menu will pop up and open up this window. And then you want to double click on this path variable here, and somewhere in here you should see a reference to Node.js. If the installation went correctly, it should be right here, but if not, you can click this new button and then the browse, and you can find wherever you install Node.js on your computer to add it to your environment variables. Next, open up whichever IDE you prefer to use. I always use Visual Studio Code. Then open up the terminal, which in VS Code you can go to View and then Terminal here, and then you want to navigate to whichever folder you want your project to be in. To navigate between folders, you can use the CD command. Inside this file path, I have a folder called Source, so I'll CD Source like this. And then inside the source folder, I have one called repos, so I'll cd repos. And this is where I usually store all of my code bases. And just so you can see this better, I'm actually going to maximize this so I can bring it up a little bit. Next, I'm going to make a new folder in the repos directory by using the make directory command. All we need to do is type mkdir, which stands for make directory, and then pass in the name for the folder that we want, which I will just call, let's say, full stack project for right now. And this is where we're going to store all of our code. So that creates a new folder, and then I want to cd into that folder, so we're then looking in that folder. So I'll say cd full stack project, and now our terminal is looking in the new folder that we just created. Once you're in the folder that you want, type the following command: npm create vite at latest. What this line does is creates a new React project using Vite, and will run you through the installation process, which is super easy and just asks you a few questions. So I'll go ahead and press enter here. And first it'll say you need to install this package. We'll say yes. And then it'll ask for a name. So for this project, the Vite setup will just represent the front end aspect of our app. So for right now, I'll just name this project front end like this. And then it'll ask you what framework you want to use. Let's go down and select React, press enter, because obviously this is a course for React. And then it's going to ask if we want to use like a TypeScript or a TypeScript variant or JavaScript. For this course, we're just going to use JavaScript to keep it simple. So we'll select JavaScript, and you'll see it says done now, and it gives us these 3 commands down here to follow. Once you've walked through all these steps, it will create a new folder with whatever name you entered. In our case, it made a folder called frontend. It gives us 3 commands to follow to get our front end booted up. I don't actually want to launch the front end right now, but let's cd into that folder and install all the packages that we need. And just so you can see what this folder looks like that Vite created, we can go into this open folder button here and then find the folder that you just created. So in my case, I've made it in my repos folder and I called it full stack project. So I'll go ahead and select folder here. So we can open the full stack project, and you'll see inside of this here, we have a folder called frontend that we just created with Vite. Now let's get back to installing all the packages that we need. So we'll reopen the terminal here, and then we want to make sure that we are now looking in our frontend folder and not just the full stack project. So we'll say cd frontend. And then from here, all we need to do to install all the packages that we need is run a command called npm install like this, press enter, and we'll go ahead and run it. So what npm install actually does is it looks at this package.json file that V created, which contains all the packages your app relies on, and then goes out and installs all of those packages. When we make an app with V, by default it adds a bunch of packages for it to run, hence why we need to run npm install. Now we could launch the front end if we wanted to right now, but let's actually focus on getting the backend folder set up before we launch the front end. Let's now go back into our terminal and let's navigate back one folder. To navigate back a folder, we can do cd ... and you'll see that now we're looking at the full stack project folder. We have a folder for our front end, but now let's make a folder for our backend. If we want to get fancy and make a folder in our terminal, we can just type make directory again, and we can say backend. Once we run that, you'll see in our file explorer here, we just added a new folder called backend. Now let's look back into our terminal and let's go ahead and cd into the backend folder so that our terminal is now looking in backend. This is arguably the most basic file structure for a full stack project, where we just have one folder for all of our front end code, and then we have one folder for all of our backend code. In a full stack project, the front end and backend code should run completely independently of each other, so we should make sure we're not muddying up the code and getting the files all mixed up. Let's start off with the backend by getting some of our backend code set up. Now, MongoDB is our database that we're going to be using, and that's one of the main reasons we need backend code for our project. So let's work on getting the MongoDB code all set up and running. In order to set up anything with MongoDB, you'll need to go on their site and first make an account if you don't already have one. Their site is just mongodb.com, and you should be able to make an account after clicking this try free button up here in the top right. Once you've went ahead and made your account, head to the MongoDB Atlas page if it doesn't automatically redirect you there. If you need to access it with the URL, it is just cloud.mongodb.com. Once you're on this page, you should be on a page that says Database Deployments. Each account you make with MongoDB gets you access to one free cluster to deploy a database on, so you shouldn't have to worry about spending any money to get this set up. I've already set my free cluster up, but I'll walk you through the process. So over here, there's this plus button here, so go ahead and click that for a new database deployment, which will take you to a page that looks something like this to create a new cluster. Before you do anything else, make sure you go to the Shared tab over here on the right in order to access the free servers. If you're on serverless or dedicated, it's going to require a credit card because it'll charge you money. Once you are here, you have a few options. You can choose between AWS, Google Cloud, or Microsoft Azure. If you heavily prefer one of these services over the other, go for whichever service you like. However, if you're indifferent, I'd suggest searching through each provider and finding the location which is geographically closest to you. For instance, the cluster I already have up and running is hosted on the AWS US East 1 location. If you scroll down on this page and go to cluster details, you can go ahead and change the name of your cluster to be whatever you want. By default, I believe it's just cluster 0, and that's what mine is because I haven't changed it. Actually, mine's cluster 1 because I've already used cluster 0. But as you can see, my create cluster button here is grayed out because I already have one created, but it should be green for you. So when you're ready, go ahead and click create cluster. Once you've created your free cluster on whichever service you want, make sure you're back on this page and then look on the left-hand side and find the tab where it says database, which should give you a screen that looks something like this. Next you want to do on this cluster menu is click this button here that says connect. So click on it and you'll be met with a screen that looks like this, where it gives you a few options on ways to connect to your database. You'll want to click this top option here that just says drivers. Go ahead and click on this driver dropdown and make sure you have Node.js selected because that's the driver we're going to be using for this project since we're using JavaScript. Then you can see it gives you some directions on how to get it set up. And we're going to follow those exactly. So step 1 is says to npm install MongoDB. So let's go back into VS Code and let's make sure we're still looking in our backend folder. So then what we're going to do is type it exactly as it said, which was npm install MongoDB just like this. And then we'll give it a second to make sure it installs. What this does is installs the MongoDB package for JavaScript, which will allow us to connect to our database. Once you've done that, step 1 is complete. So let's go back to our MongoDB page. Next, there should be a little slider button here that says view full code sample. Go ahead and check that box and it should open up some code that looks something like this. Press this button here to go ahead and copy all of the code. We're going to modify this code a little bit because this doesn't factor in Express at all, but this gives us a good starting point. Next, let's navigate back into Visual Studio Code, and then let's actually go ahead and shrink this terminal for a second. Let's go into our backend folder, and then inside of our backend folder, I'm going to make a new file. I'm going to call it connect.js, just like this, because this will be the JavaScript file responsible for connecting us to Mongo. Then once you've made this file, go ahead and paste in all the things we just copied from Mongo. Before I explain what this code does, let me just shrink the terminal here. Then I'm going to zoom in the code a little bit so it's easier to see. Before we get any farther, let's configure this file for our use. If you notice here, we have this URI string, which is basically just a unique key to access our application. You'll want to make sure you remove this whole password thing and enter in your actual password that you use to log into MongoDB. I would caution you, however, on putting this URI inside of this file, this connect.js file. If you're only running this on your computer and don't plan on putting it anywhere else, this is fine and won't be an issue. However, if you're using GitHub, for instance, and you're going to be making this a public or remote repository, it's probably smart that you don't put passwords in files that are going to be visible on the internet. Even if you're not making it public, this is generally a good practice to follow. Because of this, I use a package called .env that helps to hide the passwords by putting them in their own separate file that won't get pushed out publicly, which is generally good practice, as I said. To quickly do this, make sure you have your terminal open, which I should probably just keep it open. Let's reopen our terminal here, make sure we're in our backend, and then run npm install .env just like this. What we generally want to do now is go into our backend folder and create a new .env folder. I usually name mine config.env. I'll say config.env like this. Then I want to go in here and make a variable, which I'm going to call atlas_URI equals. And then what we're going to do is we're going to go into our connect.js file, and we're going to copy this string here. We're going to copy it, and then we're going to paste it as our URI, just like this. And note that we don't actually need these quotes here because it's not a normal string. So let's go ahead and just delete these quotes here. We can go ahead and save this file by using Control-S. And then let's navigate back to the connect.js file. Now that we have the Atlas URI string in this config.env file, let's go ahead and just delete the string that we have in this file. We'll delete this here. And then right below where we're requiring MongoDB, let's go ahead and tell our .env package where to look to find our Atlas URI variable that we just made. To do that, type this line here. We will say require, and we'll say .env, which requires a .env library. And then we'll say .config. And then we want to pass in an object that just says path, and we'll say ./config.env. So what this line does is basically just tells the .env package that we're storing our environment variables in the path of config.env because we made the file called config.env over here. In just a little bit, I'll go way more in depth on what this require line actually does because you're going to see it quite a bit in Node. But for now, just think of it as a way of importing files or packages into Node. Now, all we need to do to access our URI is type process.env, and then whatever the name of our variable is, which we named it atlas_URI in our config.env file. I'll go ahead and save this file. And then one thing you want to make sure of in this config.env file is that you replace your actual password here. I'm not going to show you mine for security reasons, but make sure you fill your password in here or else it won't connect properly. And that includes getting rid of those less than and greater than signs on the end here. Now we've essentially taken our password and put it into our own secret file that we'll be hiding from the public if our repo isn't private. It depends on what you're using, but if you're using something like GitHub, you'll want a .gitignore file that tells Git to ignore .env files, meaning it won't make them public. This is what'll keep your passwords private. Anyways, let's get on with the MongoDB connection. At the top of our code here, after our imports, we have this const client equals new Mongo client line, and this is actually a constructor. All this constructor does is makes a new variable to represent your Mongo client by calling the Mongo client function from the MongoDB library we installed a moment ago. All that this function actually really needs is a URI string, which we've already passed in. However, in this case, we're also passing in a second argument that is an object that just provides some customization for the client. It tells the client which version to use and sets the strict and deprecation errors to true. Again, this is personal customization stuff, but we'll just stick with what Mongo gives us for right now. Before we go any farther, let's quickly navigate back to the MongoDB website. You may be wondering, where is our data actually stored on here? So let me show you. To find it, make sure you go to your database tab. We'll open up our cluster here. And then once you have your cluster open, you should see this tab at the top here called Collections. And this is where all of your NoSQL data is going to be stored in the form of collections. Collections in this context of MongoDB are just a collection of essentially what are JSON objects. Over on this left-hand tab here, you can see that I already have 3 databases because of previous projects that I've worked on. For you though, you probably won't have any set up right now, so we actually want to go ahead and create some. So you can actually create a database using this Create Database button. Go ahead and click on it, and let's enter the name of whatever database you want. For right now, we'll just say, since we're building a blog, we'll just name the database, we'll say blog data. And then every database needs at least one collection in it, and it also asks for a name. For right now, let's start off with one collection just called posts, which will represent all of the blog posts that we're making. And then we'll go ahead and click create. Once we've created it, you should see here on the left-hand side that we've just created a new database called blog data that has a single collection in it called posts. The way this works is that when we want to access or upload new posts to our database, we'll simply add objects to this post collection right here. Sometimes we might want multiple collections, like if, for instance, we wanted to have a collection for all of our users as well. We could call a collection users and then use that collection to store all of our user data. Just so we're entirely on the same page here, let me clarify how MongoDB was organized. At the most upper level, you have what are called clusters. Like right here, we have cluster 0 for this project, which is what we made when we selected AWS and made this big cluster that you're seeing here. Clusters are basically just the collection of all your data spread across whichever servers you decided to host on. And then inside of clusters, we can have multiple databases. This bug tracker data here, project to do at blog data, these are all databases that I made within this cluster, which broadly represents the storage locations for your project. MongoDB at heart is a database, that's what the DB stands for, and these databases are the main functionality of Mongo. And then inside each database, we can have as many collections as we want. Collections are where we store each of the NoSQL objects that we upload to Mongo, and they look a lot like JSON objects. If we had 10 blog posts, for instance, then our post collection would have 10 objects inside of it, one for each post. Before we dive back into our code, I want to quickly make a few sample objects in this post collection so I can show you how Mongo works, plus it'll make it easier for us to do testing later on. We'll take care of creating objects through our code in the coming episodes, but if you want to manually put an object in Mongo, you can hit this Insert Document button right over here, and it'll open up this window. Whenever you insert an object into Mongo, every object automatically gets an ID because each object needs a unique identifier. And from here, we can just add whatever fields we want. And this plus button will actually add more fields if we want them. So we can click this and add a couple of fields. Now, what we're wanting to have here is objects that represent a blog post. And there's a lot of different fields we can kind of include on these objects for now. But for now, let's make a few fields. We'll do, let's say title, we'll do description, and then we'll have author, and then let's say like a date created, as these are probably the most like essential fields that we could need for something that would be a blog object. And I'm actually missing one of the probably most essential fields, which would be the content. So the actual content of the post, we can add that here. And then here we can just fill in the values manually for each of these fields. And notice how on the right-hand side, you can hit this drop down here to bring up a whole array of options. There's, arrays, booleans, dates, all this stuff. We'll keep most of these as strings for right now. So let's say for this one, I'll make it something random. I'll say like Tom Cruise movie for the title. I'll say like new Mission Impossible for description. Content, I won't worry about this for now. I'll just say blah, blah, blah. Author, I'll just say it's myself. I'll say it's Austin. And then this date created will be the only thing that isn't a string. So I'll go ahead and go over here to this drop down and we'll make it a date instead. And then here we'll just enter, let's say like 2/16/2024. And it should, actually, hold on, let me go ahead and edit that real quick. It saved it as a string, but that's not what I wanted. So if I want to edit the document, you can just click this little pencil icon over here. Let's change this back to a date again. And then here, because it was already kind of in like a date format as a string, it'll automatically convert it. This is what dates are going to look like in Mongo. And then we'll just go ahead and click update to finalize the update. And here you can see we have our first official object in our post collection. I went ahead and just added 2 objects in our post collection. So now we have a total of 3 objects in this collection overall. So now that I've inserted a couple of documents, that'll definitely come in handy later. Plus, hopefully it helps show you how these object documents sort of work. One last thing with MongoDB before we get back to our code. By default, clusters and databases in Mongo will lock out any IP address it doesn't recognize for security reasons. If it doesn't recognize the IP address of your server, it's not going to let you access Mongo at all. If you want to add your IP address to Mongo so that you can access it, you'll need to head over to this Network Access tab over here on the left-hand side. I'm blurring out my IP addresses out for obvious reasons, but this is where a list of all valid IPs are kept. I don't remember if it by default adds your current IP address, but if it's not already on this list, go up here to the top right and there's this green Add IP Address button, and you can go ahead and click it and it'll bring up this little window here. And there should be a button here that will say Add My Current IP Address. This is a super important step that you can't miss, otherwise Mongo is going to block you from connecting to your own cluster within your code. Once you've done that, let's finally get back to the code. As part of the code that we copied from MongoDB, we have this entire run function here. This run function, however, is just testing and pinging the MongoDB server, which is nice for testing, but doesn't do what we want for setting up a persistent connection to Mongo. So let's actually go ahead and just for right now, I'm going to go ahead and comment out this whole function right here. Then I'm going to go ahead and go up here and I'm going to make a variable to represent the database by just writing let database. and I'll show you how this comes into play in just a moment. Next, let's think about what we actually need to do in this connect.js file. The name of the file is connect, so it would make sense that we would need to connect our code to MongoDB. However, we also need to take something else into account. We're going to be connecting this MongoDB database to a server, and we're going to have our own separate file for our server. Therefore, we're going to have to export the functions from this file so we can use them in our server file. The next episode will dive into the whole import/export scheme, but for right now, just know that we need to specify our exports in something called Module.exports. Module.exports is from Node, and I'll explain in more detail how it works in the next episode. To do this, we can just write Module.exports equals and then an object, so we'll specify curly brackets. Now, in this object, we can specify any functions or variables that we're going to want to export. The first one will be a function that will actually connect to our server. To make a function inside of an object, we can use a simple format with arrow notation. We'll name this function, we'll say connect to server, write a colon, and then we'll do parentheses for the arguments, and then we'll do an arrow function. So we'll do an arrow, and then curly brackets for the actual function content. If you look down here at our sample code, you'll notice that it has this client.connect method. However, we don't actually need to use this in the most recent version of Mongo. Instead, what we can do is just access our database directly by using the .db method. To do this, we can take our database variable that we just declared up here, and we'll set it equal, we'll say database equals client.db, just like this. And then inside this DB, we need to pass in the name of the database that we want to access. If we go back to our Mongo page and we go back to our database, we'll remember that if we look in our collections here, give me a second, that we named our database blog data. So if we're going to access the database using the .db method, we should pass in the title, which is just blog data, just like this, as a string. What this will do is assign the database variable to the blog data database we have in MongoDB. This is super helpful because this is what will allow us to actually interact with our database in our code. And just hopefully you didn't forget, this client object that we're calling the DB method on is, remember, just this object we made up here, which is created using the new Mongo client constructor. In our module.exports object, let's add one more function that will allow us to easily grab the database whenever we need it. So let's make a function right here. Actually, we'll separate this by commas. Make a function, let's call it getDB, do a colon again, and then parentheses, and then another arrow function, just like this. And all we want to do with this function is literally just return database like this. Assuming the connection goes through with this connect to server, this database variable will contain the actual blog data database. Therefore, if we need to access it, we can now just easily call this getDB function to get it for us. Now, these two functions are going to be really important for us. Connect to server will create the initial connection between our code and our blog data database. And then anytime we want to access the database from that point onward, we can use this getDB function to give it back to us. We'll just have to be careful to only call this getDB function after this connect to server function is called, because otherwise database wouldn't be defined here. And that's going to officially wrap up this video on setting up MongoDB for your backend. In the very next episode, we're going to actually get the server up and running, and I'll explain how these module.exports come into play. Take care, everyone, and I'll see you in the next. Hey, everyone, and welcome back to the MERN Stack crash course. In this episode, we're going to launch our server using Node and Express. So last episode, we left off with two folders. We have the front-end folder and the backend. We've been working on setting up our backend. In the backend folder, we should just have a couple of things here. We should have this package.json and package.lock.json files, which just contain information for the packages we are using, as well as this node modules folder that actually contains the packages themselves. Then we should have this config.env that contains our unique access key to Mongo, and then the main file we were working in last episode called connect.js, which writes the functionality to get us connected to MongoDB. At the very end of last episode, we left off working with this module.exports object, and I didn't really go over fully what it does in the last episode, so let me explain it to you now. When we're using Node.js, every JavaScript file can specify one module.exports field. Anything specified within the module.exports field can be imported into another file by using the keyword require. It's very similar to the idea of import and export in regular JavaScript, so let me show you how it works. I'm going to go ahead and make a new file in our backend for our server. So I'm going to say server.js, and this is the file we're actually going to run when we're making our server. If we want to import the exports from connect.js, all you need to do is make a variable. We'll just call it, let's say, connect for right now, and set it equal to the keyword require, and then pass in the route for that file, which should be just ./connect, just like this. All that this line is doing is making a new variable called connect, and by using this require connect, what we're doing is looking in this connect folder, And we are setting this connect variable equal to the entire module.exports object that we're exporting from connect.js, which is just this object right here with the two functions that we made. Using module.exports and then require statements in Node is the equivalent to using export and import keywords in React, where you normally export a function component and then import it into one of your files at the very top of the page. One of the most important things to note when using require statements is that it actually fully runs the file. So for instance, if I go into our connect.js file, then I go to the very bottom of this page and I just say like console.log hi like this, and then I go ahead and save it, and I save both these folders, and I go ahead and open up our terminal here. Let's open up terminal, and then we can run any file using the node command. So I can say node server.js. Notice how it prints out hi right here. So that's just something to keep in mind, that every time you use the keyword required, you're going to actually run the file that you're importing. Before we continue, there's some packages we're going to want to install. The first one will be Express, which I briefly went over in the first episode. Express allows us to launch our server, and it also allows us to set up what we call middleware, which will allow our front end to communicate with our backend. Open up your console, ensure you're in the backend folder, and then go ahead and type npm install express like this. And we're going to actually want to add one more library as well. There's a library called cors that will need to avoid some annoying errors. So let's add cors to the list, just spelled C-O-R-S, and let's press enter to install these two libraries. And now, just like we can import libraries and packages into our React code using import, we can do the same thing in Node folders by using the require statement once again. So for instance, if I want to import the Express library, all I need to do is make a variable for Express. I'll say const express equals, and then require, and then it's just express like this. Just make sure that whenever you're importing a library or package that you installed, you're not using this // because you're not looking at a file in your directory. Let's also import the cors library we just installed as well by just writing const cors equals require cors, just like this. Before we can set up our Express server and middleware, we need to make one more variable. We need to actually create the Express application, because right now we're just importing it into our code. So to actually create it, it is super simple. It's just one line of code. And all that is const app equals express, just like this. This variable can be named whatever you want, but it's pretty common practice to just name this app because it represents our Express app. This Express that you're seeing right here is simply a function that instantiates our Express app. And now we can interact with our Express app by using this app variable we just declared. So next, let's actually set up and run our Express server. First, we're going to be running the server on our local machine for right now. Because of that, we should specify a port number that we want to use. A port is just a number that you can specify that specifies where your computer is looking for information from the internet. Each computer has access to practically thousands of ports, but one of the most commonly used ones and a common default is just port number 3000. So I'm going to go right under here. I'm going to make a new variable as a constant. I'll say const port equals 3000. Before we actually boot up the server, we should make two quick lines that will help us out later down the road. The first one is app.use, and then inside of this, we're just going to put cors like this. And then right below that, all we're going to do is app.use once again, and we're going to say express.json just like this. So app.use is a function that mounts what we call middleware. Cors is the library we imported just a moment ago and tells Express how to handle sharing resources across different domains. This is important because our front end and back end will be hosted on two separate ports. So without this line here, you'll likely get errors later on when we try to connect our front end and back end together. And then this app.use express.json is just mounting this express.json method, which just tells Express to parse requests in JSON format, which makes it much easier for us to work with. And it makes it so that we don't have to call json.parse every single time we get a request, which makes our lives a lot easier. Now, all we need to do to set up our Express server is call one last method from Express. We can go ahead and go down here, write app, which represents our Express app, and then type .listen just like this. The .listen method is what basically creates our server. A server in the context of web development is just a computer connected to the internet that will listen for incoming requests, and that's exactly what this .listen method is doing, hence how it is creating our server. Now exactly what it is listening for and what it does once it gets a request, I'll get into the next episode, because that's where we'll be writing our backend functionality. For now though, we need to pass in two arguments for this listen to work the way that we want it to. The first one should be the port that we specified, which is just 3000, and that's stored in this port variable here, so we'll write port like this. And then the second argument should be a callback function, which is a function that will run whenever the server is established. So to specify a function, we'll use arrow notation. So we'll do parentheses, our arrow, and then curly brackets, just like this. Notice how the use of callback functions is kind of a common theme in backend development. In this callback function, there's one super important thing that we need to do. When our server is created, we need to run the connect to server function that we created in this connect.js file. Last episode, we wrote all this code to get us connected to Mongo, but inside this listen callback function is where we can actually call that code to hook us up to MongoDB. We've already imported the stuff from our connect folder up top here and stored it in a variable called connect. Therefore, that's how we're going to access the connect to server function. So all we need to do to call this is say connect dot, and then we're going to call the function specifically, which is just connect to server, just like this. This line is just accessing our connect import from connect.js and then calls the connect to server function we specified, which we know from last episode gets us connected to MongoDB. The very last thing I want to do in this listen function here, just so we know it's running correctly, is to write console log, just so we can console log something out here to make sure it's running right. Let's say, actually let's do something like this. I'll say server is running on port, and then we'll do port just like this. Let me quickly summarize all this code right here just so we're 100% on the same page. This app.listen method is telling our local computer, which is where we're hosting our server, to listen to the port 3000, which essentially gives us a connection to the internet. And once it has the connection established, we run this callback function right here, which in our case just calls a connect to server function we made last episode, and then console logs that we're successfully connected to the right port. Let's now have a moment of truth. Let's go ahead and open up our terminal again. And let's actually run this file to see if it actually connects to our server, because in theory, it should. So we'll make sure we're looking at our backend, and then we'll say node server.js to run it. And you can see it prints off hi from our connect folder, which I'll go ahead and actually delete that. Just get out of the way. Let's delete that. But you can see it says server is running on port 3000. The fact that this server is running on port 3000 line got printed out means that this callback function ran just fine, and we didn't get any errors, so it's safe to assume that our server launched without any trouble. Now that we have our server launched and connected to MongoDB, we're going to end this somewhat shorter episode here. In the next episode, we're going to work on configuring Express to make our backend routes, which is where you can write the code to actually create, read, update, and delete stuff from MongoDB. Take care, everyone, and I'll see you in the next one. Hey everyone, and welcome back to the MERN Stack crash course. In this episode, we're going to connect our front end to our backend using Express. Last episode, we left off with the backend code set up to connect to Mongo and spin up the server. But what good is that if we can't interact with our front end code? The next step in the full stack development process is to make what we call middleware, which we can do with Express that allows us to connect front end functionality with backend functionality. So how do we do that? Let me show you. Here in our backend folder, I just made another file called postroutes.js, and I'll explain this naming convention in just a minute. The way that we can connect our front end to our backend is by creating HTTP routes with our backend that our front end can then interact with. I made this little graphic here to help explain this easier. As you might recall from episode 1, the whole purpose of the backend is to receive requests from the front end, process them, and then return a response back to the front end. How we do that is by setting up HTTP routes in our backend. Because these routes are HTTP, they're going to look like URLs that you're used to seeing online. If you'll recall from when we set up our server, we set it up at the URL or HTTP route of HTTP localhost at port 3000. To give our backend functionality where it can process requests and return stuff back to the front end, we can create our own routes that will append to whatever our base route is. For example, let's say I want to write a backend function that retrieves all the users from our database. I might name the route /users. To access this route, we would go to HTTP localhost 3000 /users because that is the base route plus the name of the route we just created. So let's say in the front end, I call the route HTTP localhost port 3000 /users because I want to display all the users on the page. First, the front end sends a request to the backend by calling the routes. The backend then sees this request from the front end and then executes a function that retrieves all the users from Mongo and then returns that in the form of a JSON response to the front end. As another example, let's say I have a route that is meant to create a new user in our database. I might name the route something like /users/create, meaning we could access it by going to our base route, which is localhost 3000 /users/create. Once our route receives this request, it runs a function to create a new user in Mongo, and then returns something saying whether it was successful or not to the front end in JSON format. In general, how the backend works is that it runs persistently, and it waits to receive requests from the front end, calling a particular route. Once it gets a request that matches any of its routes, it will run whatever function is associated with that route and should return its results back to the front end. And then it will continue to run and continue to listen for more requests, which means in a real server environment, it will be running 24/7, always just waiting for a request from the front end. It's also super important to mention that every single backend route should do exactly one thing. If you think of the CRUD operations, create, read, update, and delete, each route should do exactly one of these things. Let's say I want to have 4 routes to interact with users in Mongo. I might have one to create a user, one to retrieve all, one to update, and one to delete. This list here just shows what each of these routes might look like. If I, let's say, had a blog post collection of Mongo, I might make 4 more routes doing the exact same thing, except with our posts in Mongo instead of users. So we may have a route to create a blog post, maybe update a blog post, or delete a blog post. This is how Express fits into the MERN stack. It is the technology that is going to take care of all of this routing for us. Let me quickly summarize everything I just said very concisely. In order to allow the front end to talk to our backend, we need to create HTTP routes in our backend. Each route that we create has a name, which is appended to the end of our base HTTP route. For example, a route that is /users would be appended to the end of HTTP localhost port 3000. Every route is associated with exactly one function, and that function is going to run once that route is requested in the front end. After the function runs, it should return some response back to the front end. The server is running persistently, meaning 24/7, so that it can receive requests at any time and give responses back to the front end. I hope this makes things clear for you, and as we work through creating routes in this video, it should become even more clear. Before we continue, I want to make one very important note. In our front end, we're going to have routing 2 using React Router, which allows us to click between different pages on our website. For example, if our front end is on port 5000, we might have HTTP localhost 5000/home to navigate to our home page. I want to make it very clear that the front end routing is completely separate from the backend routing. They do not coincide at all. Yes, they both use HTTP, which is why they're both in the form of URLs that you're used to seeing online, but they are not related to each other at all. In the context of React, front-end routes return web pages. In the context of Express, what we're talking about in this episode, the backend routes will return JSON data. Now that you hopefully have a basic understanding of how front-end and backend interact with each other, let's use Express to start building our backend routes. As you can see, this file we're in here, I've named postroutes.js. And hopefully now you understand that the reason for naming the file this way is because we're going to make all the routes and functionality for our blog post. Generally, a good way to organize these files is to have one file per collection on MongoDB. So right now, if we go to MongoDB, we know that we just have one collection here, which you know is just called post here. Therefore, we have this postroutes.js file. If I had another connection on Mongo, maybe called like users, I'd want to have a file called user routes or something similar. The first thing we need to do in this file is import Express by writing const express equals require express. Just like we went over last episode, this express variable now allows us to interact with the Express library. Next, because we're wanting to interact with the post and our MongoDB database, it makes sense that we want to get access to our database first. So let's make a new variable called database. I'll just say const database and import the connect file by setting this equal to require./connect. In our connect file, remember that we made this getDB function that just returns our database, and that's exactly why we're importing it here so that we can call that function to get access to the database. And again, just so we're clear, the reason that we can do that is because in the server file we made last episode, we've already run this connect to server, and our server is actually currently running at our terminal here, meaning that this database variable is defined and it'll be stored in database, hence why we can call getDB to go ahead and get it in our other files. The next thing we need to do is create a router object using Express, which allows us to easily create our routes. To do this, let's make a new variable. We'll say let, and we'll call it postroutes, which I will usually just name the name of whatever the file is. And then we want to set it equal to express.router to give us access to the Express router object. You'll see how this router object is used in just a moment. So now let's work on getting our routes actually created. But first, let's stop and think for a second about the routes that we may want in our code. For each collection in MongoDB, I generally recommend that you start with 5 essential routes, which I'll list out here. So I'll have number 1, actually let me comment these. I'll say number 1, number 2, number 3, number 4, and number 5. Number 1 I generally have as retrieve all. Number 2 I have as retrieve 1. Number 3 I have create 1. Number 4 I have update 1. And then number 5, I have delete 1. You can add as many routes as you possibly want, and each one should do exactly one thing. However, I usually recommend for most projects that you have at least functionality for these 5. You may have heard of the term CRUD operations before, and this is exactly what these are. We have create, read, update, and delete. Here, I'm just using the term retrieve synonymously with read. Let's just go in order of these, and I'll show you how to make each route. So for each route that we make, we'll want to access the express router object that we created, which we have stored in this post_routes variable up here. To set up a route, all we need to do is type post_routes.route just like this. And then inside the parentheses, we should specify what we want the actual route to be. There's a couple of different ways to go about naming conventions for routes, but the way I usually handle grabbing all items in a collection is to just make the route equal to the name of the collection. So I'm going to make this one /post just like this. Notice what this is essentially doing is creating a route at this address. It would be http://localhost port 3000 /post just like this. We don't need to specify the localhost 3000 in the parentheses here, so don't worry about that. We just need to focus on what comes after, which is just the /post. Next up, we need to specify what we want to do once this route is requested, which is the function I was mentioning earlier. If you're familiar with HTTP methods, you know there's methods like get, post, delete, and so on. And those same methods are available in Express. When we want to retrieve data from a database, which is the case with this first route, we want to use the get method. So at the end of this route here, let's add .get. Now, all of these route methods like get will take in a function as an argument, and that's where we can specify what exactly it is we want to do once this route is reached. For all the methods we could do, like get, post, delete, or whatever, we always need to pass in exactly two arguments, request and response to this function. So I'm going to add request and response. We'll do our arrow for our arrow function, and then curly brackets to write the function body. This request parameter here allows us to pass in specific arguments whenever we call this route, which we'll go over in just a moment. This response parameter here is the object that is going to be returned to the client once the route action is complete, and we'll mess with the response parameter at the end of this function. So the first thing we need to do is actually grab our database, since we need to interact with it at each one of these routes. So in here, I'll make a new variable. I will say, let's say let db. I'm going to set it equal to database, which is just the import from the connect file, .getDB, so we can get access to our database. And remember, just a reminder, getDB is returning our MongoDB database from this file. Now we need to access the post collection since we want to grab all the posts from MongoDB. To do that, let's just make a new variable to represent the data we're about to get. I'll just say let data. Then we can call it db.collection and then pass the name of our collection here, which is just post, just like this. And now we're looking at the collection name posts. Now, normally with the find function from Mongo, you can pass in an object that represents the parameters or source query for what you're trying to find. However, if you just leave this as an empty object, it will actually return everything in this collection. So this is exactly how we get all the items of a collection, by calling .collection, passing the name, and then call .find with an empty object. Now, one thing to note with Mongo is that whenever you call a function like .find and you're getting back a collection or documents within a collection, it does not by default return them as an array. It returns them in what's called a cursor, which is basically this object that Mongo creates that lets you do whatever you want with it. If you want to actually turn it into an array, you'll have to do that explicitly. Luckily, they make it super easy to do. To turn it into array, the only thing we'll need to add after this is .toArray, just like this, and this will convert the cursor into an array. Since each collection document is an object, this will be an array of objects. These Mongo requests don't always happen instantly, so let's be safe and make this call to Mongo asynchronous. So we'll add the await keyword in front of this whole call. And it's going to give us this error because we didn't define this function as asynchronous. So up top up here, let's go ahead and add the async keyword before our parameters to support the await keyword. This will make sure that our code waits until the data is finished processing before it moves on. Before we return this data to the client, we should do some basic error checking. One thing to note is that with Mongo cursors like we're getting from the find method, even if the collection doesn't exist or there was some error, it'll still return the cursor regardless, and then our code will still turn that into an array. What that means is that if there is an error somewhere in the process, it'll return to us an empty array. There's no context for us where having an empty array would make sense since we're grabbing every single post out of a non-empty collection. So in our code, let's just check for an empty array and throw an error if that happens. So to do that, we'll just say if data.length is greater than 0, and then we'll make a thing here, and then we'll also write an else statement as well. And real quick, let's just worry about the else statement first. What we're going to do is we're going to write throw new error, and then we're going to write an error in here. We're going to write an error message. We're going to say something like data was not found. If we throw an error like this and we don't have a catch block anywhere, it'll actually stop the execution of this program, meaning our server will stop running. You definitely don't want this to happen in production, but while we're building and testing it, we'll want to stop the server if something goes wrong so it's easier to detect and debug. Now, let's look back at our if statement here. If the length of data is greater than 0, means that MongoDB found our data and turned it into an array. So if that's the case, we'll want to return this data to our front end. And there's a really simple way to do that in Express. If we were working with raw HTTP, we'd have to manually write the headers, body, and everything. But with Express, all it takes and all we need to write is just response.json and then pass in our data. I mentioned earlier that every Express route is going to have a request and a response. We don't need to access request on this particular one because there's nothing that we actually need from it. However, this response is how we write stuff back to our front end that called this route in the first place. So by writing response.json and passing in our data, it's doing exactly what it sounds like. It's taking our data that we just got, which is the data from Mongo, turns it into JSON format, and then by putting it in our response object, it'll be returned to the front end. If it helps, think of this response.json line almost like a return statement because it's pretty much the Express equivalent. In case you missed any step of this process of creating this route, let me summarize it all really quickly. So post routes is the router object from Express that actually allows us to create our Express routes. To make a single route, all we need to do is type that object in, which is just post routes, and then call .route, which is where it can pass in the name of our route, which is just /post in our case. Next, we specify that we want this route to be a GET route, which refers to standard HTTP methods like GET, POST, DELETE, etc. Every time we deal with a backend request, we need two arguments. We need request and we need response. The request, which represent the request from the front end, and the response will represent what is being returned to the front end once the backend is done. This entire function here is what is going to get executed once we reach this route right here that we specified as /post. In this particular route, all we're doing is getting access to our database that we made in the connect file, and then we're calling a series of Mongo functions to actually retrieve the data that we want. First, we're accessing the post collection, which is where we're storing all of our blog posts. We're doing find on an empty object, which will return everything, and then we are just converting that to an array. If there is an error, meaning our array is empty, we don't want to return the data to the front end since there was an issue. Instead, we want to actually throw an error. However, assuming there is no error, we can write our result from Mongo into our response object by just calling response.json and then passing in data. If this still doesn't make a ton of sense to you, don't worry. As we make our other routes and proceed to test them in our front end, I promise it'll make more sense. Now we've completed the route to grab all of our posts from MongoDB. In our next episode, we'll focus on testing the routes we're making in this episode. But for now, let's work on getting our other routes created. The next route we're going to work on would just be to retrieve a single route. And just so we don't need to rewrite all this code, a lot of it's going to be similar. So let's actually take it here. I'm going to copy it, and then I'm going to paste it under the retrieve one route here. First things first, we need to change the name of this route so that we don't have two matching get routes. Whenever we want to retrieve a single entry from MongoDB, we're going to want to grab it by its ID, since that's what makes each entry unique. Because of this, we're going to want to specify the ID in the actual route. Now, it'd be nice if we could just write something like /ID. However, that's going to literally interpret as the letters I and D. So to fix this, we can just add a colon in front of this our ID here to make it dynamic. So what this colon actually does with the ID is makes it so that whenever we do a route, let's say we have a route, it's like, we'll say this is HTTP localhost at port 3000 /post. If we have something after the post like 12345, whatever is in this field here, this 12345, will get set equal to this ID. Inside of our function, we'll do the same thing as before with our previous route, where we're grabbing our database using this getDB method. However, for this line here, we're going to need to change this a little bit. Instead of using the find method, let's go ahead and delete all this. And instead of using find, we're going to use find one. So find is used for finding multiple things, whereas find one is just used for finding one thing, which is exactly what we're wanting to do with this route since we're grabbing one post. We need to pass in a query to specify what it is that we want to find. Queries in MongoDB should always be an object, so we'll have this as curly brackets here. And we want to find the object where the ID matches whatever the requested ID was. So we'll make a key in this. Let's say it's _ID. This is how MongoDB actually writes their IDs. And then we'll need to set it equal to this ID parameter up here, which, like I just mentioned a moment ago, is where the ID will be stored in our request. Lucky for us, accessing this is made easy by this request parameter right here, because that's where this ID is going to be stored. To access the ID, all we need to type is just request.params.id like this. And you'll want to make sure that this ID that you're typing in here matches exactly how we named it up here after the colon. If they don't match and I spell it differently, like I did like I capital D or IF or something, that wouldn't detect it because they need to be spelled the exact same. So we'll just make sure it says ID spelled with 2 lowercase letters. Just be sure to always watch out for that. There's one more thing we need to add with this query though. MongoDB stores IDs in what they call object ID, which doesn't get interpreted cleanly in JavaScript, meaning this by itself won't actually work. So we need to actually import a quick function from MongoDB that allows us to translate it into an object ID. All we need to do is go up top here, and we're going to say const object ID. We're going to say require MongoDB dot object ID. And all this is doing is just importing this object ID method from Mongo that allows us to convert a regular string into an object ID that can be compatible with Mongo. And then right here where we're requesting or we're writing request.params.id, all we need to do is just wrap this whole thing in new object ID, just like this. Make sure we have opening and closing parentheses, and we'll wrap it like this, and it should work just fine. One last thing with this route. When we use find in this first route here, it returns a Mongo cursor, which we can then turn into an array. But when we're using find1 down here for just finding one entry, it will actually just return a direct object. So this line here where we're checking data.length isn't going to actually work the same. If we want to check for the object being empty, we'll need to add object.keys wrapped around this data here. What this does is just turns the keys of the object into an array. So basically we're doing the exact same thing as before, but this time we're checking for an empty object instead of an empty array. So it's the same deal though. If the object isn't empty, we'll return that response to the user. Otherwise, if it is, we'll throw this error saying data was not found. Now, this is all we need to have the functionality to grab a single post from MongoDB based on its ID. Next, we need to make a route to create a new post. So let's again take the route we already have here. I'm going to go ahead and copy this, make a space here, and then I'll paste it under where we are creating a route. Now, to create a new entry with a backend route, I typically name my route the exact same as I would if I were retrieving all the entries. So I would just do /post like this, where I just delete the special ID. But now you're probably wondering, wouldn't this cause an issue if we now have 2 routes that have the same name? This one right here is /post, and our one up here is also /post. And no, it actually doesn't, so long as we don't call the same exact method like .get. We're going to instead call post like this. As long as you have different HTTP methods being called, different routes can have the exact same name. And we're going to keep it that way to keep our naming simple. In this create post route, this request parameter is actually going to become very important because whenever we call this route on the front end, we're going to have to pass in an object that will be stored in the request, and then we can use that object to then upload it to MongoDB. Therefore, since we need to upload an object to MongoDB, let's go down here and make an object. I'll just call it, I'll say let Mongo object equals empty object for right now. Next, let's think about what we have in MongoDB. If we go ahead and go up to MongoDB and we look at some of our entry posts here, you can see that each object has a couple of fields. We have ID, title, description, content, author, and date created. Therefore, this Mongo object that we're actually creating in our code should have each one of those fields as well, since this is the object that will be uploaded to MongoDB. But we don't need to specify an ID field because MongoDB will do that automatically for us. So what I'm going to do here is I'm going to make some space for this object. I'm going to make each of those fields besides ID. So we'll have a title field, we will have a description field, content field, author field, and then we will have a date created field just like this. I mentioned just a moment ago that whenever we're calling a route to create something, we pass in the object to our front-end code, and that object is stored inside of request. More specifically, it's stored in request.body. Therefore, assuming the naming conventions in the front-end object match exactly what we're specifying here in the back-end, we can access each one of these properties by just typing request.body and then the name of the property, which in this case would just be title for this first field. And I can do that for each one respectively. I'll take this and I'll just copy it in here for each of these and then just change the names. So we'll say request.body.description, request.body.content, request.body.author, and then request.body.dateCreated like this. This might seem a little confusing right now, but this request.body will make a lot more sense once I show you the front-end implementation of this request. Just know that by making this Mongo object here, we've now made a valid object that can be pushed to MongoDB. The way that we can actually do that is by calling the insert1 method. So I'm going to go down here. I'm going to go ahead and just delete this final that we have right here. And after we find our collection, we can just say .insert1 just like this. And then literally all I need to do is just pass in the object that we want to enter into Mongo, which is just Mongo object. So I'll say insert1 and we'll pass in Mongo object as such. Now, because we're creating something and not retrieving something, we don't actually need to return anything directly to the front end. However, just for the sake of consistency, let's go ahead and just delete all this and we'll still write response.json data just so we can turn whatever happened back to the front end. And that'll actually wrap up our route for inserting a document into post. We've got 2 more routes to go. The next one is updating a single post. Because this request will be very similar to creating a specific route, let's just go ahead and copy this here, go under here, and we'll paste it in. For this route, we're going to keep the same route name. However, we're going to add the ID back in just like we had whenever we fetched an individual post. In the context of updating something, this ID will specify the object that we're trying to update. Except for this route, instead of using .post, we're actually going to use .put. So in terms of what we used so far, .get is typically used when you're retrieving something, .post when you're creating something, and .put when you're updating something. This is in fact an updating route, so we're going to use .put for this one. Similar to what we did in our create post route, we need to make a new object that we can upload to MongoDB. However, instead of using the insert1 method down here, we're actually going to use one called update1. Spelled just like this. And we're actually going to have to format this object right here a little bit differently for the update1 method as opposed to how we have it for the insert1. The big thing we'll need to do is add a $set object inside of this object here, because that's what will be used to find the new values that we need. So what I mean by that when I say that is by basically wrapping this in one big object that has the key of $set just like this. So let's say $set, take all of this, and then paste it inside of here. So we've essentially wrapped all of this inside of an object. I actually deleted a thing on accident. Make sure the curly brackets there. And it should look something like this. So it should look the exact same as the object here. The only difference being that we wrapped it all in this $set. The biggest thing when making these routes, especially when updating and creating something, is that all these fields always remain the same. So we always have title, description, content, author, and date created for both our update route and our creation route, so that the fields and their naming conventions always remain the same and don't change between each entry. And then the last thing we'll need to change is in this update1 method down here. We'll still need to we still need to pass in our object here, our Mongo object, to this function. However, we actually need a first argument before this, and we need to actually use the ID, similar to how we did when we were looking for a single post. So in this one, we had our argument as an object here that had the ID, and we need to do the exact same thing for update1. So we'll just do the exact same thing. We'll make this an object here, separate out the arguments with a comma, and then we'll say _ID is new object ID, and we're going to pass in the same thing we did before. We'll say request.params.id as such. And then same as before, just so our front end can see however the response went, we'll go ahead and write this data into our response and return it to the front end. And just like that, we've successfully just created a route to update a single post from MongoDB. Last but not least, let's make the route to delete a post from MongoDB. We'll again take the route, actually we'll go up here, let's take the route to retrieve a single post because this code is actually going to be very, very similar to deleting something. So we'll go in here, we'll go ahead and paste this like this. And the only big difference here is that instead of calling .get, we're going to instead be calling .delete. And then the only big difference is that instead of calling find1, we can keep the same argument here, but we just need to pass in, instead of find1, we just need to say delete1. And just like with our create and update routes, instead of looking for something here, we're just going to do the same thing where we write our response back to the front end by doing response.json and passing in our data. Now we have successfully created every single one of the routes that we're going to be using for our post collection. The very last thing we need to do in this file is export this whole big routing object here by specifying Module.exports. So at the very bottom of this file, let's just write Module.exports equals, and you want to set it equal to this big post routes object, because that is the object that is storing all these routes that we have just made. So let's go ahead and save this file. And the very last thing we need to do to make these routes accessible to our front end is to mount them, and that's very easy to do. All we need to do is go head over into our server.js file, and you can see here we're already using these app.use method twice, one for cores and one for express.json. This .use method is actually what mounts our middleware, and this is how we'll make our routes accessible. All we need to do for that is to import the routes we just exported from post routes. So we can write const post equals require, and we'll say /post routes, just like this. Now this means that this post variable in our server file will be equal to this entire post routes object that we're exporting from postroutes.js because it contains all of our routing functionality. So right below all these use statements, all we need to do now to actually mount these routes is something super simple. We'll say app.use post, just like this. Now that we've called app.use on these routes, we've made our routes accessible to other parts of our code, meaning when we start delving into React, we'll now be able to access them. And it's important to not skip past this step of calling app.use with your routes on it. If you skip past this step of using app.use and actually mounting the routes you just created, they're actually not going to be available at all because your code isn't going to know that the routes even exist. Just to now show you how our routes are mounted and working, let's go ahead and reboot our server. We'll say node server.js to start our server again. And now let's test our routes on the internet. If you recall that when we hosted this backend, we did it on localhost at port 3000. So I'm going to go to http://localhost at port 3000, just like this. And this page is going to be empty. That's expected, but let's just test one of our routes. Let's to this URL, let's add /post, just like this, which will by default look at a get route, which is going to be the route to retrieve all the posts. Go to this page and notice how we now have this big JSON array that has all of our post data. This is how backend routes work. They don't return web pages, but rather they return data, whatever data we write in the response. Let's test one more route, the route to get a single post. If I go to Mongo here to our collection, I'm just going to look at one of these random IDs. Let's take this one right here, for instance. We'll take this ID. We'll go ahead and copy it. Let's go back here. And then after, or in our URL here, after the post, let's add / and then let's paste in the ID. Press enter, and you can now see that it just returns back to us a single object. In fact, an object that exactly matches this second object here in Mongo we took the ID from. And again, this is exactly how backend routing works. These backend routes can retrieve data for us and do all sorts of things, and then we can access the result of it in the front end by just looking at whatever the URL of the route is, which we were calling the path in the backend. And with that, we're going to go ahead and wrap up this video. In this video, you'll learn all about how we can use Express to create the routes so we can access in the front end, which effectively gives us a bridge between front end and back end. In the next video, we'll actually boot up our front end and test these routes firsthand so you can see exactly how they work. Take care, everyone, and I'll see you in the next one. Hey everyone, and welcome back to the MERN Stack crash course. In this episode, we're going to finally boot up our front end and start with our React code. We'll start by testing out the Express routes we made in the previous episode, and then we'll make functions in our front end that allow us to grab data from MongoDB seamlessly. After our last episode, we ended up having a postroutes.js file that contains all the routes we made, which each represent one thing we can do with MongoDB. We can get all posts, get one post, create a post, update a post, and delete a post. Now that we have all these routes established and we've mounted them in our server.js file using app.use, let's look at how these routes actually come into play in our front end code. To start off, we need to actually launch our front end, which we haven't done yet. So go ahead and open up your terminal first, and let's assure we have our backend server running. So I'm going to cd into our backend folder. Let's just go ahead and start our server up, just what we have in the previous couple of episodes. Once this is up and running, we want to open up a new terminal that we can use to launch the front end without stopping the execution of the backend. To do that in Visual Studio Code, you can click this plus button here, and that'll open up a new instance of the terminal. Next, let's make sure we're looking in our front end folder. We'll say cd front end. And then from here, we can run a simple command to boot up the front end. The command is npm run dev, assuming you use the V installation process that I showed in the second episode. If we go ahead and press enter, it'll boot up the React front end, and it'll generate this link that opens up a page to our React app. So basically, anytime we want to launch the front end from this point onwards, just make sure you're looking in the front end folder, and then you run this npm run dev command. And we can now click this link to open up our web page. If you've created your app with V, this is exactly what it should look like. This is just a template page that came with the creation. When working on the front end stuff, I'll generally split my screen so you can see both the code and the front end at the same time. That way you can see live changes. So I'll just go ahead and open this here, put this on the right, Then let's just drag this a little bit and then close our terminal here, just so we can have both screens showing at the same time. Before we go on, I want to remind you once again that this is not a course for React itself. I have a whole 3-hour course just focused on React that you should watch first if you don't already know React. I'm going to assume you have at least a basic understanding of React as we go through this next part. With that being said, let's go ahead and close these folders here, and let's go ahead and navigate to my front-end folder. So this is the front-end folder that has all of our front-end stuff, where main.jsx is the entry point for the app, and then app.jsx is the page that's actually being rendered, which you're seeing here on the left-hand side. Let's just go ahead and clear out all this boilerplate code here, just so we have an empty page. So I'll just delete this, I'll delete this, and then I'm just delete these two imports from up top. What's nice about front-end stuff when compared to back-end stuff is that it'll update live as you save it, especially if you use Vite. So if I save this file now the page is empty because we've wiped out all the code. Last episode, the first two express routes we made were both get methods. The first one gets all the posts from MongoDB, and the second one just gets a single post from MongoDB based on its ID. Let's start off with these two routes, and let's test them to see if they work in React. If you've messed with data fetching in React before, you know that there's two libraries that are generally most commonly used, and that's Fetch and Axios. Fetch and Axios are the two primary ways we can call backend routes from the front end. Fetch is actually built into JavaScript, while Axios requires you to install it as a package because it's an external library. For this purpose, though, I'm going to use Axios because, in my opinion, it's a bit more straightforward and I like it a little more. So go ahead and open back up your terminal. And we're actually going to open up a third terminal so we don't override the front end of the backend that's running. And then I'm just going to cd into our front end. I'm going to say npm install Axios, type just like this. This will install the Axios library, which we will use to access our routes that we made in Express. Before we do anything fancy in React, let's just test our backend routes inside of this app.jsx file. We know that in React, anytime we want to fetch data, we need to use the useEffect hook. Therefore, let's make sure we import it up top here. Because we already have useState being imported from React, we'll just add a comma, and we'll add useEffect as well. First things first, we'll make a piece of state for our API data. By writing, we'll say const, and we'll name it data with the setter function of setData. And then we'll do that by calling the useState function, and we'll make the default value just empty for right now. Next, let's set up the useEffect hook where we're going to fetch our data. So inside of our component function here, but outside of the return, we're going to write useEffect. And then again, with useEffect, we always need two arguments. The first one is a function. We'll do an arrow function. And the second argument is always an array. And we'll just make sure we have an empty dependency array. I have a whole video on how the useEffect hooks works, but just know that when we're doing data fetching, we'll want to have a useEffect hook with an empty dependency array, because that means it'll run only right when the page first launches, but not on every re-render. And now, just so we can use the async and await keywords, let's define a function inside this useEffect that is asynchronous. So I'll say async function, let's just call it like grab data for right now. Make the brackets for it. And then we want to make sure we call it at the end of our useEffect here. This is standard methodology for writing a data fetching function. You want to declare an async function inside the useEffect and then call it at the very end. Inside this grab data function is where we can now use Axios to retrieve the data from our backend routes. Before we use it, we need to import it into this file. And we can do that by going up top here. And we need to write import Axios, and I probably won't autofill the first time. So let's say import Axios from Axios, just spelled like this. In our grab data function, where we're going to call Axios, let's make a variable to store that response. And we'll actually just call that response. So we'll say const response equals, and here's where we're going to call Axios to fetch the data. Axios has methods that correspond with our typical HTTP methods. We have axios.get, axios.post, axios.put, axios.delete, and so forth. So if, for instance, you want to call a get route with Axios, all we need to do is type axios.get. Inside this axios.get, we want to pass in the route that we specified in our backend. We should keep in mind that when we launched the backend server, we launched in localhost at port 3000. Therefore, if we actually wanted to access the HTTP routes for backend, it would look like a URL like this, http://localhost at port 3000, kind of how I showed you last episode. And again, just to show this in the browser here, I'll copy this link here, paste it in the browser, and this page will be completely empty because that's expected. But if we do /post, something that actually matches one of our routes, you can see it actually will return the data from MongoDB through our backend routes. And again, the reason I'm showing you this is to show you that when you're accessing a backend route from your frontend, like we are here with axios.get, All that our front end is doing is simply just accessing a URL that has some data in it, like over here on the left-hand side. In this example, localhost 3000/post contains our post from MongoDB, and all we need to do to access it is call Axios.get, and then pass in that URL, and it'll get the data for us. Before we test and see if it worked, let's just do two more quick things. The first thing will be to add the await keyword in front of the Axios.get, because these methods do not always occur instantly and could take time, so we want to make sure we have the await keyword. And then all we're going to do right under here is just console log out the response. So console log the response, and let's actually see if it's fetching correctly. Let's go ahead and go back to our front end page. Let's open up the console here, and it looks like it says 404 not found. And that's, oh, I see why. Should probably make this an actual route. So let's add /post to this so we can check the route where we're retrieving all of our posts from MongoDB. So I'll do /post, go ahead and save it. And you can see now we're actually returning an object that has all of our posts in it. If we look in our console here, you can see that this object is basically just the response that we got from Axios. There's a couple of fields here that represent data around the request, but there's only really two fields that I care about right now. First of all, this data field right here is going to contain our actual response that we requested. So this data contains all of our posts from MongoDB. And as you can see, it's an array of objects, just as we would expect. We should also pay attention to this status field right here. Status tells us if the request succeeded or not. A status of 200 tells us that it was successful. There's a whole list of HTTP errors that you can look up, like 404 is a commonly known one, which means not found. There's 400 bad request, and so on. And it's important to check what the status of the request is before you try to do anything. For instance, if we get a 404 error on our route, kind of like we did up here, and then we try to access the data in our React code, that would cause us problems. In light of that, let's actually write an if statement right below where we're capturing our response to make sure that it actually returned correctly. So what we're going to do is, instead of console logging this, let's just say if response.status equals 200, meaning it was successful, then we can set our state. To do that, we can just call setData, which again is the state function made up here. And then we can pass in response.data, because again, if you look at our object here, that is where the data we got back is actually being stored in this data field here, which you can access with response.data. This sets our data state equal to the data we received in our response. Otherwise, if the status is not 200, it likely indicates the request was unsuccessful, therefore we're not going to set our state at all. There's a ton of different ways to handle errors here. This is probably the simplest way that I can think of for right now, just checking the status. There's also things you can do like adding a .catch after this .get here, and then do something like logging the error out and then returning. You can also simulate that same thing by wrapping all of this in a try-catch block. For now, however, we'll stick with this method of just checking the response status. With that being done, if we now go into our JSX down here where we're going to render something on our page, let's just render some code here. We'll say JSON.stringify, and we'll render in the data we got. And again, with React, just make sure if we're going to display an object, we have to use JSON.stringify or else we'll get an error. So I'll go ahead and save this, and voila, you can see all of our MongoDB data is now on our React page. Meaning, in effect, we have essentially successfully connected our front end with our back end. Obviously, we need to add more stuff to make this a fully functioning thing, but we've just shown that the connection is there and it works. So now that we've done that, let's now test all the other routes we've made, like getting a single post or creating a post. Grabbing a single post from MongoDB would be almost the exact same thing, but we would just need to add an ID field to this route here like we specified in our backend routes. If we just go ahead and let's go to MongoDB, and let's go to one of these random posts here, and let's just pick a random ID. For right now, we'll just pick this one. So let's go ahead and copy this ID in here. If I can see it, go ahead and copy that. And then let's go back into our code and let's actually paste it in here. We'll do / and then that ID, because that's the format we specified for our backend routes. Now, if we go ahead and just save this code, let's go back to our page, and you can see now we just have one post instead of all the posts, which is great because we've just verified that both of our get methods are working as intended. If we wanted to test the delete method from our backend, it would work the exact same as this get route, except all we need to do is just replace this .get with .delete like this. That's because if we go and look at our post routes, let me go here real quick, look at our post routes, and we go to the delete one, notice the format for grabbing a single post with this /post/ID here is pretty much the exact same as the one as getting a single post minus the actual method that we're calling. And I don't actually want to delete an entry from MongoDB since we only have 3 to test with, But if I were to save this file right now, it would delete a post from MongoDB. Lastly, we've got our create and update routes. I'm only going to show you create because the only difference between create and update is using .post versus .put for the method. Otherwise, they're exactly the same. So normally to create a post, we should have like some text or input fields that users can type in that allow them to enter in whatever they want. For the sake of testing, however, I'm just going to hard code an object into our program just so I can show you. What I'm going to do now to show you this, I'm going to comment out all of this code right here for the use effect because we won't need it to test this route. I'll make some space up here and I'm going to make just a new function. I'm going to call it create post, just like this. And then what I'm going to do here is down in our JSX, I'm actually going to make a button. So I'll make a button here that will basically just call, whenever it's clicked, it will call this create post method up here. And for our text inside, we'll just say something like create object so we know what the button's doing. Like I said, I'm going to go ahead and hard code an object in that has the same exact fields as our objects in Mongo. So in our create post, I'll just say, let's say let post object equals to an object. And remember we have, I think it's 5 fields, right? We can see it here on this screen. We have the first one is title, second one is description, and then we have content, author, and then date created like this. And let me just fill in some random stuff here. I'll say like, I'm just going to fill in some letters here. B, C, D, and then for this one, we'll just do new date to get the current date. Now that we have the object we want to upload to Mongo, that being this object right here, we can now call Axios.post to go ahead and upload it by accessing our backend route. To do that, all we need to do is type Axios.post like this. And that's again typing the route that we're going to want, which is http://localhost 3000, because that's where our backend is hosted at. And then we know that if we look in our post routes here, the route to create one is also just /post, as long as we're doing a post route. So we'll do it in here and we'll say /post, just like this. However, remember that in this route, we also need to pass in the object that we want to create, because in our backend, when we're creating it, we have this field here that we're referencing called request.body. In Axios, to store things in this request.body field, all we need to do is after we pass in the name here for our post method, is write a comma to specify a second argument, and then we can pass in the object that we want to upload, which in our case is just called post object. And again, what passing this argument allows us to do is in our post routes, we can then access this request.body field, which holds all the data we want to post to MongoDB. There's a couple of different ways we can pass data down through an Axios request. However, this is the way I like to typically go about it and what is probably the easiest way. Let's go ahead and test this out. Let's go in our console here. Let's clear it out so we can know if there's any errors. Let's go in here, make sure this is all fine, which I think it is. Go ahead and save it. And you'll see you have a button that says create object. And now let's test it. Let's go ahead and click create object. Let's check our console. We don't have any errors. So let's go ahead and go to Mongo. Let's refresh this page. And let's see if it actually uploaded to MongoDB. And we can see we now have a 4th object in here down here at the very bottom that has the exact fields that we specified right here in this hard-coded object. And if you notice, it actually gave it its own object ID because Mongo does that by default when we upload. It's titled A, description B, content C, author D, and date created is the current date and time, which is exactly how we specified it right here. And all of this was made possible because we were able to build a proper front-end connection to our backend using Axios to access the routes that we made in the previous episode. Before we move on to another topic, I want to go over something that I usually do to make it a bit easier to work with these routes in the backend. We could just make an Axios request in a use effect every time we want to access the stuff from the backend, but I find it easier to write my own functions that do the Axios stuff for me so that I'm not having to mess with it every single time. So I'm not having to call an Axios.post or Axios.get every single time I want to grab something. What I typically do to mimic this is somewhere in the front end folder, I will create, in the source directory, I'll create a file, I'll call it api.js or something along those lines. And then what I'll do in here is write functions that correspond to each one of the routes that we have and each Axios method that we could call. So for example, I'll write a function to get all of our posts. I'll say export async function, get posts, just like this. And I would do the same for each of our other routes. So let's copy and paste this 1, 2, 3, 4 times. And then we'll have one to get a single post. We'll have one to create a post. We'll have one to update a post. And then we will also have one to delete a post, just like this. Note that for some of these, we're going to need arguments to pass in. For example, get post, update post, and delete post are all going to need IDs, which is the ID of the post in question of whatever we're interacting with. So we can make an ID parameter for each of these. We'll say ID, ID, and ID. And then we know for create post and update post that we're going to need an object that represents whatever we're uploading or updating. So let's just go ahead and make an argument in each of these called post. We'll say post, and the update will separate it by commas, and we'll say post for this one as well. And then what I will do is fill the contents of each of these functions with the logic from Axios. This way, if we want to say, let's grab a single post in our React code, all we need to do is call this get post function and pass in an ID, and it'll handle all the functionality for us without us having to write all the Axios logic each time. I just spent the last few minutes showing you how to use Axios, so I'll run through these functions fairly quickly. First thing, obviously, is making sure we import Axios at the top here. So import Axios from Axios. For our get post method, we can just do what we did before. We'll say const response equals axios.get. We'll actually make sure to add the await here. And then in this file, instead of hard coding a URL into every Axios request, what I would usually do is make a variable that represents your URL. And you can just use that variable in all your requests. Because if you ever deploy your app anywhere besides localhost, we want to avoid having to go in here and manually changing every single URL. So what I'll do in here is I'll just go to the top here and I'll just say const URL, and I'll just make wherever our backend is hosted on, which is http://localhost at port 3000. And I don't remember if I've shown you this yet, but if you want to access variables inside of strings in JavaScript, you can go ahead and use the backtick character, which is the one right above your tab key on your keyboard. This treats it as a normal string. However, if you add this $sign plus curly brackets, you can inject direct JavaScript into the string. So for this post, we'll just pass in the URL first, and then we'll want to write the corresponding backend path for this route, which would just be /post, just like this. When this line actually runs, we have our URL variable set to this URL up here, and then we have /post. So what this line is actually getting is just, what this line is actually getting is just what we're getting before, like this. This is just a cleaner way of writing it where we're storing the URL as a constant variable. If the request was successful, it will have returned a 200 status code. So we'll do what we did before, and we'll say something like if response.status equals 200, then we want to return the data it gave back, which is just stored in response.data. So I'll say return response.data, just like this. And then otherwise, so let's write an else statement, meaning it was something other than 200. Let's just return without actually returning any data. So we'll just return empty. Again, like I said before, there's like a million different ways you can do error handling with data fetching. And there's definitely a more sophisticated way to go about it than doing this. But this is what we're going to do for right now, because if it's just successful, we'll want to return the data. And if it's not, we'll return nothing. And then in our React code, we'll just quickly check if the return has anything in it. That's what we'll do for our get methods. Now let's move on to this get post function. I'm actually going to copy this and paste it in here because the functionality is almost the exact same. The only difference is going to be the path that we're actually accessing. So we'll need to change this path inside of the get. We're still accessing the same URL, and we're also accessing /post. But remember, when we're getting a single post, we need its ID, which we have as a parameter right here. Therefore, after our /post, we can add another slash and then do another $sign curly brackets to inject direct JavaScript. And then we can add ID in here just like this. That way, if our ID is, let's say 12345, this route would essentially be getting HTTP localhost 3000 /post /12345. That's what this path right here is doing. And then we'll go ahead and keep this same code down here because on this get post, it'll just be returning a JSON object that we can use in the front end. And then let's go ahead and work on our, delete post. Let's skip down at the bottom here. Delete post, like I've mentioned a couple of times now, is almost identical to this get post. The only main difference being the method that we're calling. Obviously, if we're deleting something, we'll want to use axios.delete, not axios.get. So let's just change this to delete. So when we're deleting, creating, or updating stuff in our database, we don't necessarily need to return anything because we're not actually retrieving any data and giving it back to the front end. However, just so we can check and see the outcome of our methods, let's just erase all this, and I'm just going to return response like this. And the only reason I'm going to return response is that so when we go back to the front end, we can quickly go and check to make sure the status is 200 or see if it's like a 400 for an error to make sure that it actually went through all the way. Otherwise, we know there's a problem. Next, let's work on our create post and update post. So for create post, I'm going to take this same code here, just go ahead and copy it, and let's paste it in here. We know for this create field, we're not going to need the ID. So let's go ahead and just delete the ID off here. And then since we're using a create method, we want to use .post instead of .delete. So we'll say .post. And I'll go ahead and just delete this here so we know we're looking at just /posts. And we also know that whenever we're calling post, we need to pass in the object that we're wanting to create in Mongo. So let's go ahead and in this Axios request here, write a comma to make our second argument, which will be our blog post object, which we're just storing as this post argument right here. So to do that, we can just say comma and then put in post. So basically, whenever we call this create post, we'll want to pass in the object we want to create in Mongo. And then using this function right here, that gets sent to our backend using this post request. When this gets sent to the backend, this post object that we're passing in here gets stored in this field called request.body. So hopefully now it makes sense why when we first created our backend route to actually create something, we access every single one of these fields from request.body. The idea is that this post object in our API file should have the exact same fields as what we're specifying in our backend here. Hence why you can do something like request.body.title, request.body.description, because these fields all match the fields that we mentioned in our backend. We'll just have to be sure that whenever we're actually creating the objects and we're calling this create post, that the fields do match exactly. Otherwise, there's going to be discrepancies in Mongo. Lastly, let's finish with update post, because that's going to look almost identical to create post. But we're just going to use .put instead of .post. So let's go ahead and just take this code here. I'm going to go ahead and copy it. And it's right here. Go ahead and paste it in here. And then we'll know that this update post will require an ID, just like delete post and get post. So this should be like an ID here, like 1, 2, 3, 4, 5. I'll do that just to show you. And then we know the method should be .put instead of .post since we're updating something, not creating something. And because we'll need the ID back in the route, let's go over here. And just like we did with the get method right here, we'll add the ID to the end of the route. So we'll look at here, we'll say $$ brackets to inject JavaScript, and then we'll pass an ID because that's one of the arguments we're passing in here. And then the rest of this code will remain the same. Now we've completed all the functions in here that we're going to be using for right now. To summarize, remember that we have routes in our backend that all do one specific task, like getting all the posts, creating a post, updating a post, etc. We can use something like Axios to fetch or call these routes essentially, which is exactly what we're doing in this file. We have a function for each particular Axios call, which calls one specific route from the backend. Like this function here calls our get all routes. This function here calls just our get a single route. This function here calls a route to create, and you get the picture. Now, let me show you how we can easily call these functions from the front end. Let's go ahead and navigate back to app.jsx. I'm going to comment out this function for right now because we'll use it in a second. I'm going to uncomment useEffect, comment it, and let's just delete all this stuff just so we can start fresh. I'll actually delete this as well. Let's first test the method to get all of our posts from MongoDB. We'll make a function in here. We'll say async function. Let's just call it load all posts or something like this. And then we'll write it like this. Make sure we call it at the end here. And then let's import all the functions from our API file that we just created, just so we can have all of them ready to use. So we'll actually delete this Axios import because we won't need it in this file. Let's say import get post. And let's add comments here. Get post. We have create post, update post, and delete post. So now we have all of these functions now imported in app.jsx. Now, all we need to do in this function here where we're actually loading all our posts is just call the function we just made. So I'll say something like let data equals await get post, just like this. We know that this get post method here is going to return the post if it was successful and nothing otherwise. So let's do a statement here. We'll just say if data, and then we can set some sort of state. So let's make a piece of state up here. Let's call it, instead of data and set data, let's do set post, post, and then we'll do set post. And then we'll just keep the use state empty right here, just so the default value of post is null. Inside this if statement here, meaning our data came back correctly from our function, we can go ahead and set the state. By doing that, we can just say set post data like this. If it didn't come back successful, then for right now, we won't do anything because we would just be setting our post to be empty or null. and is already empty when it's initialized, so there's not much point in really checking for that. Now, finally, in our JSX, just to show you on the page, like we were doing before, let's just stringify this whole thing. We'll say json.stringify, and we'll pass in our post state. Let's go back to our front end page here before you save it. Let's go ahead and make sure this console's cleared out. And let's go ahead and save this right now. And you'll see we're displaying all of our posts from MongoDB. You can see that we now have a page that contains all of our posts in it, which means we've effectively taken information from MongoDB and gotten it all the way into our React application. Meaning after 5 episodes now, we are now able in React code to call functions from a separate backend server that will then access database information stored anywhere in the world in the cloud. Pretty cool stuff. Just for the sake of testing, let's test our, let's say our create post method from right here. So we've already imported it into our app.jsx file. I'm going to go ahead and comment out this whole use effect here. And then let's, like we were doing before, let's just make a button that is going, to just call this function up here, this create post. So let's say on click, we want to call create post just like this. And we'll say create post just like this. And all we're going to do in this function now is instead of calling axios.post, we'll call the function that we just made, which is, as we can see, create post. And we need to make sure we pass in a post object that we want to upload to Mongo. So we'll just say create post, and we'll pass in the post object we just made. And just so it's slightly different than the one before, let's just change this like Z here, X, Y. This will be just A again, like this. And then we'll go ahead and save this file here. Let's go ahead and click create post. It says there is a maximum call stack size exceeded. Oh, and that's, I think, actually because our create post is the same name as this function here. So let's just call this one like make post or something, just so it's not redundant. Let's clear this out here. I think that should be the error. Let's save it again, click it, and let's see, we have another error here. Oh, and that's actually because I forgot to change the name here. And just to make post, and let's finally test it and see if this one works. Let's save this file, click create post. Hopefully, okay, there's no errors this time. That's a good thing. Let's go into Mongo. Let's go ahead and save it. And let's see if it created a post. You can see it says out of 5. And down here at the very bottom, you can see it just created a new post, just like we specified right up here. So hopefully now you have a good idea of why I wrote these separate functions like create post or just get post, because I think it actually makes it a lot more convenient if you have those functions in their own separate file, because these contain all the Axios logic. So that way we're not having to write, axios.get, axios.post all in our React code. It'll just be in a separate function. And all we need to do to call it is just import that function, and then it can do whatever functionality we want it to do. There are a lot of moving parts to where we've gotten so far in this series. So let me do a very quick review before we end this episode of everything we have done so far and how it has led us to this point. So first, as you know, we set up our MongoDB database and our collection that we called post so we can store data. We named the database itself blog data, and then the collection is just named posts. Each item in this collection will represent one blog post object. Then we started with our backend folder, and we messed with these connect.js files and the server.js file. And what these do is basically handle all of our backend functionality by connecting to MongoDB and then running and spinning our server. And then what we did last episode is make this post routes file here, where we make one route for each specific task that we want to do. So we can go ahead and get all the posts from Mongo, we can create something in Mongo, delete something from Mongo, and so forth. In our front end, we have this file called api.js. And in this file, we have functions that can interact with these routes and our post routes by using a fetching library like Axios. And these are all one-to-one. So for each function in here, there is a corresponding route in our backend. So again, post routes is in our backend, API is in our front end, and how we're connecting the two of them is by using these routes. Then in our React code, which would be something like app.jsx, we can then import these functions we made that will interact with our backend, and then we can call them as we please to do things like creating an object from our React page or just getting all the objects and displaying them on our React page. If there's something you're not confident on or you're still confused about the way this is all set up, feel free to rewind any of these videos or otherwise leave a comment and I'll try to get back to you as soon as I can to help you out. Now that we've got all the foundations of our app built, in our next video we will use React to truly start building out the web app. Thanks for watching everyone, and I'll see you in the next one. Hey everyone, and welcome back to the MERN Stack crash course. Last episode, we left off having created all the functions in our API.js file that allow us to interact with our backend and do things like pull blog posts from MongoDB, add posts, delete posts, and so forth. Now that we have all these functions, we'll easily be able to call them in our React code as needed. And we were also able to test all these functions so we know that they work just fine. In this episode, we're going to be building out the front end of our application, which means getting our React router set up and getting all of our blog pages made. I'm going to be doing extremely minimal CSS and styling in this episode because we'll have a full episode for making our web app look pretty. Since we're talking about front end, we need to think about how we want our web pages to look like and the functionality we're going to want the user to have. So let's start off by doing some quick brainstorming on some pages we may want in our application. And remember, this project in particular is going to be a blog website, so that's a huge consideration into how our site should look and what it should do. In our app.jsx file, which is the entry point for our front end, I'm going to go ahead and just delete all this testing stuff we messed with last episode, so I can just go ahead and get rid of all this here. I'm going to go ahead and delete everything within this return here, and I'll actually go ahead and delete these imports here too, so we can start off fresh. And then in this component here, I'm just going to make a comment. I'm going to say pages. And now here, we can just brainstorm some pages that we actually want for our website. So let's think about this. When the user first gets to the site, they should be met with a login page where they can log in to access the rest of the site. They should also be able to make a new account to log in if they haven't already made one on this page. For the sake of simplicity, let's just call this a landing page. Next, let's think about what the home page or the main page should look like. On most basic blog sites, the main page or the home page is just a display of all the blog posts, usually filtered by recency or something along those lines. So for this page, we'll call this the home page, and we'll just say something like filtered by recency since we're talking about blog posts. In a lot of apps where there's no dedicated login page, the landing page is the home page. Think about YouTube, for example. Whether you're logged in or not on YouTube, the home page is still going to be the first page you get to. However, in our app, just so I can show you how login works on its own, we're going to separate them out into landing page and home page. On this homepage where we have a list of blogs, the user should be able to click on any blog they actually want to read. When the user clicks on a particular blog title, it should take them to a page where they can read that whole blog, whichever blog that may be. So we'll have our own page for reading this blog. We'll just call this, for right now, we'll just say a ReadBlog Page. And while we're on the topic of reading individual blog posts, we know we're going to also need a page to create new blog posts. So we'll make a page for that. We'll just call it a CreateBlog Page. And because we're eventually going to add user logins and user information, let's actually make a profile page as well, where a user can see the blogs they've posted and can see other things pertaining to their profile. And then just for the sake of imitating what I'll call, a customer-friendly web app, let's have two more pages. Let's say like an About Us page and then a contact page. All in all, this gives us 7 pages. A landing page, a home page where all the most recent blogs are displayed, a page to read each particular blog, a page to create a new blog, a page for your user profile, and then we have an About Us page and a contact page. So now we have 7 pages, and we know that each one of these 7 pages should be in their own JSX file. So let's actually take each of these pages we want and actually turn them into JSX files. So I'm actually going to go here in my file directory in my front end folder, and I'm going to create a new folder for right now, and I'll just call it pages. And then I'm going to make 7 files, one for each of the pages that we have. So I'll go in here, new file, and I'll do this for each one. We'll have landing.jsx, home.jsx, we had readblog.jsx, createblog.jsx, and then the last 3 we had profile, and then we had an about us and a contact. So let's say about.jsx, and then we will also say contact.jsx. We want them all as JSX files because each page is going to be a React component. Off camera, just to save a little bit of time, I filled each of these pages with a basic skeleton component, where I just define its name and then return a div that says the name of the page. We'll worry about filling in the specific contents of these files in just a little bit. Before we do that, we'll want to set up our routing so that we can navigate between these pages that we just made. If you've watched my React course, you know that to make multiple pages in a React app, we need to use the library React Router DOM in order to build the routing scheme. To do this, to get this React Router DOM library, open up your terminal, go ahead and cd into your front-end folder, and then just run the command npm I or npm install and say react-router-dom, and then this will install the React Router DOM package. Once you've installed that package, let's go ahead and head back into app.jsx, where we're rendering the main part of our app. This is the file we're going to use to set up our routes, and this is typically the norm. At the top of this page, there's a few imports that we're going to need for this file, particularly from React Router DOM. We need to import a few things. We need to import, first of all, something called hash router, something called routes, and something called route. And this should all be from React Router DOM. And we'll have to put this in quotes here, just like this. Just to make this hash router easier to represent, let's write as router here so that we can use the alias router to represent hash router. You'll see how each of these three imports comes into play in just a second. Next, we need to import all the pages we want to use. We have 7 pages, so we need to import all 7 of those pages. We'll have to do each of those one by one. So let's go in order of the pages that we see on the left-hand side. So we'll say import about, and all of these should autofill, so you shouldn't have to type them out individually. We'll do import contact, import create blog. This is a little bit tedious, but luckily this is the only time we'll have to do this. So we'll say import home, import landing, import profile, and then lastly, we're going to import ReadBlog, just like this. The next thing we need to do is go down into our return statement here, and we need to wrap our entire app in this router component that we just imported from React Router DOM. This router component, which again is this hash router right here that we're representing with the word router, is basically just a component that allows us to use URLs within our app to navigate between pages. Inside of router, we need to do a routes like this and make sure we have both an opening and a closing one. And this is the second import from React Router DOM. And writing this here tells it that we're about to give it some routes. And then for each individual route that we want, we can render a route component, but we can just do it as a self-closing tag by using this /. We're going to have one of these individual route components for all 7 of our pages. Each of these route components requires 2 arguments or props basically. The first argument is path, which specifies the URL path at which we want to access this route. And the second argument is element, which is the component we want to render at this route. For example, let's say I want to make a route for our landing page. What I could do is type in something like path equals, and for this path, I might just say something like /landing. And then I would say something for the elements. This would actually be JavaScript, and I would pass in our landing component as if we were rendering it. So what does this route here actually mean? Well, what it means is that if I were to go to a URL for our app, and let's say it's like HTTP localhost like 5173 or something. Just making up something random here. Let's say 5173. And I went to something like /landing like this. I have just specified /landing as the path. And once we reach that path, we're going to render this element, which is our landing page. Let's now do the same process for our other 6 pages. And to speed this up, I can just copy this and I'm going to paste it 6 times. So 1, 2, 3, 4, 5, 6. And now we'll have a route for each one of our 7 pages. But let's change these around to make sure they match accordingly. So let's think. We have a home page, and that the path for the home page we can just say is /home. And at that path, we'll obviously want to render our actual home page component. For this next path, let's say we'll do our CreateBlog. And for that, we'll obviously want to render the CreateBlog component. For ReadBlog, same thing, ReadBlog component. And hopefully you're getting the picture here. Basically, we're just making our own path name, whatever path name we want, and we want to specify what component we want to render at that corresponding path. So for this next one, let's see, we need profile, and we're going to render the profile component at the, let's say, about us page. Let's do /about. We'll render the about page, and then lastly, our contact page will be /contact, and we will render the contact component. Again, each one of these paths refers to a specific URL path on our website, just like this up here. Once that particular path is reached, we want to render a certain component. We want to make sure all of our paths and our corresponding elements match each other. So whenever we hit the landing path, we want to render the landing page. Whenever we hit the home path, we want to render the home page. And hopefully you get the picture. Now we've effectively created 7 routes for a React app, 1 for each of the 7 pages we're going to have on our site. One quick thing. If you want to specify the default route for your website, meaning the route that users are taken to whenever they first type in your URL, the path for that route should just be a / with nothing after it. Because we want our landing page to be our first route, let's actually change this from /landing to just be a / so that users are automatically directed here. What this means is that if somebody typed in our base URL, if it hosted at this localhost port, and it was just like this, then it would say that it is an empty path, so it would take us to the landing page, and that's exactly what we want for this behavior. Now, let me test out these routes so I can show you how they work. So let's actually launch our front end so I can show you. And remember, to launch our front end, we need to make sure we go into our terminal here. So open up our terminal, make sure we're looking in the front end folder, and then run the command npm run dev, and then press enter. And that will generate a link for us to actually open up our website. If we go ahead and hold down Control and then open up the link, it'll take us to our page here. And I'll actually go ahead and readjust these folders here so that we can get this looking correct. And I'll go ahead and shrink this down here and close down our terminal to make a little more space. For right now, we're going to manually test our routes using this URL up here at the top. When using routes with HashRouter, we actually need to use a hashtag or pound symbol in here. So I'm going to go ahead and add that in here, and then we can add whatever path we want after that. Whenever we get into using link buttons later on, it'll do that automatically for us, because obviously we don't want users to have to type in the URL bar. If we just have no route here in the URL, we can see that we're looking at the landing page because that's what we specified over here as our default route. If right here I typed /home, you can see now it would take us to the home page. If I went /profile, now we're on the profile page, and hopefully you get the picture. Because in the app we specify each particular route, where the element is the element prop is the component we want to render, and then the path prop is the path we want to render that component at. So for example, for this home route here, we said the path is /home and the element is the home component. Therefore, that's why when we go to the /home route here, it renders the homepage component. This makes it super easy for us to add pages and see how the pages work. Before we move on, we should add something to our ReadBlog route right here. Keep in mind that every individual blog post we have will have a link to their own unique post page where users can read that blog post. Right now, however, I can show you, if I just go to the ReadBlog page, we're just going to one page that isn't unique to anything. And if we were to try and implement it right now, every time a link is clicked, it would take us to this one singular page, which is not what we actually want. An easy way we can differentiate each post is to put that particular post ID within this path itself. This will allow us to use the ID to show each post uniquely, and the easy way to add an ID in the path is just to write /:, and then whatever you want the ID name to be, which I'll just name ID, right after the initial path. Now, whatever comes after this colon here will be stored in this ID variable, which we'll be able to access on that page. And you'll see why this becomes important later down the road. We saw a very, very similar concept when we were working with our backend routes. So for example, if I were to go in here for ReadBlog and I were to go ReadBlog /12345, this 12345 is now equal to this ID right here. And you see it actually is not rendering our page anymore because it's going to tell us there's an error because we haven't specified any ID yet. So I'm going to go ahead and just take this away. Let's go ahead and go back to our home page and make sure this file is saved. Let's think about what we want next. It doesn't make a lot of sense to require users to type in the path of the page you want to go to in this URL bar. Like if I'm a user, I don't want to say, oh, I want to go to the home page. Let me just type in /home. That doesn't really make a whole lot of sense. Ideally, we'd have buttons on our website that users can click that allow them to navigate between different pages. This can be done through a Navbar, which is a simple menu usually at the top of the page that has links to all the different pages you can visit, which essentially every modern website has in some way, shape, or form. I've gone over how to make a Navbar in my React course, but now I'll go over it in a quicker fashion so we can get started with the more important stuff, like actually filling out the content of our pages. The first thing we need to do to make a functional Navbar is to actually make two components. And before I make the components themselves, I'll actually make a dedicated components folder to store them. So I'm going to go in our front end here. I'm going to go new folder. And I'm just going to name this folder just components just to make it easy. And then in this folder, I want to make two components. The first component should be the Navbar itself. So I'll say, we'll name it navbar.jsx because these should be React components. And then the next one will be one called layout.jsx, which will represent the layout of the site. And both of these components will quickly write the skeleton component. So for Navbar, I'll say export function Navbar, and then we'll just return an empty div for right now. I'll do the same in layout. I'll say export function layout, and then we'll do the same thing. We'll return just an empty JSX div. In this layout file, we need to import two things to make this file work the way we intend it. The first one is the Navbar component we just created, so we'll import that first. I'll say import navbar. And then the second is a React Router DOM component called outlet. So I'll go ahead and import that next. We'll say import outlet from React Router DOM. And then all we need to do in this layout file is pretty simple. We need to render the navbar, and then right under that, we need to render the outlet. And that's it for this file. I go into a really detailed explanation of how this whole layout file works, plus this whole outlet thing works in my React specific course. But basically, long story short, outlet is something we can use with parent routes that allows us to render child routes. Right now, we just have in our app.jsx file, we just have 7 routes that aren't parents or children of each other. But that will change when we add the navbar. And what this outlet allows us to do is render our navbar in whichever pages that we want. And the whole main reason why we're doing this is because there's some pages like the landing page that we don't want the navbar to display on. So now that we're done in this file, let's save it and let's head into our navbar component and work on getting it set up. One of the first things I want to do is import the link component from React Router DOM. So we'll say import link from React Router DOM. This link component here basically acts as a button that we can click to navigate between the routes that we've made. So it's super important if we're wanting to create a navbar for our pages. Next, what we want to do is create links for each of our pages, -2 of them. It wouldn't make sense to create a link for the landing page in our navbar, and it also wouldn't make sense for the ReadBlog page to be up there as well, considering that page should get activated whenever we click on a particular blog, not from the navbar. That means we need 5 links for the other 5 pages. There are a couple of ways we can do this. The first way would just be writing all the links in this file, one for each page, just like this. I could say, a link for the home page. I would do a link for the profile page, a link for the CreateBlog page, and so forth. The second method would be to extract the page info into another file and just map over it. Each of these 5 links that we're going to make will have the exact same format, so let's actually go with the second option, because we'll avoid duplicate code with this method, which will require us not to have to write, link over and over and over again. Plus, you'll thank yourself later if you want to add more pages because it'll make it easier. If I go with this method of extracting data into another file, usually how I do it is I go into our components folder here and I'll make a new file. I will call it pagedata.js. And this isn't going to be a React component, just a JavaScript file. That's why it's .js and not JSX. And all we're going to do in this file is make an array of objects, where each object represents the information for one page. And then once we go back to our navbar, we'll just map over this array and render a link for each one. So let's go ahead and close this, head back to our pagedata.js page, and we'll want to export this array here to our navbar file. So let's write export const, and we'll just call it the same name as the file. We'll say pagedata equals, and we want it to be an array. Oops, missed the equals there. And it'll be an array just like this. We know we're going to want 5 pages, hence we're going to need 5 objects. So let's use curly brackets to denote the first object, and then we need to give it 2 properties. We can give it more than that, but 2 is what we're going to stick with for right now, because that's all we're going to need essentially. It'll be name, and it'll also be path. The name will be the text we show on the button itself, and the path will be the URL we want to navigate us to. So we'll want to make sure this path here matches exactly how we specified it when we first made our routes in app.jsx. So for example, for our home page, we want it to be named home, just like this, and we would want the path to be /home. And because we're going to want an object for each one of our pages, let's actually just copy this here, comma, let's copy it, and let's make one of these for each one of our pages. For this next one, we'll say its name will be CreateBlog, because that's what we want to display in our navbar. And this path should be CreateBlog, again, matching the routes we made in app.jsx. This one will say just the profile page, and that's /profile. This one right here will say about us, and that will be /about. And then the last one will be named contact, and that path is obviously just /contact. And that's actually all we need to do in this file, because all we're doing is just containing the information for our page routes. So let's actually go now back to our navbar.jsx file, and we can now take this information and map over it. The first thing we'll need to do is import the data we just created in that file. So let's say import page data from the page data file. And then all we need to do is actually really simple. We'll go in here, we'll use curly brackets to know that we're using a JavaScript expression, and let's map over this array that we just imported. So to do that, we'll say pagedata.map. And then for each page, we're going to want to, for each page, we're going to want to return something. And we'll make sure we have our return statement here so it can return some JSX for each page that we have. And now here's where we can specify what we want each button on the navbar to look like. For one, each button should be a link component from React Router DOM because they should each link to a page. Therefore, let's make this outer level component here, this outer level div here. We will make that a link. Each link needs to have a to prop that specifies where we want the link to lead to. Lucky for us, we already specified the path to each link within the objects that we just made because each object has a property called a path. So that means it's stored in what we call page.path. So inside the link here, we can say to, and we'll say page.path just like this. When we're mapping over page data, this page object here is set equal to each individual object in our page data file. And each object has a property name and path, hence why we're able to say page.path and it'll work. Inside each link, let's actually render a button component just so we can get some of the automatic button styling from JSX. We'll do button like this, and the button should have the name of whatever page we're clicking to. So therefore, we use curly brackets, and we just want to say page.name, again accessing one of the properties of the object because it has the properties name and path for each one. So if we want to get the name of it to display on the button itself, we can just say page.name. And this is actually all we need functionality-wise to get our navbar to work. But before we add our navbar into app.jsx to actually render it into our app, let's add some quick CSS just to put it on the top of the screen and make the buttons look at least somewhat decent. I'm actually going to wrap this entire return here in a actual div. And then I'm going to give this a class name. Class name is how we do CSS in React. I'll say class name equals, let's just call this navbar. And then for each particular link, which represents each button on our navbar, I'm going to make another class name for CSS that I'm just going to call nav item. Now that we have these class names, let's actually access our CSS file. When we first made the project with V, it put all the CSS into this app.css file. So let's go ahead and navigate to here. Let's go to the bottom and let's add a property for each class name we just made. So we said our first one was navbar, and the other one we had was nav item. Again, I'm just doing super minimal CSS for this episode because we'll have our own episode dedicated towards that. But for now, let's think about what we want to be super minimalistic. So we want it to be fixed at the very top of the screen. And let's just say for right now, we want the navbar to cover, let's say 50% of the screen. To do that is pretty easy. Let's just say position is going to be fixed. We will say top is 0, and let's say width 50%. This will make sure the navbar stays fixed, is at the very top of the page, and takes up 50% of the screen width. Let's actually now center it as well. 50% of the width is covered by the navbar, meaning that if we did a property like this, we said left 25%, that will actually center it since this sets the left margin 25%. I also want the nav buttons in this navbar to be evenly spaced out as well as possible. To do this, we can just add a few more properties. We'll say display flex, and then we can just add justify content will be space between. This is all we'll need to do with the navbar class for now. And then for the nav item, let's just do a couple of things. Let's give each one some like padding and margins. So we'll say padding for it will be 4 pixels. Let's say margins also 4 pixels. Let's make the buttons white. We'll say color white. Border style, let's do a solid border just so we can give them a little outline. Let's make each border 2 pixels wide. So we'll say border width is 2 pixels. And then the last thing I want to do is just make sure each button is rounded a little bit to make it look a little nicer. We can round each button by saying border radius. Let's do 4 pixels for right now. And this is just some super basic CSS, which like I said, we'll add a lot more of down the road. But for right now, we'll keep it at this. So we'll go ahead and save the file. We spent the last few minutes getting our navbar and site layout all set up. So now let's actually get it added into our code, which is actually pretty simple. In our app.jsx page, let's scroll to the top and let's import the 2 components we just made. The first one was the navbar, and then the second one was the layout. And then here's how this site layout is going to come into play. We know we aren't going to want the navbar to be displayed on the landing page. We only want it to display once the user logs in and is on the site. Therefore, this landing page here should be its own route. However, this is where the outlet we made earlier in the site layout, and let me show here, this is where the outlet here will actually come into play. All pages that would like to have a navbar on it, like the home page, contact page, etc., should now all be made child routes of this layout component, meaning they'll get rendered as this outlet here. And I'll show you exactly how to do that. So let's head back to our app.jsx page, shrink this, and let's look back at these routes here. We need to make another route under our landing route, except this time we need to give it both an opening and a closing tag. And for this route, we don't need to specify a path for this route, just an element. So we can say element equals, and we want this element to actually be the layout component that we just made. And then all of the pages that we want a navbar on will get nested in between these tags. We want a navbar on all of these pages down here. So let's actually cut and paste these routes inside of this layout route here. Now what we have is the landing page route on its own entirely. And then we have a parent component, which is the layout, which contains the navbar, and then all its child components are all our other routes, meaning in effect that the navbar is only present on pages that are children of this layout route. If you want a more detailed explanation on how this works, check out my video on routing as part of my React course, which I'll link in the description. To get the moment of truth, let's go ahead and Control S to save this file. And you'll see some buttons actually appear at the top of our screen, and this is the navbar we just created. Honestly, it looks pretty ugly, but it'll do for right now. Let's run some testing to ensure this new navbar works the way that we intended to. Let's actually go back to our landing page. Let's go /here, just so we can look at our landing page. And you can see on our landing page, we actually have no navbar, which is exactly what we want. Then let's navigate to homepage, so we'll go /home, and now the navbar reappeared. We'll take care of jumping between our landing page and homepage once we get our user login stuff done. Here on our homepage, you can see we have our navbar with the 5 buttons on it for each of the pages we want to navigate to. I can click between these buttons and now navigate to whichever page that I want. Notice how each time I click the button, it's actually changing my URL path up here, which is being done by the link component from React Router DOM that we used in the navbar. Now that we've tested this, we can see that we have got a fully functional navbar. Again, it doesn't look super pretty, but we'll worry about that later down the road when you do our styling and CSS episode. And that's where we're going to end this episode. In this episode, we figured out the page structure we're going to use for our front end, and we created template files for each of those pages. We've also got all of our routes set up with React Router and made a functional navbar that allows us to navigate between all of our pages. In the next episode, we'll focus on filling out each of these individual pages. Take care, everyone, and I'll see you in the next one. Hey everyone, and welcome back to the MERN Stack crash course. In this episode, we're going to start designing our React pages. The first page, as you know, when we launch our app, is going to be this landing page we have right here. But we're going to save designing this page for whenever we do user authentication. So let's start with the home page first. To get to the home page for right now, as you remember, I can just type /home, and this will bring us to our home page. On most blog sites, the homepage or the main page simply contains blog posts that are filtered by the recency. For example, we may have the most recent 5 blog posts displayed on the homepage with their name and a short description, which allows the reader to click on whichever one interests them. We may add more later, but that sounds like a great starting point for our homepage. We'll want to grab all of our blog posts from MongoDB, show the most recent posts, and allow users to click on them. Let's get started with that implementation. Also, real quick, off camera, I asked ChatGPT to write me some sample blog posts, and I actually uploaded these blog posts to MongoDB manually. So now we have what looks like actual blog posts instead of just random text like we had before. If you recall the episode where we built the functions to interact with the backend, remember that we stored all of that functionality in this API.js file, where we have functions like getPost, createPost, and so forth. Lucky for us, we already have this whole getPost function here, which will allow us to easily grab all of our posts off of MongoDB, which we can use for our homepage. So to use it, we'll navigate to our homepage file here. It should be in the pages folder, homepage right here, and let's import that function actually from our API. We'll say import getPost. I don't know if it's going to do it or not. We'll say import getPost from, let me actually shrink this down and look at the files real quick. Let me change something real quick. I just realized the earlier when we made these components and pages folder, we should have put them in this source folder here. So I'm actually going to change that right now. I'm going to, it shouldn't hopefully not break anything. I'm going to cut and paste these folders into source. I'll cut and paste again. And let's fix this error real quick. We may need to change some of the routing here. So I need to actually real quick to fix that. I'll just go into here. And all of these should just be // not // I believe. So let's just fix that real quick. Go ahead and save this, and maybe this will fix it. There we go. Okay, so now that we got the folder organization fixed, let's go back in here. Let's see if this will actually autofill this time. If I do get post. Okay, so I'm not wanting to. So we'll just do it manually. Let's say get post, and it should be just // and then API like this. On this page, we're going to want to store all of our post in React state. So let's also import useState from React. So we'll import useState. And then we know that we're going to be loading in data as well. So we're going to also import useEffect as well. Both of these hooks in tandem will allow us to call getPost and store these posts in the state. If we want to load something into our state from an external source, like an API, remember that we need in React to use the useEffect hook. So inside of our component, but outside of the return here, let's write a useEffect hook. We'll write useEffect. And remember, we always need to give it 2 arguments, a function and a dependency array. When we're loading data in from an API, we typically want to keep this dependency array empty unless we have a particular variable that keeps track of whether data is loaded or not. So for right now, we'll just leave it empty. And just to make it easier for you to see, I'm actually going to zoom this in one more time. The easiest way to call a function from an API inside a useEffect is to define the function inside the useEffect and then call it in the useEffect as well, because this allows us to declare the function as asynchronous. So let's define a function in here. We'll say async function. Let's just call it load all post. And then just so we don't forget, at the very bottom here, we'll make sure to call load all post. Now, the question is, what do we put inside this load all post function? Well, the first thing we should do is call the getPost function we imported from our API file and store it in a variable so we can use it later. To do this, I'll just make a variable. I'll call it, let's just say data for right now, and I'll set it equal to this function call. I'll say await because it's asynchronous, getPost. Just like this. Again, just to be careful, make sure you don't forget this await because this is an asynchronous function. And if you don't include the await, it's not going to wait for it to finish, so you'll just be getting a promise. Assuming all goes as planned, this data variable should contain an array of all the posts once this getPost function goes through, since this function is directly returning the array of posts grabbed from MongoDB. Therefore, we now have the posts we need, and the last step is just to store them in React state. Before we can do that, we need to make a piece of state in React to hold the posts using the useState hook. So up top here, let's just go up here and let's make a new piece of state. We'll say const. Let's call this piece of state post with a setter function of setPost. And we're going to initialize the state by calling useState. And we're going to make the default value an empty array. Now in our useEffect inside this load all post function, right below where we're grabbing our data, we can now set this React state. All we need to do that is call setPost and then just pass in the data we just grabbed. This sets the piece of React state post equal to the post that we just grabbed from MongoDB. All that we've effectively done in this file so far is called our API function getPost, which grabs the posts from MongoDB and returns them. And then we've stored the data in a piece of React state called posts. All we need to do now to display these posts on our homepage is to go into our JSX down here. Let's just delete the filler stuff that we've got going on so far. And then we need to map over our post array to display our info. We need some curly brackets to tell JSX that we're about to use JavaScript. And then we'll write post, which is just our piece of React state, .map. And then for each post, we want to return something. Remember that in React, map is basically just like a for loop, and it allows us to loop over some array. And then for each item in the array, we can return some JSX to display something on our page. Since we're wanting to have JSX, let's make sure inside of here we specify a return statement, and then we can specify whatever JSX in here that we want. And just to get rid of this little error here, let's actually just pass in some empty div tags here. And it would be nice in here if we could just return posts like this, but remember that we can't do that because React can't have objects as children, and post itself is an object. So what we need to do to display these is instead specify certain properties of post, like title, description, date, etc. So let's actually display a few of post properties here. And I'll do a different JSX tag for each property. So for the first one, I'm just going to do an h1 tag. And let's just say for this one, we'll do post.title. And then let me take this, I'm going to copy it. I'm going to paste it twice. We'll do a header 2 here. And then let's do a p tag for this one. And let's just change it. So instead of having title, let's make this one say post.description. And this one, we'll say post.dateCreated. And we're able to do these properties because you know that this post object here is part of our array, which is grabbed directly from MongoDB. So basically each one of these posts that we're mapping over here corresponds to each one of these object posts that you're seeing in MongoDB, and then each one has a title, description, and date created field. So all that this chunk of code is essentially doing is looping through every single post that we have, and for each post, we're displaying three things: its title, its description, and the date it was created. And for this whole file, that means all we've done so far is loaded the data from MongoDB, stored it in the React state, and then mapped over it in JSX. Let's test this now by saving our file. And voila, here you can see on our site, 3 posts just showed up, each with their own title, description, and date. This is a great starting point because we can see that it clearly worked. But let's actually make a few tweaks to this code. One thing that makes React strong is the use of reusable components. In case we need to use this format again for displaying each blog post, let's actually extract this code into a single component, and then we can just render that component wherever we want. And for the sake of simplicity, I'll just call this component a BlogCard, since it'll be like a small card that has basic info for a blog post. So let's actually go here into our file explorer. Let's go into our components folder that we've already made last episode, and I'm going to make a new component. We'll say blogcard.jsx. And to make the component, as always, we'll type export function blogcard. We'll want to make sure that it returns just some empty JSX for right now. And then to make this easier for us, let's actually go into this home file. Let's make sure we copy all this code here, or actually we'll just cut it. We'll cut it from here, and we'll paste it inside this component. Let's fix this ugly tabbing. So now we have the JSX extracted into its own component. One thing we need to keep in mind when we've copy and pasted this in is that these blog cards have no idea what this post object is referencing. So let's actually pass post in as a destructured prop, just like this. For a quick refresher on props, remember that if we pass in props with curly brackets, that's what we call props destructuring, and it allows us to reference the props by a specific name. So let's go ahead and save this file. And now that we have this super basic component made, let's actually head back to our home page now, and let's import that component up here. So we'll say import blogcard, and then all we need to do down here is just render the component itself. So we'll just render blogcard just like this. We know that this blogcard component is expecting one prop called post, so we need to make sure we pass that in. So on the home page here, we're rendering it in. Within this tag here, we need to pass in a prop called post. So let's say post equals, and luckily we already have this post object here that represents our post. So we can just pass that in as our post prop, just like this. And now if we go ahead and save this file, and you can see we obviously have the exact same output as before because all the JSX is the exact same, but now it's just extracted into its own component. Now we're rendering this blog information as a component that we could reuse anywhere else in our code later on if we wanted to. There's something I want to show you real quick that you should take into consideration when loading things into React State. I've run into the problem a lot before where I get an error that says cannot map properties of undefined or something along those lines. Because there's a split second where post is undefined since the data isn't loaded in instantaneously, and then we're trying to map over undefined, which throws an error because we obviously can't loop over something that's undefined. That's why it's super important that whenever you have a piece of React state like this, like we have post here, we specify an empty array to start out with, because that actually avoids that error. Looping over an empty array is fine, but looping over undefined is not fine. So if I actually delete these square brackets here, and then I make this our default value, which would be undefined, and then I go ahead and save the page, notice how everything disappears because our page has crashed. And if I actually look at the console, I have this error here that says cannot read properties of undefined reading map. I've seen a lot of people do this use state thing where they don't give it a default value. And in full stack applications like this one, that can cause problems that get really annoying to try and debug. So I'll just add the empty array back again, go ahead and save it, and notice how everything comes back on the page and it's working fine again. So that was a short little side tangent, but long story short, if you're loading in stuff from a backend like a database, and you know the type of the state it's supposed to be, then pass in that type for the default value. So we know that post is supposed to be an array, so that's why you do an empty array. If it's going to be an object, you know you can just pass in empty curly brackets like this. If it's going to be a Boolean, make sure it's either true or false by default. Hopefully you get the picture. So let's make sure this is still square brackets, save, and let's go on. On our page, all of our posts are here, with the only issue being that there is virtually no styling done. So it looks pretty hideous. Let's add some super basic CSS properties for now to make it look at least decent, which we'll expand on later. Let's make sure that this entire return here in this whole map section is surrounded by a div. So I'm going to name this div here, and let's give it its own class name so we can style it. Let's say class name equals, let's just call this one post. And then what we're also going to do is go into our BlogCard and we'll do the same thing. We'll give it a div, and we'll also give it a class name. And for this one, we'll just do post, but singular. And then let's head on over into our app.css file so we can do some quick styling. We'll add a class called post, and then we will also add a class called post. For post, all we want to do, let's just make display flex, and let's give flex direction as column. This will just make it so that each post inside this post class will be displayed in a vertical column instead of one big blob. And then for our post class, let's just give each one some margin and some padding. So we'll say margin, let's just give it 4 pixels. And let's do the same for padding as well. Give that one 4 pixels too. And then I also want to make them a little bit rounded on the edges. So we'll add border radius is, let's say, 10 pixels. Lastly, I just want to add some basic hover behavior for each post so that some stuff can happen style-wise whenever our mouse hovers over a post. So to add that, we can do .post, and for a certain behavior, we can do a colon, say colon hover. And then in here, all I want to do is highlight the post a certain color and then turn our mouse into a pointer. To get the pointer for our mouse, all we need to do is this. We can say cursor pointer. And then for the color, we'll need to change the background color when we hover over it. So we'll say background-color, and let's just do like a light gray for right now. Let's just do, actually let's do AAA. This will just be a light gray. If I go ahead and save this now, and I hover over these, you can see that now they're hovering gray, and you can see my mouse is now a pointer. So it doesn't exactly look beautiful, but this will do for right now. There's a few more things I want to do before we're finished up with our home page. First of all, this date that's being displayed here for each post looks pretty ugly because it's in the JavaScript format, which is not very readable for regular people. Secondly, we should order these by the most recent. First, let's fix this date by heading up into our BlogCard file. Right now, this date is just being stored as a string. So let's convert it into an actual date object, which you'll see why we do that in just a moment. To convert this into an actual date, let's just go up into our function here. Let's make a new variable for it. I'll say let date equals, and we'll say new date. And then we'll just want to pass in our date string, which is just stored in post.dateCreated. Now that it is an actual date object, there is an easy function we can use that will convert it to something that is a lot more human readable. And that function is just called toString, which we can do by making a new variable. Let's just say let string date equals, and all we need to do is call the date dot toString, just like this. And then now in our JSX, instead of displaying post.dateCreated, let's instead display that string that we just made, which is just string date. If we go ahead and save this file, notice how the string now looks a lot nicer for each date. However, it also has this extra fluff on top of it that we don't really need, like all this like standard like time zone stuff and whatnot. So let's actually just slice this string to include only the parts that we want. For right now, let's say that we don't care about day of the week, and we also don't care about any of the time zone stuff. So in our JSX, we can actually go to the string here, and we can add .slice to slice the string based on its index to only take part of the string. So if we look, for example, at this very first post, the date says Thursday, March 14th, 2024, and then it has all this time zone information. For this particular post, all I'm going to want is this March 14th, 2024. So let's slice that. Within this slice method, we'll need to actually find the indices that we need here. So let's actually go over here and count. We know that this is always going to be 3 letters. There's always a space, which means that this is always going to take up indices 0, 1, 2, and 3. So the first letter of the month here is always going to be on index 4. So we can add that as our first argument to slice. And then we also need the index where the slice is going to end. So we know this starts at index 4. So that's 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 should be the index where it ends at. So for the slice, we will say we want to go from index 4 to index 15. Now let's go ahead and save this file, and you can see our date looks much prettier. We're actually displaying it in a way that is readable. And actually while we're here, instead of doing this as a p tag, I'm going to do this as a header 3 tag. Oops. And save it, just so we can get the date to look a little bigger. The last thing I want to do style-wise for this homepage is order these posts by the most recent. And if you look here, they're actually already ordered by the most recent, but that's just based off of luck because that's the way I ordered them in MongoDB. but we want to actually make sure they are ordered on their own within the code. We can do that by first heading back to our home.jsx file, and this can actually be done with just one line of code. Right after we grab our post from MongoDB, we'll add this line in here, which I'm just going to copy and paste in, just like this. Basically, all this line is doing here is calls the sort method, which is a built-in method in JavaScript, and we're specifying the way that we want to actually sort the array. Basically, the way we do it is we find the difference between the two timestamps and sort it based on the difference, which would sort it so that the most recent dates are at the top of the list. If we go ahead and save our page here, nothing actually changes because, like I said, they were already sorted. However, now if we were to insert a new post, that would get sorted as well. Now that we've got most of the basic styling out of the way, there's one more thing I want to do on this homepage, and that's allowing users to actually click on a particular post and get redirected to a page where they can read the entire blog post. We already made a page for that in our folder, which we have over here, and that's just this ReadBlog Page right here. We also already have a route set up for this exact scenario. If we look, we go down here, and we know for the read blog, each one can take in its own ID. What I'm going to need to do is go into the BlogCard component and give each one a link to this route here. And each link will be unique because each card will have its own unique ID, hence why we have this ID field. Here's how we can do that. If we go back to our BlogCard page, let's import the link component from React Router DOM. This will allow us to link each post to its own page. Now, inside of our JSX, where we're rendering out each post, instead of making this a div here, let's actually turn this into a link instead. So I'm just going to replace div with link. Next, we just need to specify where we want this link to send us. Remember that when we made the route in app.jsx, the path here is /readblog/ and then whatever ID we want, meaning we need to fill in the ID of this post after the read blog part. If we go back to our link here, here's how we can do that. We can go ahead and write the to field like we always need for any given link. And actually inside here, we're going to do curly brackets, and then we're going to do a backtick character so that we can inject JavaScript inside the string. And then just so we can match our path, we'll write /readblog/ and now we need to fill in the ID of the post. Lucky for us, MongoDB gives us each post a unique ID. To grab this ID, all we need to do is type $ curly bracket so we can inject JavaScript into the string, and then write post._ID. And remember, _ID is how Mongo scores IDs. Let's save this page now so we can test the routing, and I can show you how it works. I guess first things first, there must have been some default CSS for divs, because since we have changed to a link instead of a div, you can see the text color change from white to like a bluish purple. But let's just go ahead and ignore that for right now. Let's test the link behavior. If I click on this first post here, you'll see this URL path becomes /readblog and then / whatever this ID is. If I go back to the main page and I click another post like this one, you can see we're still at /readblog, however the ID is different this time. This is what I like to call dynamic routing, and it's technically routing to just one route, this /readblog route. But each post can be given its own unique page by using this ID field. It's exactly why we passed this ID in the first place when we were making this route for each blog reading page. Now that we have this routing taken care of in the home page, let's head over to the ReadBlog page here so that we can go ahead and show you how we can uniquely display each post since we're already here. On this page, this is where we want the user to be able to read through an entire blog. So we essentially need to take one whole blog and display the title, description, content, and everything else we'll need for that blog. Lucky for us, we already have the functionality necessary to do that. If we go back to our api.js folder where we have all of our functions, remember that we made a function here that we just called getPost. We have it right down here, and this is just used to grab a single post. It requires an ID argument, and it'll just go and fetch a single post off of MongoDB based on whatever ID you give it. This function will help us to get one post information. So in our post or in our readblog.jsx file here, let's actually go up to the top here and let's actually import that getPost function. Let's import getPost from API. Now you may be wondering, how do we actually extract the ID from the post that we need to pass into this getPost function to find whatever post that we're looking for? Well, there's actually a really easy way to do that. Notice that whenever we're on this post page here for a particular post, we have this ID present in the URL because of the way we handled the routing. there is actually a hook in React Router DOM called useParams that will actually grab this ID from the URL so that we can store it in a variable. To use it, all we need to do is import it at the top here from React Router DOM. So it's called useParams, and it should autofill here to import. Once we've imported this, I'm going to go ahead and make a variable down here. I'm going to say let params equals useParams. When we use this useParams function, it actually returns an object where each param is a property of that object. So let's make a new variable. I'm going to call it ID. We'll say let ID, and we're going to set it equal to params.id since it'll store it in the ID field. Now, this ID right here is equal to whatever ID was in the URL. For example, if our URL up here was like /readblog/12345, this ID variable would now hold 12345. This is super important for us because it'll allow us to find the corresponding Mongo post with this particular ID. Once we have that, we can call the API function getPost, just like we did with the homepage. Let's actually go ahead and import useState and useEffect because we'll know that we're going to load in some data. So let's go ahead and import both of those just so we have them. And then we'll make a piece of React state to hold our post. Let's say we'll call it post with a setter function of setPost, useState, and it's going to be an object. So let's set the default value to an empty object. And then, like always, when we're loading in data from an API, we'll want to use a useEffect hook. So we'll go ahead and write useEffect hook, and we'll do a function for the first argument and an empty dependency array for the second argument. Hopefully by now you're getting comfortable using the useEffect to call functions from the backend. And again, just like we did with the home page, we'll actually define an asynchronous function inside of here. Let's call this function, let's say async function, let's just call it load post. And then we'll make sure at the very end, we call load post. Inside of this function, we'll call our API and we'll set it equal to a variable called data. So we'll say let data equals, and we're going to call this getPost function that we imported up top. So we're going to say await getPost, just like this. And then remember, we've already captured the post ID through the params in the URL. So we can actually pass that into the getPost function here because it is expecting an ID to go out and find the post it is looking for. The last thing we'll need to do is set our post state to the result of this function call. To do that, we'll just say setPost, setPost, if I can spell today, and we will set it equal to data. I went through this code super quick, so let me really quickly summarize what all this code is doing in case you're not fully clear on it. When we're on the home page, if we go to here, we can click on any particular one of these blogs that we want. No matter what blog you click on, you'll be taken to the ReadBlog page, where you can read that entire blog post. When we navigate to any particular blog post, for example this one here, we navigate to the /readblog route up here, and then the ID of the post to the URL so that we can differentiate between different blog posts. And then inside this ReadBlog component, which is this page that you're seeing, we are grabbing the ID from the URL and we're storing it in a variable. We're then just calling the getPost function, which we made in an earlier episode, that allows us to grab a single blog post from MongoDB based on its ID. Once we have that, we just store it in a piece of state or a piece of React state called post. Now that we have that information stored in post, we can display whatever we want on this page. We'll worry about most of our styling later, but for right now, let's just display all the properties we have for each post. So first of all, I'm just going to make a header 1 tag for the title. So we're just going to say post.title. I'm going to go ahead and take this, I'm going to copy it, I'm going to paste it 3 times here, and let's change these around. I'll make this one header 2, this one header 3, and this bottom one will be a p tag. Make sure to change these to match. Header 2, header 3, this is a p tag. And this one will display, let's say, the description, and this one will display the date it was created. And in this one, let's actually display all the content of the blog post. We're putting the content in a p tag because this is the actual paragraph text you would see on a typical blog post. Let's go ahead and now save this file. And you can see we now have all this text on our screen for this blog post. Let's actually real quick go back to our home page and just click on it to make sure it works correctly. If I just click on one of these posts, let's say this very bottom one here, you can see we've navigated to the /readblog route as well as the ID of this particular post. And we're uniquely displaying the title, description, date, and content of this particular blog post on this page. If I return back to the home page and I click on another blog post, you can see that the content is entirely different. And again, all of these pages are going to the /readBlog route, but because they each have their own unique ID, they are all fetching something that is completely unique from one another. Whenever we made the blog cards for the homepage, we ended up making this date here look a little nicer. So let's do the same exact thing on this page as well. So let's go up here back into our load post function where we're actually grabbing the post, and let's change how this date actually looks. First, let's just go in here and let's say let date equals new date, and we're going to pass in the actual date from this data object. So we'll say data.date created. This will just turn this variable into a new date. And then let's actually take that same field, that data.date created, and let's set it equal to date.toString. And if we go ahead and save it, this will make the date a lot more readable. We still want to get rid of this whole extra gunk though. So let's do the same slice that we did last time. Let's go down here. Let's do the same slice. We're going to do slice, and we're going to pass in, I think it was 4 to 15. Oh, oops. Actually, I shouldn't be slicing the content. I should be slicing date created. So I'm going to go back down here, slice, and it was 4 to 15. If I go ahead and save it, we may actually get an error when we refresh. I'm going to check it real quick. Okay, yeah. So the page actually crashed here and gave us an error. And if we open up our console here, it'll say cannot read properties of undefined reading slice. That's because there's a split second where this data isn't fully loaded in, and then we're trying to access this .slice method on something that doesn't actually exist since post.dateCreated doesn't exist yet. A quick fix to this would actually just to go in front of the slice here in front of this dot and just add a question mark in front of us here. What this question mark does is reads the methods after the dot only if what you're accessing isn't undefined. So we go ahead and save this, and you can see we can refresh and whatnot, and our page is back to normal. Great, so we're almost actually done. Next, just as a small convenience thing, I just want to add a quick button on this ReadBlog page that allow us to navigate back to the previous page. That way we don't have to keep clicking home to go back and forth between each of these posts. So let's see if we can look at one of these pages here. And in this JSX here, I'm actually just going to add, I'll just add it at the very top right now. I'm going to go ahead and add a button. It'll just say back, and it'll take us back to the previous page. We'll add an onClick property here. And then whenever this button is clicked, we want to navigate back one page. There's actually a really easy way to do this in React Router. We just need to import a function called useNavigate from React Router DOM. So we'll go up here and we'll just import useNavigate. UseNavigate is kind of like link, where it allows us to traverse between pages, except useNavigate is used within JavaScript code, not JSX. In your onClick property here, let's just write a little arrow function here, and we can just say useNavigate, and then we can plug in -1. -1 in the context of this situation will just take you back one page, which is exactly what you want. However, if we go ahead and save this and click back, you'll notice nothing actually happens. And if we look at our console here, it's telling us that we have an error. It'll say that it's an invalid hook call. It's important to remember that we can't unfortunately just call hooks like this in React. So we'll have to make an alias for useNavigate. So up top here, let's just go up here where we're doing use params. Let's just say const navigate equals useNavigate, so we can make an alias for it. And then down here, instead of calling useNavigate, let's just call the navigate alias we just made. And it'll behave the exact same, but it'll actually work this time. I'll go ahead and click save here. And now if I press back, it'll actually take us back to whatever page we were on previously. Great, so now we have the home page working just as intended, and we also have the ReadBlog page working just fine too. This video is getting kind of long, so I'm going to go ahead and end this episode here. In this episode, we built out the bulk of our home page using our blog data from MongoDB, and we also built a dedicated page where each blog can be fully read by using dynamic routing. In the next episode, we'll finish up our React pages by fleshing out the create post page, as well as the about us and contact pages. Take care everyone, and I'll see you in the next one. Hey everyone, and welcome back to the MERN Stack crash course. In this episode, we're going to finish the rest of our React pages. We'll make the functionality to create a blog post, and we'll add in some filler content for the rest of our site. There's a few more pages I want to focus on us building. First of all, the create blog post, and then the about us and the contact pages. After that, we'll focus on our last two pages, the landing page and the profile page. However, we'll go over these two pages next episode when we do user authentication. The About Us and Contact page will be super quick since there's not really a whole lot of functionality there, so let's actually save those for last. So we'll focus on creating the CreateBlog page first. This is a super important part of our app because without the ability to create new blog posts, we don't really have a functional blog site. First, let's make sure we have the CreateBlog.jsx file created and in our pages folder, and then we can get to work. We know we're going to be using state to help store the post we're submitting, so let's go ahead and first import useState from React. Once we've imported it, let's think about what we'll need on this page. For each post, we want the user to be able to make a title for it, a description, and write the actual blog content itself. That's all we're going to need in terms of user input because the fields like author and date created can be filled in automatically with JavaScript. First things first, we'll treat this submission page like a form, so let's make our outermost JSX tag a form tag, just like this. Next, we're going to give this an onSubmit property. OnSubmit works similarly to onClick and onChange. Basically, it's a way to handle an event, in this particular case, a form submission. Whenever this onSubmit is triggered, let's call an imaginary function just called handleSubmit. You'll see how this handleSubmit comes into play in just a moment, but for now, let's build out our form. Let's now get started with the 3 input fields that we need. We'll make the first one an input with a self-closing tag and just give it a name of title. And then I'm just going to take this, I'm going to copy it, I'm going to paste it twice, and let's change this one here to description. And then let's change this one here to content. And these are the 3 essential input fields that we're going to need for creating a blog post. And actually, since content was going to be a larger text box, let's actually make this a text area instead of input. And then what I'm going to do for each of these inputs is I'm going to make a label tag for each one, just so the user knows what each one is for. So I'll say label here, we'll say blog post title. And then let's go ahead and just copy this, and let's paste it below each of these and just write these labels out accordingly. We'll name this one blog description, and then we will just name this one blog content. Just so you can see what this page now looks like, I'm going to go ahead and save this file. And it looks like we defined this handleSubmit function up here, but we didn't actually, we're calling handleSubmit, but we didn't actually define it. Let me just write, I'm not actually going to fill out the content yet. I'll just write this right here, just so it stops giving us this error. And here you'll see we have now 3 input fields on our page. It's a pretty simple page layout with just 3 text boxes and some labels to show what each one means. Now it's time to get into the real React functionality for this page. The first thing we'll want to do is create state that can hold each of our variables for our text fields, meaning we'll want a piece of state for our title, one for our description, and one for our content. This is so we can update these fields in real time. So let's go ahead and go up here and create these 3 pieces of state. For title, we'll say const title, set title, and we're going to set all these equal to empty strings just to start. Just copy this, paste it twice. This will be description, and then set description. And then lastly, we'll have content, and then set content. Next, we'll want to add an onChange property to each of the text boxes that we have on this page. I have multiple videos going over how to use the onChange tag, but basically what it does is calls some function every single time something within the tag changes. For example, if I have an onChange property within the title field here, and I go into the title box, every time I type a letter, delete a letter, or make any other possible change, we're going to call whatever function we put inside onChange. To add an onChange property, all we need to do is all we need to do here is go in here and add onChange like this and set it equal to a JavaScript expression. Every time something happens in this tag, it's stored in what's called an event, which most people will just denote as E. So we'll add E as an argument. Then we'll add the arrow function here. And now we just want to call the setTitle function to set our title to whatever is currently in the text field. In JavaScript, it's stored in this event object in a property called value, which is within another property called target. So all we need to do to access it is write e.target.value. What this line here implies is that every single time I make a change to this title input, we're going to call this function right here that says set title to e.target.value. And what this actually implies is that upon any change, we're going to be setting the title state to whatever is currently in the text box, meaning it updates in real time, so the state will change upon every update. Let's go ahead and take this whole chunk here. Let's get onChange. Let's actually copy it, and let's paste it into our other input fields as well. And obviously, we'll need to change the names of these. So this one should say set description because it's the description field. And then this one should say set content because it is the content field. Now, each time we change any one of these fields, their respective state will be updated accordingly. In order to actually submit this form, we should make a button tag here at the very bottom. So I'll make one called button. And then let's put it in the text right now. We'll just say submit. And then what we'll need to do to actually submit it is give it this property called type equals submit. Anytime you have a button inside of a form and you give it this type equals submit, it tells the form that whenever you click this button, you'll invoke whatever function is in this onSubmit tag right here. So let's go ahead and save this page. And now let's write this handle submit function that we defined up here. So let's actually think about what this function needs to do. Well, it needs to combine all these state fields into a single object. And then it needs to upload that object to MongoDB so that we can store it as a blog post. So let's inside this function create a brand new object, and I'm just going to call it submit object. So I'll say let submit object equals, and we'll do our curly brackets. And we'll just want to aggregate all three pieces of our state into this object. So first we'll make a property called title and set it equal to title from our React state. Then we'll make a property called description, set it equal to description from our React state. And then we'll do the exact same for content and get content from our React state. Now we filled this submit object with the React state we're gathering from our text fields. However, remember that in Mongo, we actually have 5 fields. We have title, description, content. Then we also have author and date created. So we'll need to add the author and date created fields in here as well. The author field we'll take care of next episode when we actually do the user authentication part of it. So for right now, I'm just going to make an author field here, and I'm going to set it to null. But we also need to make date created, and that's actually really easy to do. All we need to do is write new date, just like this. This new date line calls the constructor of the built-in JavaScript date object, and we'll set it equal to whatever time it currently is right at that moment. Real quick before we submit, I should quickly mention that if you want, you have the option of putting all these 3 pieces of state in a single piece of state. Sometimes people like having one piece of state and make it an object with the keys, title, description, and content, and whatever else they wanted. I would do that if we had a ton of fields, but since we only have 3, that's why we're just keeping them as separate pieces of state. However, now that we have our object ready to be uploaded, we should import the CreatePost function from our API that'll handle all the MongoDB functionality for us. So I'll just say import, and it is just CreatePost, and that is from our API file. Once we have that, all that we actually need to do to submit our blog post is go down here, and let's just call this function that we just imported CreatePost. We'll say CreatePost, and we'll pass in the submit object that we just created. And this CreatePost function in our API file is actually defined as asynchronous since it won't execute instantly. So let's actually turn this handle submit function into an async function up here, and then we'll add the await keyword in front of CreatePost. We're not doing anything in this function after we call CreatePost, so technically you don't actually need the await keyword, and it won't really do much, but I just think it's standard practice to always await any functions that are asynchronous. Now, what we've done on this page is created 3 text fields where users can directly alter 3 pieces of React state, that being the title, description, and content of a blog post. Then they can click this submit button right here to publish this blog post, which we'll call this handle submit function, and we'll actually upload it to MongoDB by calling this CreatePost function we made in our API. Before we call this good and move on to testing this, there's a few things we should check to make sure our form input is valid. First of all, it would probably be smart to put a character limit on these fields, so a user couldn't just, let's say, input 15 million characters in a field and just flood our database. Secondly, right now we're still able to submit this form even if one of these fields here is blank, so we should have a check to make sure that all the fields are filled out. Adding a max length on all of our input fields is actually super easy. If we go to any one of our input fields here, we can go in here and we can specify a property actually called max length, just like this. And then we can set it equal to whatever number we want the character limit to be. For title, let's just set it to 100. And then we'll go ahead and copy this and let's paste it into these other 2 blocks here. For description, let's make the max length, let's say 200. And then for content, since content's going to be the largest field, let's do a large number. Let's just say 5,000 character limit. If I go ahead and now save this file, and I were to go in this blog post title and type forever, there would be a limit where it would basically not let me type anymore. And you can see we've reached that wall already. So let's go ahead and just delete this real quick. And then next, if I can delete it fast enough. And then next we'll focus on handling the cases where not all the fields are filled out. There's a lot of different ways that we can actually handle this. One way to do it would be in our handle submit function up here. We could just write like a big if statement, basically checking each field saying like if not title or not description or not content, and then throw some error or something along those lines. However, I have a much simpler solution that only requires one word. In each of our input fields down here, we can actually go over here and we can just add a property called required. And this will make sure that the form cannot submit if these fields here are not filled out. So let's add required to all of our input fields. Now that we actually have this page pretty fleshed out, let's go ahead and save this. And then let's run some testing to see if we can actually upload blog posts to MongoDB. So for title, I'll just say something like, I am testing the title. For description, I'll say insert filler blog description, something like this. And then for content, I'll say this course is meant to teach people how to build full stack React applications. And then I'm going to go ahead and open up our console here to see if we have any errors. These are errors from earlier. And let's go ahead and press submit. So let's actually go to our Mongo database and let's see what happened. Let's go ahead and refresh this page. And let's look at our post here. And at the very bottom of the screen here, you can see we have a new blog post object right here with the fields that we just inputted. So it said I'm testing the title, insert filler blog description, and this course is meant to teach people how to build full stack React applications. So it looks like I filled out all the fields completely correctly. This is awesome because now we have the ability to just create blog posts in our app however and whenever we want. Being a blog website, this is probably the most essential feature. And I'll actually show you if we go back to our site here and we go back to home, you'll see that we now actually have this new blog post right here. We can click on it here and it'll have all this information on the page. Now that we have this hugely important feature out of the way, let's flesh out our two super easy pages, the About Us page and the Contact page. You don't actually need these pages if all you're going for is a simple and easy blog, but since many real websites do have pages similar to these, we'll have them on our site as well. Because they're super simple, I'm going to do these pages off screen so I don't waste your time, but I'll quickly explain how they work. So I went ahead and made a super simple About Us page. All it is just a couple of paragraph tags that have some text in it that I just filled with some random words. You can see how simple it is if we have a look at the actual About Us page over here on the left, since it's just some text on a page. The only thing really worth noting on this page is that I imported the link component from React Router DOM, and then I made this link here that just links directly to the CreateBlog page in case a user wants to click on it to create a blog. Aside from that, this page is pretty bare bones and only took me like 2 minutes to make. Next, we'll head over to our contact page in our code and have it open up on our site here as well. You can see this page is definitely a little bit more involved than the About Us page, but it's definitely nothing too crazy. Again, I just made some basic paragraph tags here with some super simple text in them, and then at the bottom I made my own little custom form element, almost identical to how we made the create blog form. There's labels for each one of these fields, there's inputs for each one of the input fields, and then there's a button at the very bottom to go ahead and submit the form. When we submit it, we're calling this function called handleSubmit, which is defined up here, and you can see it doesn't actually do anything right now. If you wanted some sort of email service or something like that in your app, this is where you could call some of those functions if you wanted. However, that's beyond the scope of what we're trying to do, so we just have this function here as a template in case we wanted to actually do anything when the user submits the form. Other than that, this page is super simple. Now, you're probably thinking, all these pages we've just made are super ugly and unappealing, and you'd be exactly right. But if we just hold off for a little bit and get these next few episodes out of the way, we'll end this series with a full styling episode where we make all this stuff look like it's actually professional and like it wasn't built on a Nintendo DS. And with that, we'll wrap up this episode. In this episode, we built the functionality to create a blog post and upload it to MongoDB, as well as created two easy pages, the About Us page and the Contact page. In the very next episode, we'll take care of user authentication, which will allow us to create user accounts and log into the site with our own unique profile. We'll also flesh out the very last two pages, the landing page and the profile page. Take care, everyone, and I'll see you in the next one. Hey everyone, and welcome back to the MERN Stack crash course. In this episode, we're going to take care of user authentication, which will involve handling a user's collection in MongoDB and building a landing page for users to interact with, where they can create their own accounts and log into the app. First of all, you might be wondering, what actually is user authentication? User authentication is when users have account information that is stored somewhere like in a database, and every time a user tries to log in or access our site, we check their login information against what's in the database to authenticate if they are a valid user or not. If they are, they can proceed to the site, otherwise they won't be able to access it. This also includes restricting user access based on whether they're authenticated or not. The first thing we'll want to do is to make sure our database is able to store users. Ultimately, we need to store user info somewhere, and we already have a Mongo database set up that is connected to our code. So what we can do is just create another collection in MongoDB called users that will store this info. If you're logged into MongoDB and head to the database that we already created, this blog data database, you'll remember that we have this post collection here, which we know stores all of our blog post information. To create a new collection, we can hover over this button here, this plus button, click on it, and it'll bring up this pop-up right here. We want our new collection to be named users, so let's go ahead and type in users in this field here, and then we'll go ahead and click create. Now that we have this users collection made in MongoDB, we can write code just like we did for the post collection that allows us to create, update, and delete users. All of our backend functionality for dealing with our post in MongoDB comes from this post-routes.js file we made in our backend folder. Now what's nice about these post routes is that the functionality we have for creating, updating, deleting, and so forth is pretty much the exact same functionality that we'll need for doing the same things with users. The only difference is the name of the collection that we're accessing. With that being said, I'm going to go over to our file directory in our backend folder. I'm going to make a new file called userroutes.js that will pretty much just mimic this post routes file. And when I say mimic, I mean I'm going to go into this post routes file, select everything in here, copy it, and I'm going to paste it right into this user routes file. The big thing we'll need to change is naming the router user routes instead of post routes. So I'm going to go ahead and go into Control F here so I can do it more easily. Let's type in post routes. And then every time I see post routes, I want to replace it with user routes. Go ahead and here, click this button to replace all. And now all post routes have just become user routes. And notice here also in all of our route paths, we're accessing post. And also in all of the collections in here, we're also accessing post as well. So let's change that as well. So we'll do post like this. Anywhere where we see post, we'll want to change that to users. Let's go ahead and do a replace all here as well. And you'll see now all these routes are users. The last thing we'll need to do is make some changes to our create and update routes. Obviously, it doesn't make sense for a user object to have fields like title, description, content, etc. So let's make these fields new to reflect the fields we'd actually want with a user. For a user, I'm going to make 5 fields. I'm going to have name for the first one. Then I will have email, and then we'll do password, and then join date, and then lastly, we will also do post. And I want to make sure to change our request bodies as well. So this should be name, this is email, this is password, this one is join date, and then the last one is post. And actually, whenever we create our users, the only information we're going to be grabbing from them directly is name, email, and password. So these 3 fields right here. The other 2 fields, join date and post, can just be populated automatically here in our backend. For join date, instead of saying this, we'll just say new date, which means whenever a user is created, it'll just set this join date equal to the current date and time. And then obviously, whenever a user is first created with their account, they won't have any post at all. So let's actually just make this an empty array. The very last thing we should do is make these same updates for our update route. So I'm actually going to take this object here. I'm going to copy it. And I'm going to paste it in place of this object here. And the only changes here is that whenever we're updating an object, we don't want to set a new join date, and we don't want to erase all the posts they currently have. So on these ones, we actually should use something like this, where we have request.body in the name of the field, so we can maintain what we already have. So we'll change this one to join date. And then we will change this one to posts. Now we've essentially just created all the backend routes for our users collection without having to really write any extra code. The very last thing we need to do before we make sure this works is go ahead and save the file. And then let's head into our server.js file here. And then we'll need to mount the user routes to middleware just like we did with our post routes right here. So to do that, we can go ahead and import user routes by saying, you can say const, let's say users equals require. That should be /user routes like this. And then all we need to do down here is say app.use, and we're going to use users. And that now adds those routes to the middleware, so our backend will be able to see them as valid routes. Now, pretty much all the basic backend functionality for user routes should be taken care of. Just like we did with the blog post routes, however, we might find it useful to create front-end functions that interact with these routes, so that we can just call the functions each time we want to interact with our database. We don't have to worry about accessing these routes explicitly every single time. If we go ahead and go in our file directory here and we find our API file here, you'll remember that we have all these JavaScript functions that call our backend routes. And I'm going to make something similar for the user routes we just made. For right now, I'm not worried about deleting a user, so we'll first just add functionality to create a user, retrieve a user, and update a user. Because the code for users is virtually the same as the code for posts, I'm going to go ahead and take the functions that we already have for updating, creating, and getting a post. I'm going to go ahead and copy it and paste it down here. And then I'm going to rename them so that they all work for users. This one will be get user, this one will be create user, and this one will be update user. And I'll make sure to change these arguments as well. Instead of saying post, they should say user. So this should go here as user. This should be user. And then this should be a user as well. Lastly, we'll obviously need to change the actual path of the routes here. So instead of going to posts, we want them to go to users because that's what we specified in our backend. So this should be users and this should be users. And now we should be all good to go. And actually, just so these comments are clear, I'm going to change these to users as well. Users, users, and users. Now that we have these functions ready to go, we can import these functions and call them anywhere in our React code where we want to create or get a user. Awesome. Now that's taken care of, let's get started with the actual user authentication aspect of this episode. The way we have routing set up right now, when the app is first launched, the user is directed to a landing page. This is the page where we want to allow the user to log in or create an account if they haven't already. So let's go ahead and actually navigate to the landing page here on our site. And then in our file explorer here, let's actually go to landing.jsx, which is this page here, and let's get to work. First things first, we're going to need two views on this page, meaning this page will kind of act like it's almost two separate pages. The first view should be the login view, and the second view should be the create account view. This is what most web apps do. Most of the time when you have a login page, there's a button that'll say something like, if you're a new user, click this button to create an account. And you create the account on that same login page. Otherwise, you can just log in like normal, which is why we need functionality for two things, logging in and creating an account. I'm going to split these two views into two separate React components. That way we can keep them organized a little bit better. So I'm going to go ahead and go into our components folder here. I'm going to make a file called createuser.jsx. Then I'm also going to create one called login.jsx as well. And let's actually start first with the create user because we can't log in if we haven't made an account yet. First things first, we'll just write the boiler code for our component. We'll say export function create user. And then for right now, we'll just return empty tags. Then let's import the create user function that we just made in our API. We know we'll need to allow users to create an account, so we know that we need this function. Next, we know we're going to be needing state for a few things. So let's go ahead and import useState from React. Just like we did when we created a post, we can create pieces of state to keep track of what the user is inputting into text fields. This time though, just so I can show you a slightly different approach, we'll handle it as one large piece of state instead of separate pieces of state for each input. So to do that, I'm going to go ahead and make a piece of state. I'll say const user, set user, and I'm going to set it to useState. And then we'll make the default value an object, and we're going to give it 3 fields. These fields are going to be the fields that the user is filling out. So first we will have name, we'll do this as empty strings for right now. We will have email, and then we will have password. In our JSX, let's make the parent element a form tag. I'm going to type form in here, then form down here as well, just like we have with other forms. And then with other forms, just like we did with those, we'll give it an onSubmit tag. And whenever it's submitted, we're going to call an imaginary function that for right now, we'll just call handle submit. And just to make sure that function doesn't stay imaginary, let's go up here and define it. So I'm going to say async function, and then I'm going to say async function, let's say handle submit. And then we'll do this just so we can be sure that it's actually defined for our onSubmit tag. Next, let's go inside of our form here and let's add some input fields. So we'll first add an input field that is for the name, and we'll make one that is for email and then one that is for password. Let's add a placeholder property in all these so the user can actually see what the fields are. So we'll say placeholder for this one, and this will be, I said this one, sorry, it was name. Placeholder for this one should be email, if I can spell right, email. And then the placeholder for the last one should be password. And just so you can actually see what's happening on this page over here on the left, I'm going to go ahead and save this file. And I'm going to import it into our landing page, import create user. And then right here, instead of saying landing page, I'm just going to render the create user component. Go ahead and save it. And you can see over here, they're kind of small, but we do have 3 input fields, one for name, one for email, and one for password. Just like with all our other forms, we'll also add an onChange property so that we can update the state each time one of these fields changes. So we'll add onChange here, and we'll add this to our other 2 as well. But let's hold on just a minute. Because we have all of our state in one large object here, we need to modify slightly the way we use this onChange property. So let's actually make a separate function up here. I'm going to call it handle change. Let's say function handle change. And each time any of these input fields is changed, let's call that handle change function. So each of these onChanges here should have handle change inside of them. Inside handle change, what do we need to do? Well, we know we want to modify the user state up here because that's ultimately what's being modified every time one of these input fields changes. So let's go ahead and call set user. And then because we're working with an object, let's start off by using curly brackets to denote that we're working with an object. To update a React state object, we normally need to use the spread notation if we want to maintain what we already have in the object. And spread notation just means adding 3 dots like this, ... and then the name of the object in question, which is just our user state. Then to go ahead and update a value in the state, we need to pass in a key value pair that represents the updated value. So if, for example, I wanted to update the name field to Austin, I would do something like this. I would say name equals Austin like this. But we can't just hard code either of these things in this case here, with that being the key or the value, because the key could be name, email, or password, and the value could be whatever we wanted to enter in. So I'm actually going to give this handle change an E argument to represent the event of whatever the user is typing in. We're going to set the name to e.target.name because that is where the key is going to be stored. And then we will set the value to e.target.value. And again, just so we're clear here, this E is the event object, and to use it, we'll just make sure that we have it as an argument in our definition here. And what's nice about React and JSX is that whenever you call a function like this down here, handle change, I actually don't need to pass in E because it does it automatically for you. This e.target.name right here means we're making the key of our updated value equal to the name of whatever field we're working with. And for this to work, we actually need to give each field its own unique name. And to do that, all we need to do is go down into our tags here. We'll give this one a property of name. And this one actually will just be named as name because that is the name field. And then we'll copy and paste this into here. This is the email field. And then this one is the password field. And then you should hopefully be familiar with e.target.value as it's what you would normally use when we're talking about an onChange property. And actually, one last thing, this handle change function, we'll probably need to surround e.target.name here with square brackets to ensure that this gets done correctly and get rid of this error. Now we're done with the onChange part. Every time a user changes anything in any of the fields on this page, we're going to call handle change. And then we change our user state to be equal to the current user plus the modification or update of whatever key value pair is in question, which could be either name, email, or password. Let's quickly add some small things to each of these fields. First of all, we're going to add the required property to all of these to make sure that it requires them before we submit the form, meaning it won't let us actually call the submit unless these fields are all filled out. Next, let's give each of these fields a maximum length. For each of these fields, we can add a max length property just like we did with post to ensure a user doesn't try to enter a username that's like 1,000 characters long. To do this, we can just add a max length property. And then for example, for our name, let's just set it to 20. Let's go ahead and copy this. Let's paste it in here. For email, let's say, I don't know exactly what it should be. Let's just say 40. And then we'll keep password as 20 as well. And then so we can actually submit, let's go ahead and down here, create a button. Let's just have it say, actually I'll say create account. And then to make it call this handle submit function, we'll just have to say type equals submit. I can go ahead and save this page and you'll see this create account button just showed up. The very last thing we need to do on this page is figure out what we're going to do with this handle submit function. We need to actually call the create user function that we're importing from our API when we submit the form. We already have it imported here at the top. So let's just go ahead and go into our submit here. And let's actually just call the create user and then pass in our React user state that we've been modifying. And then because create user is technically an asynchronous function, let's add the await keyword in front of it. And I actually want to set this equal to a variable. I'm going to say let response equals await create user. And then with this variable here, let's actually just do some super elementary error checking to make sure it went through just fine. Right now, if we go to our API file, whenever we're creating a user, you can see we're just returning the response here. So that's what we are essentially capturing right here with this variable. One way to check if something went through correctly is to check the status of it. If a request has a status of 200, that means it went through successfully. So let's just say down here, I'll say if response is not equal to 200, meaning something went wrong, what I'm going to do is I'm just going to alert the user, and I'm going to say user account could not be created. Obviously, later down the road, we should probably want a more intricate way of checking for the response and making sure it's valid, but for right now, this will do. This just provides a basic alert in the front end to let us know if something went wrong when we try to call the backend. One thing you may be wondering right now, the way that we have it, we're just uploading a raw password to MongoDB. And this is not a safe practice by any means. There's a ton of different conventions you might have to think about when storing user information. And I'm not going to go cover all of them, but one very obvious thing you should never do is store raw user passwords in a database, or any sensitive information for that matter. If there is some sort of breach of the database, that could mean some bad things. One simple thing we can do with passwords is to encrypt the passwords so that the Mongo database just holds an encrypted version of the password, not the actual raw password itself. There's a few ways we can go about doing this, but one of the easiest ways is by using a library called bcrypt. Bcrypt has functions that allows us to encrypt a password as well as decrypt to validate login information. So to go ahead and install bcrypt, all we need to do is open up our terminal, and let's make sure we are cd'd into our backend folder because that's where we want to be installing it. And we just want to write npm install bcrypt just like this to install the bcrypt package. Once you have bcrypt installed in your backend folder, let's head to the user routes file that we made earlier. Go ahead and close this terminal, and let's actually import that library. To do that, it's pretty easy. All we need to say is const bcrypt equals require bcrypt. Once we have this package both installed and imported, head down to where we're creating a new user right here. And then we know it's not safe to store a raw password in our database, so let's use bcrypt to encrypt this password that we already have. To encrypt the password, all we need to do is make a new variable to represent our encrypted password. I'm going to go ahead and say const hash. I'm going to set it equal to bcrypt.hash. Then hash requires two arguments. The first argument is the password we want to hash, which in our case is stored in request.body.password. And then the second argument is what we call salt rounds. I'm not going to get into the nitty-gritty of what salt rounds are, but for our sake, all we need to know is that it's an integer number that is used as an extra security measure. So I'm going to go up here to the top of our file. I'm going to make a constant for that. I'm going to say const salt rounds equals, and let's just set it equal to, let's say 6 for right now. Then I'm going to go back down here, and what are we calling it? Oh, right here. And for our second argument, I'm going to pass in salt rounds. This hash method right here, basically all it is just a method from bcrypt that turns our password into an encrypted one. And this hash method is actually a asynchronous function, so I'm going to go ahead and add the await keyword before we call it. Lastly, when we're creating the object to send to our database, we'll replace this request.body.password instead with hash. Great, so now we've got the password encryption taken care of, so that we're passing in an actual encrypted password to our database. Here's one thing we should think about before we move back to our front end. Right now, there could theoretically be duplicate usernames in our database or emails, because we're not checking for that whenever we create a user. This may cause problems down the road when we try to verify the login. We can add a super simple check for this that'll only take a few lines of code. First, we should make a variable to represent if the email is taken or not, which I will just name, I'll say const taken email, and then we will set it equal to db.collection. We want to look at our users collection, and then we're going to call the find one method from Mongo. And then for our query, all we're going to say is find one where email is equal to the email that was passed in from the request, which is just request.body.email. All this line does is collects to our database, accesses the user's collection, and then runs this method called find one. If find one actually finds something, it'll be set equal to whatever object it found. We're searching for an email field in the user objects that matches what the user inputted in when they were trying to make an account. If this whole thing returns an object, meaning we did find a match, that would mean that this email is taken and thus not available. With that being said, I can write an if statement right here, and I can say if taken email, then all I'm going to do is just write a response object. I'm going to write to the response. I'm going to say response.json, and I'm going to say, let's give it a message, and let's say the username is, or actually not username, the email is taken. If this right here is the case and the email actually is taken, we don't want the rest of our code to run because we'd still be adding a duplicate username. So let's actually go ahead and write an else statement. And I'm going to put everything else inside the else statement. This ensures that these chunks run completely exclusively from one another. Now that we have that out of the way, let's go ahead and save this file, and let's head back to our landing page and finish up with the functionality to create a new user. And actually, let's go ahead and test to see if our ability to create a new user actually works. So in the name field, I'm just going to go ahead and fill it for email. I will just say austin@outlook.com, and then password, I'm just going to say 12345, and then let's go ahead and click create account. And actually, I just noticed it wiped out all of our fields here. So actually, to prevent that, I'm going to go into our code here, and I'm just going to add one line. I'm going to add this E. I'm going to do e.prevent default. And that's actually how you prevent it from wiping out all the fields. Let's actually now look at Mongo and see if our object uploaded correctly. So let's go ahead and refresh this page here, and hopefully there should be an object in our collection. And clearly there's nothing here. So let's actually go back to our page here. I'm going to re-enter the information and look at our console and see if I can see if anything's going on. So to austin@outlook.com again. I'll do 12345. I'm going to go ahead and have my console open here, click create account. And then it says 404 not found. Oh, you know what? Actually, I didn't relaunch the server after we modified our code. So I think I need to actually relaunch the server, and it should run correctly. So I'm going to go into the terminal where I have the server open. Should be this one right here. I'm going to go ahead and Control-C that and just run the server again and go ahead and reconnect to the server. And then what I'm going to do is I'm going to go ahead and close this, and I'm going to try this again. So I'll go ahead and close out these errors here. I will click create account, and it says user account could not be created. Okay, so I went ahead and did some digging actually, and I think the error is right here. This find one method should be an asynchronous method. So I actually need to define this, or say await here, because I think that right here it says promise pending, which means that it's not yet waiting for it to finish before it actually finds whatever it's looking for. So I hope theoretically I should be able to save this. Go ahead and close this, reopen the server. And now let's fingers crossed, go ahead and test this. So I'll go ahead and click create account, and it says user account cannot be created still. Let me actually check something real quick. I want to see. Okay, yeah, so it looks like on Mongo it actually did update our collection here. So it did upload it, but for some reason it's still saying there was an error on the front end side. I'm going to go ahead and delete this here, save this, go into our create user. And I'm going to go ahead and keep this response console logged out. And I'm actually going to create a new user. I'm going to say this is just like Sam or something. I'll keep kind of similar. I'll go ahead and click create account. Said user account cannot be created. And let's actually look at our response object here. It actually looks like, okay, it's not opening for whatever reason, but it looks like our status actually is 200. So I'm not sure exactly why this is running here. Oh, oops, I'm dumb. This should not be response. This should be response.status. Let's go ahead and save this. Hopefully now try again, and this should work fine. So it will have just created a Sam object. So I'm going to go ahead and do a new name. Let's just do David. We'll do david@outlook.com. Go ahead and click create account. And now hopefully no error message. Go ahead and refresh this. And yeah, now we have two new entries, Sam and David. So I'm actually going to go ahead and just delete these because I was just testing. But now we know that it works and the error is resolved. Couple of things to note here. We see that this object has all the fields that we just filled out, plus the current date as this kind of date type string. And then we have an encrypted string for our password that has literally zero resemblance to the actual password that we originally passed in. And of course, we have an empty post array at the bottom. One super quick thing I want to mention that's kind of an important thing to notice. So if we go to where we are creating our user, we know that we're encrypting our password before we send it to the database. However, it's not encrypted when we send it between the front end and back end. This means that in theory, someone could be listening for the HTTP request and then actually intercept the password before it gets encrypted and then have access to somebody's account. If we wanted to actually deploy this app and not just work locally on it, we'd want to use HTTPS instead of HTTP in order to encrypt our HTTP request. However, this isn't something we're going to worry about right this second. And before we move on to the next part with the login, I want to change this password field here. Normally on most pages, whenever you fill in a password, the password is kind of hidden in a way. So what I'm going to do is actually I'm going to go to create user here, and I'm going to make this password here. I'm going to give it a type of password as well, and that should actually hide it. So now you can see the 1, 2, 3, 4, 5 is as those kind of password dots instead of just the raw text. Now that we have the user creation taken care of, the next thing we would logically need to do is create the functionality for users to log in using the information they created their account with. Before we start building out the React page for this, we should ask ourselves how we're going to verify that a user has the correct login information. Well, we should first check to see if the email they entered in on the landing page matches any of the emails we have in the database, like for instance, austin@outlook.com. If it does, then we should move on to checking the encrypted password. If it doesn't, then we would just say something like user not found. Whenever we first encrypted our password, we use this library called bcrypt. And bcrypt actually has another method used for password checking called compare. That just compares an input string with an encrypted string, and it compares them to see if they are compatible. Essentially meaning, could this encrypted password have come from this input string? What that means practically is that we could compare 1, 2, 3, 4, 5, which is the initial password I made in here, against this encrypted string that we are storing in Mongo. If I ran the compare method with those two things, it would return true because this encrypted string here came from the password 1, 2, 3, 4, 5. But for instance, if I try to compare this encrypted string against something like, let's say, ABC, then that would return false because they are not compatible. So in summary, compare is a method that we can use to verify if a password is correct or not. In our user routes file over here, we have the functionality to create a user and get a user, but we don't have any routes to verify a login. So let's actually make a new route that we can use to verify a user login. And to do this, I'm actually going to go to the route where we're creating a user here. I'm going to go ahead and copy this, and I'm going to paste it down here at the bottom. I'm going to say this one is number 6, and this will be our login route. Typically, when you're doing a login verification route, you'll want to keep it as a post method because we need a request body. So that's what we'll do. Though we will need to change this route name here so that we don't confuse this route with the one that creates users. So for right now, we'll just name this one /users/login like this. So if we want to verify a login, we can just call this path right here. We're still going to need this DB variable to access our database, and we're going to use this taken email as well. Although I'm actually going to rename this to user instead of taken email. Now I'm just going to go over here and I'm going to delete everything else down here that we just don't need. Now let's think about what we need to do. I talked about this a little bit earlier, but here's what we need to do in this route. We need to check and see if an email matches the email that a user passed in. Luckily, we're already checking for that with this user variable right here, where we're searching our database for that email. If this email is found, we check the password. If it is not found, that means the email doesn't exist and therefore is not valid. If the email is found and the password is correct, we will allow the user to log in. If the email is found and the password is incorrect, we don't allow the user to log in. Simulating this behavior is actually pretty simple with some if-else statements. So first, I'm going to say if user, meaning if the user is found, and I'm also going to add an else statement, meaning the user was not found. And inside this else here, we're just going to write to the response body by calling what we're familiar with, response.json. And for this, I'm actually going to make it an object. I'm going to give it 2 fields. I'm going to have success and message. Success will just be a Boolean, and we'll just say this is false because obviously the login did not go through. And then we'll give it a message too, just so we know exactly what happened. And we will say user not found. If the user is found, meaning we're at this if statement here, then this is where we will look and see if the password is correct or not. I'm going to go ahead and make a new variable in here. I'll say let confirmation. I'm going to set it equal to bcrypt, and then I'm going to set it equal to the compare method that we just talked about. And this is the method where we can compare our encrypted password with the password that the user passed in. And those will be our 2 arguments for this method right here. The first thing should be the password the user passed in, which is just stored in request.body.password. And then the second should be the encrypted password, which should just be stored in user.password. Since user is this object here that we're obtaining from Mongo, and then the .password will actually grab our encrypted password string from the database. And just so we don't forget, we'll add await in front of this method here, because technically this compare method is asynchronous. If the password is validated, meaning this compare goes through and says these 2 things are compatible, then this confirmation will be true. Otherwise, it will be false. So if we want to simulate the responses here, what we can do is we can just say if confirmation is true, then what do you want to do? Well, we want to write a response that's going to say successful, and we're going to return the user. Else, meaning it's false, we also want to write a response to show that it was unsuccessful. For this first response, meaning where the password was successful, let's just give another object, and we'll say for this one, success is equal to obviously true, and then we're going to give the user back to the front end which again is the user from our database. And then for this one, this means the username, or sorry, the email was correct, but the password was incorrect. So I'm going to say success is false, and we're also going to give it a message, and we're going to say that we're just going to say incorrect password. So basically, with this kind of weird looking if and else statements here, we have three different possibilities. Either one, the email entered in is not found at all, in which case this else will trigger, saying that the user was not found in the database. The other two possibilities are if the user is found, and then if it is found, either the password they entered in is correct, which we run this code, or it is incorrect, which is where we run this code. So basically, depending on if this confirmation comes back true or false, will depend which one of these two is returned, assuming the user is found in the first place. Now, you might be wondering, why am I actually returning the user object here back to the front end in the response where it goes through successfully? Well, we may need some functionality on our site, like a profile page, where someone can look at their own user information, which is why we're returning it back to the front end here so that we can use that user's information however we want. And now this route should be all good to go. So I'm going to go ahead and save this file here. And now that we have the backend functionality to verify a user login, let's head back into our API file so we can write a function in the front end to call this route. I'm going to name this function, I'll say export async function. I'm going to call it verify user. And it should take in a user argument because we need to pass it into the backend route. And then just like we're doing with these other routes, I'm going to go ahead and say const response equals Axios, and it should be a post method. And then we're going to want to call that route, which is going to be URL, and it's /users/login. And remember, this response here will be an object that has some sort of success property no matter what it did. So what we can do is actually check if the success is true or false. So I'm going to say if, and actually make sure we add a wait here. I'm going to say if response.success, meaning the success is true and it went through, we want to return the information of the user, which means we will return response.data. Oh, and I forgot to add this user, should be right here. So we're passing it into the request body. And then we'll write an else statement, meaning the login didn't go through successfully. I'm going to actually throw an error. I'm going to say throw new error. I'm just going to say, I'm going to actually pass in the status text of the response. This way, it'll basically throw an error and tell us what went wrong in the process. Now that we have this check, this function should be complete. So we've written the backend functionality to verify a user login, and we've also just written the front end function that calls that backend route. So now we're ready to get back into our React code to implement this. Okay, so let's actually head back to our landing page now. And right now, the view that we're looking at here is the view to create our account. And I mentioned on the landing page, you want to have two views, one where you can create an account, but also one where you can log in. So let's actually go back to our files here. And we have this landing page here that has create user. We also need to develop this login component. And you know I love to copy and paste. So I'm actually going to go ahead and select everything in this file. And I'm actually going to paste it into the login file. And we're just going to change a few things. Obviously, firstly, we'll change this. And then at the import, we don't want to import create user. We want to import the verify that we just made, this verify user. So let's import verify user from our API file. And then for our login page, we're not going to have the user pass in their name, email, and password. We're just going to do email and password. So let's go ahead and have email and password here. And then right here where we're passing a name, we can go ahead and delete that because we don't need their name, just the email and password. Let's make sure all this text should be fine. Instead of saying create account, this right here should just say login, and the rest should be, it should be the same. And we'll just need to change this handle submit function because we obviously don't want to call the create user function. So let's actually change this to verify user, and we still need to pass in the user object, so we'll keep that argument the same. I'm going to take away this thing here, and I'm just going to console log out the response. I'm going to go ahead and save this component. Okay, now if we go back to our landing page, let's actually import this login component. So I'll say import login, and we'll import it into this file. And now, right now, we're just rendering the create user component. But we want to be able to switch between the create user and login components. So how do we do that? One way we could do it is to make a piece of React state that will basically just be a Boolean variable that if it's true will mean one view, and if it's false will mean the other view. So I'm going to go ahead and import useState from React, and I'm actually going to make a Boolean variable up here. I'm going to say const, I'll just call it view and set view. And let's set it to a default of 0. And just so we're on the same page here, let's say if view equals 0, that would mean that we're in the login mode. And if view is equal to 1, that would mean we're in the create mode, which means that if we have a default value of 0, the default view will be the login page. And to go ahead and simulate the ability to switch between the two of these things, let's make a conditional statement here. And we'll say if view is equal to 0, actually, let's just do this. If not view, meaning it's equal to 0, that will mean that we are in login mode. So if that's the case, let's do the question mark for the ternary operator, and then we want to render out the login components. Otherwise, we want to render the create user component because that would mean that the view is equal to 1 or true. So if I go ahead and save this file, you'll see we now just switch to our login view. However, I do want to have the ability to switch between the two views, so let's actually add some stuff in here. So I have to add these tags here because I'm going to add some more stuff. So I'm going to add this tag, put login in here. Let's do this. And then in addition to having just the login, we want to have a button. Let's do a button for now. Let's say button. And then this will say create new account. And this will give us the ability to switch between the other view. And then we'll do the same thing for create user. We'll make these tags here. We'll give it this. And then we will say a button to switch back to the login view. Okay, so now if we save our page here, you'll see you have this button that says create new account because we're on the login page. However, this button doesn't actually do anything right now because we don't have any on-click events. So let's add that. So let's add an on-click event. And this will just say that we want to set the view to whatever it is currently not. So I'm going to say set view to not view. And then we'll do the exact same thing for this one actually. Oops. Do the same thing for this one. And that will do the same thing. If I go ahead and save this, now if I click them, you can see I switch between the two views. So when I first load the page, if I refresh it, I'm automatically on the login page. But if I click create new account, I can go to the create user page. And now we've just simulated the fact that we can switch between our two views however we want. Before we go any farther, let's test out our login. Right now, we're not actually doing anything after we log in besides calling the login route and then printing off the response. Let's see what happens when we try and do that. So for email, I'm going to enter in austin@outlook.com. And then password, I'm going to do 12345. I'm going to open up my terminal here and go ahead and click login. And it's saying we're having a 404 not found error. So I'm going to go ahead and actually restart the server just to make sure it's been restarted since we've done our implementation of the login. Go to node server.js, run this again, and let's try this again here. So I'm going to go ahead and do this, and we're going to press login. And it looks like we have another error here. It says uncaught and promise error okay in our API file at line 73. So let's look at that. Okay, so it looks like it's throwing a file on the, or throwing an error on this right here. I'm actually, just to see what this is printing off, I'm going to do a console log. I'm going to console.log response here. I'm going to go and save this file. I'm going to retry this again and see what our response is. Okay, so we're getting something back. We have our data field here, success and user. Oh, you know what? I think I know what it is. Right here, we're saying if response.success, but it should be if response.data.success. So I forgot that data there. And then this, the return should be response.data. Where is it? .user instead. So let's fix that. Let's do response.data.user. I'm going to go ahead and save that. And now let's actually try this again here. Let's do a login. And okay, now it actually is printing off the user in our login component, and it looks like we're receiving it just fine. So it looks like the login is working now. I'm going to go ahead and just delete this console.log just to get this out of the way. And let's head back to our login page. Now that we know we're getting something correct back from the backend, let's take care of what we should do once the login is correct. And there's two primary things we want to do. Number one is that we want to navigate off the login page and head to the home page. Number two is that we should store the user object in session storage. Let's start with redirecting the user to the home page if they've successfully logged in. This is actually really easy to do thanks to a hook in React Router called useNavigate. It's basically just a function that you can pass in a route to, and it'll take you to that route without having to click anything, which you would normally use a link for. To get that useNavigate hook, we can go ahead and go up here, and we can just import useNavigate, and it's not going to autofill for some reason. We'll say useNavigate from, and this is from React Router DOM. And then at the top of our component here, I'm going to write const navigate equals useNavigate. If you're familiar with React, you know that hooks can sometimes get problematic when not called at the base level of a component. So it's standard practice for these kinds of hooks to make an alias for them, which we just did with this navigate variable. All we need to do to call this hook is go into our handle submit function here, and I'm going to go ahead and backspace this. And whenever we want to call this hook, all we need to do is type the name of the hook and then the route we want to navigate to, which for us is just /home. But wait a minute, we only want to actually navigate to the home page if the login was correct. If you remember with this verify user function, we are just returning the user if the response went through successfully. So we're already doing the check there, which means if it wasn't successful, this response object is going to be empty right here. So all I need to do to check this, I can just say if response, meaning something came back through, then we can navigate to the home page. Else, if it didn't come through, let's just alert the user and let's say login failed. And now let's actually test this functionality. And real quick, before we do that, I'm actually going to go in here and instead of throwing an error, I'm just going to return just to make sure this if works correctly. So I'm going to go ahead and save this. I'm going to type in something completely random to make sure it's the wrong information. Click login, and it should say at the top, login failed. I can do it with any number of random login stuff. If I just do this, I'll say login failed, and I'll keep doing that until I put the correct information in. So if I go back to austin@outlook.com, go 1, 2, 3, 4, 5, log in, and now it has taken us to our home page just as intended. Now that we know this is up and running, let me quickly go back to the session storage thing I mentioned a moment ago. I mentioned that we should store the user object in the session storage, meaning in a client's browser session, because that will allow us to grab their information if we want. For example, if we were to have some sort of profile page, we need the info of the user that's logged in, hence why we'd want to store their information in the client. And you can actually see your own session storage if you go into your thing here, and you go to this tab application, and you look in this tab right here, session storage, and this is where anything that is stored in session storage will be at. Now, what we could do is just store the user object that logs in this session storage here. So we could have for a key, let's say like user or something, and then the corresponding value would be like an object. We might say like something like an ID, and it's just some random numbers. And then we could have like a view type, and we'll say like they're an admin view or something along these lines. However, the problem with doing just this is that session storage is on the client's machine, and they have full access to see and edit it. Meaning if I wanted to restrict access to certain pages based on the user object that we have here in the session storage, someone with not so good intent can maybe go into the storage and then alter their own data to try and perform actions they aren't permitted to. Like for example, let's say like when somebody first logs in, they're just a regular user and they have no administrative capabilities, right? They go into their session storage, they see that this view here says user, and they literally just go in here and change it to admin, and now they can see all the stuff that the admins can. This is obviously not something you want because it is a security risk. The way that most apps get around this is through what we call an authentication token. Whenever the user logs in, our backend generates an authentication token that is signed with a private key. This authentication token can be decoded to obtain our user data, and is stored in our session storage instead of the raw user data itself. This token would be encrypted, meaning it would just look like a random string of letters, like it would look something like this, because it is an encrypted string that actually holds our user data. And then what we can do, anytime we want to make requests to the backend that require authentication, we'll pass in this authentication token, and our backend will verify that it is valid. If it is valid, we can proceed as normal. But if it's invalid, meaning it's expired or the user has altered it in some way, the backend request will not go through. This is the way that probably 90% of web apps do login verification, through some sort of authentication token. Now, enough talking about authentication tokens, let's actually implement it in our code. And it's actually very easy to do with just a couple of lines because there's libraries that can handle most of it easily for us. We're going to use a kind of token called JWT, which just stands for JSON Web Token. And the library we're going to use is actually called JSON Web Token. So let's go ahead and open up our terminal here. Go here. Let's cd into our backend folder where we're going to use this, and let's npm install JSON Web Token, spelled just like this. Press enter, and it'll install this library. Once we've installed this library, let's actually go ahead and navigate to our user route here, and let's import this library at the top of the file. To do that, it's very easy, just like we did with everything else. We'll say const JWT, that's what we'll call it for now, equals require, and we'll do JSON Web Token. Once we've got that imported, let's scroll down to the route where we're actually logging in a user, which is right here. In our code right now, whenever a login is successful, we're just returning the raw user data right here. Here's where we change that, and instead we want to return an encrypted authentication token. And we'll need two things to do that. First is our payload, which is our user object right here that already exists. And the second is a secret key. Since we already have this user object, let's get the secret key real quick. This secret key could technically actually be anything really. It could be a string of numbers or letters. It doesn't actually really matter. It's just an identifier to let the program know it's you trying to access it. And just so we didn't have to actually write any extra code in our program, I actually found this online node compiler here. And I found this code right here. I'm not sure if you can see it. Let me zoom this in a little bit. Scoot this over. This code right here, it just uses a module called crypto, and it basically just makes a 32-byte hexadecimal string that acts as a secret key. So I just had it generate one for me right here in this terminal. You could do the same thing if you wanted to, or something like it. Like I said, it doesn't matter what the key actually is. However, it is probably preferable to go a bit longer like this. In my case, it's 32 bytes, because the longer it is, the more safer it is in practicality. If your key is something super simple like the number 5, that can really easily be guessed, which means people can probably bypass your authorization. So what I'm actually going to do is I'm going to go ahead and copy this key here that I just got, and I'm going to head over into our environmental variables like we made at the very beginning that has our Mongo string in it. So right now we just have this Atlas URI. I'm actually going to make another one in here. I'm going to call it secret key, and I'm going to set it equal to this string that I just got from this little node terminal. And this right here will actually act as my secret key that I use whenever we're getting our JSON web token. So I'm going to go ahead and save this file here. I'm going to go back to our user routes. And if you recall, actually, if we go to, I believe it was not server, but it would be connect, go to the top here. Right here is how we're actually importing the environment variables. So let's actually take this line of code. I'm going to go ahead and copy it, and I'm going to paste it in our user routes file here. So I'll paste it just right at the top up here. Go ahead and save this. And if you also recall, the way we access it is by doing process.env and then whatever the name of the environment variable is. In our case, our name is secret key, which means to access it, it would be process.env.secret-key. So with that being said, let's go back into our user routes here. Let's go ahead and scroll back down to the login. Now that we have both our secret key and we also have this user payload, which is our user object, we're ready to create our token. We've already defined JWT at the very top of the file as being the import of the JSON Web Token library. So let's actually call it down here in our login route where we know the login was successful. To create our token, we just need to write one line of code. We'll just write const token equals JWT, again calling the JSON Web Token library, and we're going to call .sign, because sign is the method from this library that we use to create the token. And we need to pass in 3 things here. Technically only 2, but the third is a optional thing. The first argument is the payload, the second one is the secret key, and the third one is an option that we can use to customize it, like saying how long we want this token to last. So first I'll pass in the payload, which is just our user object, so we'll say user. And then next it is the secret key, which is in process.env.secret-key, as we defined it in our environment variable file. And then lastly is the optional customization argument, where we can set as an object, and we're just going to give it a field. We're going to say expires in, and then we're going to give it a value of 1 hour. So basically this token will last for 1 hour long, and after then it will be expired. And it's just as simple as that. Now what we've done is encoded our user data into this JSON web token right here, which will allow us to safely store user information and the front end. And the very last thing we need to change is, instead of returning the raw user object here, we obviously need to instead return the token that we're generating. So we're just going to replace the user with token. And I believe we should now be good to go. So let's go ahead and save this file. And let's return back to our front end to get this finished up. So I'm going to go ahead and head over back to our login component here. And let's actually now add that token to our session storage so the user can store their own information in their client browser. Before we test this, we'll need to change one thing. In our API file right here, we're returning the response.data.user, but we replaced user with token. So let's actually change this to token. Go ahead and save this file. And now we want to figure out how to use session storage. And lucky for us, it's actually super simple. If you want to add an item to session storage, it's just session storage.setItem. And if you want to get something from session storage, it is session storage.getItem. So what I mean by that is we can just call session storage.setItem, and we need to give it a key and a value, kind of like a object. So let's say user, that's what we'll call the object. And we're just going to pass in response, which is equal to our JSON web token. So let's go ahead and save this file. And let's actually go ahead and test this. So I'm going to go ahead and go back into our terminal here. And I'm going to make sure I pass in the correct information. Do 1, 2, 3, 4, 5. I'm going to log in. And it says login failed. That's most likely because we didn't restart our server since modifying it. So let's actually go back into our terminal. We have our server. Let's terminate this. And let's just go ahead and restart it. It's a little annoying having to restart it each time, but it is what it is. All right, so I'll go back. Oops. So we'll go back into our console here. And let's actually just try this again. And you can see it takes us to the home page. And let's actually go into our application now. And you can see if we go into our session storage here, we have this key of user, and the value is this super long string. That is actually our JSON web token. And with that, we're actually going to end this episode here. In this episode, we learned how to create a user in our database with an encrypted password, and also how to take those users from the database and verify their own login information and give them access to the site. Lastly, you learned how to create an authorization or authentication token for that user and store it in the session storage of the user's client. In the next episode, we'll finish up with the authorization part of our code, which will include us locking unauthorized people out of our site and handling permissions accordingly. Take care, everyone, and I'll see you in the next one. Hey, everyone, and welcome back to the MERN Stack crash course. In this episode, we're going to finish up with authorization and learn how to properly authorize parts of our web app. We're going to make sure people who aren't logged in can't access our site or do things they aren't allowed to. This is a super important and crucial part of web security. I'm not going to cover everything relating to security, but we'll cover at least a few basic things. When we left off last episode, we had just added our authentication token into the session storage container of the client's browser. The reason for this was twofold. First, it'll allow us to restrict access to pages based on whether this token is valid or not. Second, it'll allow us to decode the token and extract the user information from it, in case we need to have the user information for something like a profile page, which we'll actually develop at the end of the episode. Let's first start with restricting access to each of the pages on our site for people that aren't logged in. There's technically a couple of different ways we could go about doing this. The first thought that might come to your head is, oh, let's just add a user to our session storage here, and if the user isn't in here, then we just redirect back to the landing page and then force them to log in. This might sound reasonable, but remember, users can edit their own session storage, so this isn't super secure because somebody could technically game it. Realistically, the only way to ensure true security would be to send our token to our backend, where we can verify it and then perform the backend functions that we need to, like creating, updating, deleting, etc. What this means is that we need some sort of middleware that intercepts the request before it gets to the backend that will handle the verification. If it goes through just fine, then it can proceed to the backend. Otherwise, we should not let the backend routes get called at all. And there's actually a pretty straightforward way to do this. In our front end, we'll need to add our authentication token into our Axios request headers. So to do that, I'm going to go ahead and go to our login page here. And when we do that, every time we call a backend function, it'll get the authentication token. Let's do that first before we do anything else involving the backend. It's only one line of code, technically two if you're counting the import line, but we can knock it out really easily. All we need to do is in this login file, let's go up to the top here, and let's import Axios from Axios. Remember, Axios is the library that we're using to call our backend routes. Now let's scroll back down to where we're getting the login here into this handle submit function. And now if this went through successfully, in addition to sending our token to the session storage, let's write one line to add it to all future Axios requests. All we need to write is axios.defaults.headers.common, and then we're going to make a field called authorization. And then we're going to set it equal. And here is where we normally pass in our token. So right here, this actually kind of looks like a lot of writing here, but all of this line is doing right here is basically just making an authorization field in every single Axios request header, and it makes it the default. So you don't have to specify this authorization header every single time we send an Axios request. Now you'd think I would just insert in the token itself, which is stored in the response like this, but there's a formatting rule whenever you handle authentication tokens that you typically have the word bearer before the token. So I'm actually going to do a backtick character here, and I'm going to put this in like a JavaScript expression. And then in front of it, I'm going to put the word bearer just spelled like this. So if, for instance, our token was, let's just say 1, 2, 3, 4, 5, then this would be bearer space 1, 2, 3, 4, 5. And again, adding this bearer is just kind of a formatting thing, and it's kind of just a norm. And that's all it takes to make sure we're passing down our authentication token every single time we send an Axios request. So all these requests we're making in our API file right here to our backend are now going to have an authorization attached to the header, which will help us authenticate in the backend. So we'll go ahead and go over and save this login file here. And now that we've taken care of the front end part, let's actually head into the backend, and we're going to create some middleware that will verify that the authentication token is valid. And we're going to go ahead and start with our post-routes.js file. We do not want users to be able to interact with any of these routes at all if they haven't logged in yet. That means they shouldn't be able to retrieve the routes, create them, edit them, or whatever if they haven't logged in. And we're going to handle this through what we call middleware. And Express is actually a framework built for middleware and actually makes it pretty simple to handle something like this. Basically, we just need to write a function that will verify that the token is legit. And then we will add this function to every single route as a sort of checking mechanism. So let's, at the very bottom of this file, create a new function. I'm going to call it, say, function verify token. Just like every time we're calling a route, we need to give 2 arguments right here. We need to give the request as well as the response. For this function in particular, which is special, we'll also add a 3rd argument, which we're just calling next. This 3rd argument next, when using the context of Express, is just a function that basically says, okay, we're good to proceed to the next step. Meaning if it ends up going through that our verification is good, we can call this next argument here as a function, and that will send us to our backend routes where we can proceed. The first thing we need to do in this function is extract the token from the request header, because again, remember, whenever we did this thing in our login file, we are adding our token to this authorization header in Axios. So whenever we receive the request in the backend, we want to pull that token out of the authorization header. We can do that by simply just writing const, I'll make a variable, call it auth headers. I'm going to set it equal to request.headers, and it was titled authorization, spelled just like this. This will return to us the string that says bearer and then the token itself. We don't care about the bearer part of the token, so let's just extract the token itself from this header and ignore the bearer. We can do that by simply writing const token equals auth headers double ampersand auth header dot split. And then what we're going to do is split this string that we got from the header. We're going to split it by its white space, and then we're going to take the first index. All that this line is doing is saying if auth headers is found, then we're going to split auth headers by its white space and take the first index. So if I were, for instance, to have a token that says like bearer 1, 2, 3, 4, 5, whenever we call this split method, bearer would be stored in index 0 and 1, 2, 3, 4, 5 would be stored in index 1. Hence why we're taking index 1, because we just want the token, not this bearer part. If all goes well, this token variable right here should store our authentication token in it. If this doesn't store the authentication token, that would mean that the authentication token isn't included in the request header from the front end, which would then imply that whoever is sending the request is not actually logged in, because as soon as we log in, we set that header. So let's actually check for that. Let's say if not token, meaning the token doesn't exist, let's return a response that says the user isn't authorized. We'll just write return response.status, and we're going to give it a status of 401, because in HTTP, 401 means you're not authenticated. And then just like normal, we'll call .json, and then we're going to pass in just a message for right now. And for the message, we'll just say authentication token is missing, because after all, that's the only way this if statement would get triggered. Now that we've taken care of this case, what do we do if the token is not missing? Well, now the next step is to check if it is a valid token or not. If it is not, we need to do a similar thing like we're doing right here and just return an error response and tell the front end that something went wrong. And here is actually where our secret key that we made when we first signed the token finally comes into play. This is where we can call a method called verify, again from JSON Web Token, and we just pass in the token along with a secret key. If the two are compatible, we'll be good to go. Otherwise, there'll be a problem. First things first, let's import JSON Web Token into this file by going up here and writing const jwt equals require and we'll do JSON Web Token. Next, because I'm wanting to access our environment variables, namely the secret key, I'm actually going to go into our user routes here. I'm going to take this line that we copy and pasted from before. I'm going to do it again in this file just so we have this configuration set up. just so we can now access the secret key from our config.env file. Once both these things are done, we can get moving. Let's go back down now into the verify token, and let's call that verify method that I was just talking about. To do that, all we need to do is type jwt.verify. The first thing we need to pass in is the authentication token, which is just stored in token. And the second thing is the secret key, which again, when working with environment variables using this .env package, is process.env. whatever the name of the variable is, which in our case is secret key. Next, to streamline this process, we want to pass in a callback function that runs whenever this verify method goes through, and that'll actually be a third argument. So we're going to go ahead and make it an error function. We're going to give it 2 arguments, and I'll explain these in just a second. We're going to say error and user. We're going to do an arrow and then have this callback function written here. Basically what this callback function is it's a function that is going to run no matter what after this verify function is done running. If the verify did not go through correctly, we'll have something here in this error argument. If it did go through correctly, we'll have something here in this user argument, which is just the decoded user information from the token itself. First, we'll handle the case where the verification didn't succeed. So we'll go in here and we'll say if error, meaning the token was not valid, what we're going to do is kind of like we're doing up here with this return. We're going to say, I'm actually going to copy and paste this so it's a little less writing. I'm going to paste this in here. And then instead of returning a 401, I'm actually going to return a 403 because in HTTP, 403 means that it got the token, but it doesn't accept that it's valid. And then for our message here, I'm going to say exactly that. I'm just going to say invalid token. Next, let's handle the case where the token actually is valid, which we can just write after this if statement here. We don't actually need an else here because we're already returning if we hit this if statement. So I don't need an else statement here. I can just put it down at the bottom. Theoretically, at least for these blog post routes, we shouldn't need the user information like this right here when interacting with any of the posts. However, just in case, I'm going to set the request body to actually include the user. So I'm going to say request.body.user equals user. Meaning, if the token validation did go through, we'll add this user object to the request body in case we do need to use it. And then the very last thing we need to do here is just call next as if it's a function. And this is again the third argument I was talking about just a moment ago. It is a function that tells Express to proceed to the next step. In our case, go to the actual backend routes themselves. Now that we have this entire verify token function written, there's one last thing left to do before this works. We need to add this function to all of our routes up here. Like I said, we don't want anybody to be able to call any of these backend routes if they aren't authenticated in the first place. So I want to add this verify token to every single route in this file. And it's actually super simple to do this. All we need to do is to go into each individual route, and when we're calling the actual method like get, post, put, etc., we need to pass in an additional argument right here. And that argument is simply going to be the verify token function. So we'll say verify token, and we're just adding this as an argument. I'm going to take this code here, I'm going to copy it, and I'm going to paste it into every single one. That way, we're adding the verify token on every single one of our routes. Now, let me actually explain to you how this works practically. Let's say I call the route to retrieve all of our posts. So we're looking at this route right here. Before we even get to all this code here, because this verify token argument is here, we're going to call that function first, which means this code is going to run. If it ever goes to either of these 400 statuses, meaning it was incorrect or something bad happened, and that means the actual code in our route, like this code being right here, is never actually going to run. Because in verify token, before we even get there, if there's a problem, we're actually returning a response already. However, if it does go through successfully, that's where calling this next argument comes into play. If we go back up here, we're calling verify token. Let's say a verify token gets all the way through and then it calls next. Once next is called, it signals to the route that we're ready to move on to the actual code. Meaning if next is successfully called, then only then will all this code actually run. Let's now test this to see if this actually works. So I'm going to go ahead and save this file. I'm going to reopen our terminal, and I'm actually going to restart the server so it doesn't auto update. We'll make sure it gets all these new changes added to it. I'll restart the server right here. Then I'm actually going to go onto our site, and I'm going to go back to the landing page. And I'm also going to wipe out what's currently in our storage here so that we can start from scratch. First things first, let's try and bypass this login page by just going straight to the home page. I'm just going to go /home like this, and you can see that there is nothing here on our page. And I know there's errors here, but this is exactly actually what we want. You see this error here says 401 unauthorized. And that is actually this right here saying 401 authentication token is missing. And that is because we don't actually have any authentication token here in our session storage, meaning that this page is inherently unauthorized to get to. And now our backend is looking for that, and it's stopping it before it can even load anything on the page. Great, so we know this works now. Let's actually test the next thing. Let's go back here, and actually I'll keep my console open, clear this out, and I'm gonna actually go ahead and try to log in. So I'll do this austin@outlook.com, 1, 2, 3, 4, 5, log in, go ahead and click it, and it says here that we are also unauthorized. Okay, so off camera, I actually was trying to solve this bug, and I found out in the backend, in the post routes here where we're verifying the token, this A in authorization actually needs to be lowercase, not uppercase, and that actually was the problem. So if I go ahead and save this file, I'm going to go ahead and open up our terminal and then restart the server. Now I'm going to go back to the login page here. I'm going to go log in like normal. And you can see this time now everything displays correctly just because we changed the capitalization on this authorization. However, now that that's fixed, I actually, when I was debugging that, ran across another problem. And that's if I refresh the page, things don't load anymore, and I actually get the 401 unauthorized once again. And that's actually because whenever the page gets refreshed, we're setting our Axios headers right here, but whenever the page gets refreshed, it actually wipes this out. So basically what we need to do is find a way to, every time it refreshes, we need to watch for that, and we need to run this line of code again. It actually shouldn't be too bad to do. I'm going to try something here. I'm going to go ahead and, I don't know why I clicked that. I'm going to go ahead and just copy this. And I'm actually going to go into our root app right here. And I'm actually going to add some code in here. Let's wipe all this out. That will basically just watch for when the entire app refreshes. So I'll import a use effect here. And I'm going to write a use effect with an empty dependency array. So it'll run whenever the app first renders. Empty dependency array. And I'm going to paste this line in here. The only thing is this response variable no longer exists, but lucky for us, we are still storing this token in the session storage, which does persist upon every refresh. So actually in this use effect, I'm going to grab that. I'm going to say let token equals, I'm going to say session storage dot get item. That's going to be user. And then once we have that, then we can pass in right here, bearer is equal to token. However, we only want this to actually run if there is a valid token in the session storage. So let's actually write an if statement. Let's say if token, and then we're going to put that inside right here. And now theoretically, every time the page refreshes, this should run. It'll grab a token from session storage, which does persist through a refresh. And if it does exist, it'll reset the Axios headers. So I'm going to go ahead and save this page. And I'm going to go ahead and refresh this. And it looks like there is still a problem. Axios is not defined. It's probably fixed. Import Axios from Axios. Save it here. And now everything's back on the page. If I refresh it, everything's still back. And we have not lost anything. And now that we've fixed those things, let's actually go back to our landing page here. Let's go to our session storage and actually wipe out this key right here. And let's do the original testing of seeing if it still locks us out. So theoretically, if I go to the home page, it shouldn't display anything. But now it seems to be working as intended. And just to make sure, just a last final check, we'll log in again. We will 1, 2, 3, 4, 5, go here. And now we can see everything on our page because we are logged in and we are authorized. And now that we've checked the route to get all these posts, let's actually check and see what happens if we try and create a blog post. Hopefully we should get an unauthorized message as well. Let's go and clear out the user here. Let's go ahead and refresh this page. And it'll still show this on the page here. But when we go and do this and we try and just fill something out. Okay, it actually wiped it out. Let me go preserve log so I can show you this time. So it doesn't wipe it out. Let's go this. And it'll say post 401 unauthorized, which is perfectly as intended. Not only can we not see the post, but we can't create a blog post either because it won't even let us submit it. Now that we know this works, let's move on to the next step. Obviously, it's nice that we stop any backend functionality from happening if the user isn't authorized. But what about the front end? Is there a way that we can stop the user from even navigating to these pages in the first place? Because we're using session storage, we can't 100% really guarantee this, hence why we did the backend stuff in the first place. But what we could do is just in our front end, check to see if there is a user object in our session storage. And if there's not, then we can just redirect back to our landing page. To do that, I'm actually going to go into our code here and I'm going to navigate to our layout component, which we have actually not touched in quite a long time. If you'll recall, this layout is the parent component to all of our front-end pages that contain a navbar on them, which means every page except for the landing page. And that's actually perfect for us because the landing page should be the only one where you can be unauthorized. We can just do a super simple check in this layout component to see if the session storage has a token in it. So let's just go in here into the function. Let's just say let user equals session storage dot get item, and that will be user. And then what we can do is write an if statement saying if the user doesn't exist, we can redirect. So we'll say if not user, meaning the user does not exist, then we want to navigate back to the landing page. And to navigate, we know that we're going to use the use navigate hook. So let's import use navigate here. And then let's make an alias like we normally do. Const navigate equals use navigate. And then we just want to call this navigate function. And let's pass in the route of our landing page, which is just a slash with nothing else after it. Now, right now, this whole layout component doesn't actually have any reason to ever re-render, which means that this code isn't really going to run the way we want it to. We actually want to add a use effect hook to get it to run every time a session storage changes. So we're going to do a use effect, and we're going to wrap all this in a use effect here. We're going to do this, the function. We're going to paste this inside the use effect. Oops. We're going to paste this in here. And then since user is a dependency, we want to add that in the dependency array. This will make sure that if we were to take an action like log out from this page and we were to delete the user from session storage, this layout component would automatically pick that up and then redirect us to the landing page. And while we're here, speaking of logging out, let's add that real quick so I don't need to keep going in here and manually wiping out my session storage. I'm going to go ahead and save this file. And then I'm going to, and you can see it actually took us back to the landing page here automatically. And I'm going to go to the navbar actually, and then I'm just going to add a button. I guess I'll add it right here. And I'm just going to say, it'll say log out. And then on click, all we're going to do is something super simple. We're just going to call session storage dot remove item, and we're going to remove user from session storage. Now, real quick, let's test this to make sure it works the way we want it to. So I'm going to go ahead and save this file, and let's actually log in. Get our login information, get on this page, and now we have this kind of really badly styled logout button. We'll do the styling later, but now if we click logout, it looks like it didn't actually log us out. So let me check real quick. Okay, so yeah, I actually did wipe out the session storage. It just didn't redirect back to the landing page. So we can actually have a quick workaround and just force it to go back to the landing page. So I'll just write a quick function handle logout. And here we'll just call this line. And then we're also going to call, we're going to get use navigate in here as well. Import use navigate. We'll say const navigate equals use navigate. And then we're going to call it in this function as well. Force it to go back to the landing page. And then here, we're just going to pass in that function. We're going to say handle logout. So I go ahead and save this file. I'm going to go back to the landing page and let's log in and try this again. Let's go austinalec.com, 1, 2, 3, 4, 5 for the password, log in. And now let's go log out. And you can see it takes us back to the landing page, which means it is probably working as intended. Next, let's try testing out other routes to other pages if we're not yet logged in. If I try and now go to /home up here in the URL bar, you can see it actually just redirects me back to the landing page. I can't even get there by manipulating the URL. If I try /about, it does the same exact thing. I can go /contact, same thing happens. It keeps redirecting us back to the landing page. Let's now move on to the next thing. A moment ago, I talked about how whenever we verify the user in the backend, we could add the user object to the request body in case we need it. One place where we actually will need it is whenever we're creating a post. If you remember, we made each post have an author field, and we've kept it empty thus far. So if I go to our post routes here, and we look at where we are creating a post here, you can see we have this author field. And right now it does say request.mongo.author, but that is empty on the front end when it's passed in. So this is always set to none. And I can actually show you that if we go into our Mongo database here, look at our post, and you can see these names here. These names are just made up. But if I were to create a post like manually on the site right now, it would not have any author filled in. Now in our middleware, we're actually passing in the user data to the request body. So let's actually add the author information when we're creating a post. So we'll add it right here in this field. Whenever we're storing the user in the middleware, we're storing it in request.body.user. And then for the author, let's actually grab their ID. So let's say request.body.user.id. And it's actually just as simple as that. We've just added and created a way for us to give an author to a blog post that we create. Now let's actually save this. I'm going to go ahead and restart the server. And I'm going to test this actually. So let's go do this, restart the server. Let's go back to our page here. Let's re-log in. And then I'm going to go to the create post page. I'm going to go here. I'm just going to do some sample stuff, just random letters. Do this, click submit, and it looks like it went through. So I'm going to go ahead and check this. Let's look at our post here. And there should be a fourth post right here. And you can see this author ID that we have in this field should, in theory, so it's 666273, should match my ID and my user. Yep, 666273. This now gives us an easy way to connect each blog post to each of the users. So now these posts actually are related in some way. One unique thing that this will actually allow us to do is pull all blog posts that belong to a single user. For example, the user that's currently logged into the site. And now that we have that, let's actually build out the final page on our site before we call it good. And that's going to be the profile page. This page we'll just make super simple for right now, and it'll just contain a couple of things. Let's say it'll have your name, the date you joined, and then a list of the blog posts belonging to you. We already actually have the skeleton for this file. It should be in profile.jsx. So let's head to this file and let's get to work. First of all, we know we're going to be making a list of blog post cards, kind of like we're doing here on the homepage with these cards. So let's go in here and let's import that BlogCard component that we made a couple episodes ago. So it's not autofilling. Let's do a BlogCard from, should be components / BlogCard. We're also going to use useState and useEffect. So let's import those as well. Import useState, and we'll also import useEffect. Lastly, we're going to be needing the getAllPost function too. So let's import that. Import getAllPost. That one's not autofilling either. So getAllPost from, and that should be from API. Let's first make two pieces of state, one for the post on the page and one for the user themselves. So for the post, we'll say const post set post equals useState, and we'll default it to an empty array. For user, we will default it to an empty object. We'll say user set user equals useState as an empty object. Next, let's make a useEffect with an empty dependency array, so that we can specify the behavior for when the component first renders. So we'll give this empty dependency array here. And just like every single other time that we're loading in data from an API, we're going to write our own function in here. We're going to say async function. Let's just call it load user data. Do this, and then we'll make sure to call it here at the bottom of the useEffect. Now, the $1 million question is, what do we actually put inside this function here? Well, before we call getAllPost up here, it would be smart to retrieve our user information first. How can we get that information? And actually, there's an easy way to do it, and that's by decoding our authentication token that we have in session storage. Remember that this token here, this string, is just an encrypted string of our user data, and we can decrypt it to get our data from it. In order to do that, we'll need to install that same JSON Web Token library in our front end. So let's go ahead and open up a terminal. Let's open one up here and make sure we are CD'd into our front end folder. And then I'm going to write npm install JSON Web Token, same as before. Once I've done that, I'm going to import a function in here called JWT decode, and that is actually from JSON Web Token. This function does exactly what it says it does. It decodes, meaning decrypts the token and breaks it into its original parts, which is our user data. So now in this useEffect, let's actually call that. So let's first grab the token from session storage. We'll say const token equals session storage dot get item user, because that's where it's stored. And then we can call this JWT decode. So we'll go here and we will say, we'll call it decoded user. We're going to set it equal to JWT decode, and we're going to pass in our token. If all goes well, we should now have our user data stored in this decoded user variable. Next up, let's make a new variable and let's actually get all of our posts. So let's do this. Let's say const all posts equals, and this is what we're going to call the get all posts from our API. We're going to say get all posts just like this. And we'll actually make sure to add the await in front of it because this is an asynchronous function. And you may be wondering, why are we getting all the posts for this page? Well, glad you asked. Now that we have all the posts and we have the user information, we can easily filter out the posts that belong to this particular user and then display them on the page. To do that is actually pretty straightforward because JavaScript has a built-in filter function. If we want to use it, we can just say, let's make a new variable for it. We'll say const filtered post. We'll say equals all posts dot filter. And this is the built-in JavaScript method. We'll say post for an argument. And we're going to say filter all posts where the author of the post is equal to the decoded user's ID. And this magic line here will return an array of all the posts where the post author is equal to the ID of the current logged in user. Meaning if I'm logged in, this variable here will now store all of my posts that I've made. The last thing we're going to do in this use effect is store that in our React state. We already made a state variable called post. So let's go set post, and we're going to set that to filtered post. And then for our user information, we're going to do that as well. We're going to say set user, and that is stored in decoded user. So now we have our filtered post up here in this state, and we have the user information in this state. And with that, we should be good to go. We have both our current user stored in React state as well as the blog posts that belong to them. All that's left is to write out in the JSX so it displays on the page. So we'll actually just be super basic. I'm going to write labels for each field. So let's do a couple labels here. I'm going to do 3 labels. We'll have one for name, we'll have one for email, and then we will have one for join date. And then for each one of these, let's just do like a, I don't know, something like a header 2. Let's do for each field. And then for each field, we'll just want to do whatever the information for the user is. So we'll say user.name. This one will be user.email. And then this one will be user.joinDate. We go ahead and save this file. It looks like our page blinked out. So let's check our console here. And it says source API does not provide an export name get all posts. Let's check that. So we have get all posts. Let's go into our API here. Oh, it's just get post. Okay. Sorry, that's my bad. I'm getting lost where we're working in your profile. Let's just do get post like this. Save this file. Let's refresh this. Looks like we're still blanked out. It says cannot read properties of undefined. Actually, let's reload this page here. Let's go ahead and get out of here. Looks like we still have a issue here. Okay, so off camera, I tried messing with this decode function from that JSON Web Token library, but I was having a bunch of problems with it, so I'm actually using another library just called JWT-decode. So if you want to get this library, just make sure you can go into your terminal and then just run the command npm install JWT-decode like this. And then like I did here, you can import it just like this. And then on this line, instead of calling it just the JWT_decode, we're going to call this .jwt_decode and then pass in our token. And this will actually decode the user for us instead of doing what we were doing earlier. And I also just realized this get all posts. We changed the import, but didn't change this. So let's change this back to get posts. Let's save this page. And now let's actually map over the blog posts and display them as blog cards, kind of like we have here on our homepage. So I'll go back here. And in here, I'm going to write a map statement. So I'm just going to do, it should be in post right here, or it should be post plural. And we will say post.map. And for each post, we're going to return some JSX. For each one of these posts, we want to render out one blog card component because after all, that's what each one of these little components is right here. So I'm going to go ahead and just render in blog card because we've already imported it into this file. And then remember, for each one of these components, we need a post prop. So we're just going to go ahead and give it post, which is this argument right here. Then let's go ahead and save this file. And now you can see this post is right here. And that makes sense because as you can see in our database, if we go ahead and look at this post here, that is the only one with an actual valid author ID. I'm actually going to test something out here. I'm going to copy this ID. I'm going to go into one of these random posts here and I'm going to edit it. And let me open up the screen all the way. I'm going to edit in here. And then for, let's see, we want to get the author. Let's change this field. Instead of saying John Smith, we're going to make it equal to my ID. I'm going to go ahead and update it. And now let's actually test. I'm gonna go ahead and shrink this back down, go up here, refresh the page, and now we have this post on my page as well because it thinks that I am now the author of it. And of course, this looks very, very ugly, but don't worry because we're getting to the styling episode very, very soon. And with that, we're gonna end this episode here. In this episode, you'll learn how to protect your backend routes through proper authorization protocol, how to handle encrypted user information in the front end in the form of an authentication token, and also how to create a profile page for a user where we're extracting their important details. In the next episode, we're going to cover media management, and by that, I mean being able to add images and photos to our website. Take care, everyone, and I'll see you in the next episode. Hey, everyone, and welcome back to the MERN Stack crash course. In this episode, we're going to take care of storing media like images and video in our database. Up until this point, every piece of data that has entered our database has been in the form of a JSON object, where each object basically just contains properties that give us useful information about a user or about a blog post. However, there's a big thing that our app is missing right now. This right here is all just text. What if you wanted to store different forms of media, like images, videos, or audio files? Right now, we don't have any functionality to do that since we're just storing what is essentially just text. If we just go to a sample blog website, let's say NASA, for example, we can click on any one of these blogs here. And you'll notice how in each one of these blogs, there's always an image at the top. So this one has an image on it. I can go down to here. There's an image on this one as well in the blog information. I can go down here. There's also an image on this one. And in general, it's extremely common for each blog post, no matter what blog platform you're on, to have some sort of cover image or some type of title image like this one. Because of that, we should add functionality for our database to store images at the very least. MongoDB is great for storing documents and text data, but that's really all it can store. If you want to store images, there's a way to do it with MongoDB, but it's not recommended because Mongo isn't really made for media storage. We should use some other tool that we can connect to our app. There's a handful of different tools you could use for media storage, but the one I've used in the past is AWS S3. It's AWS's, meaning Amazon's, primary storage tool, and it's honestly pretty simple and easy to get set up. So before we get into any code using AWS, you want to make sure you have an AWS account set up. If you go to aws.amazon.com right here, you should be on some page that looks at least something like this. And then you want to go to the sign in here to the console. And this is kind of the root login page. If you don't have an account yet with AWS, go ahead and make a free account. I already have an account, so I'm not going to walk through the exact process to go ahead and set it up, but go ahead and set it up and make sure you choose the free tier because you shouldn't have to pay anything to get this account made. Once you sign in, it should take you to your AWS dashboard, which would look something like this. This dashboard has access to all of the AWS tools, which there are tons and tons of. We're not worried about other AWS features for right now. We just want S3 for storage. To find S3, go up here to Services, and at the bottom there should be the Storage tab. Go ahead and click on that. And right here you'll see this says S3. Go ahead and click on this link here. And what's nice is that once you visited S3, it'll say recent when you go back to your dashboard, so you can just go click on it without having to search through this services menu. AWS S3 stores media in what we call buckets. Buckets are pretty much the equivalent of collections in Mongo. Just like a Mongo collection can have multiple items in it, an S3 bucket can have multiple images, videos, or whatever else. As you can see, I already have one bucket here called Debuggo Development, which was some previous project I work on. If you want to make a new bucket, go over to this button here, it says Create Bucket, and click on it. First off, it should be in the same region that you made your account with. In my case, it is US East, which is US East 2. And then for the bucket name, I'm just going to name this something super simple for right now. I'm just going to call it Blog Storage. Actually, I'll go ahead and zoom this in so you guys can see a little better. And then let's scroll down, look at the rest of this customization here. We're going to block public access. We're going to keep this disabled. Tags I don't care about. Encryption, we'll just keep this type as the default. And we'll enable the key as well. We don't need any of these advanced settings. Let's just go ahead and click Create Bucket. And it looks like there was a problem. Bucket name must not contain uppercase letters. Let me do blog underscore. Actually, that's not going to work either. I'll do blog storage just like this. Bucket with the same name already exists. Okay, it's being a little annoying here. Let me just add full stack blog storage, see if that works. We'll go down to the bottom. Go ahead and click Create Bucket. And this time it looks like it created. So now we have this new bucket here, full stack blog storage, which again, like I said, is just like a collection in Mongo. Once you have this bucket created, you can click it and see inside the bucket. Obviously right now there's nothing in here since we haven't added anything yet. Just like with MongoDB, we can manually upload stuff if we want. For example, I could click this upload button right here and manually upload an image into our bucket. Obviously though, we want to be able to upload images and whatnot through our app, not manually. Now that we have this AWS bucket set up, let's get our uploading set up in our code. The first thing we want to do is in our terminal, install the software development kit for AWS, which we can do with one line with npm. So if we go into our terminal here, let's make sure we're looking in our backend folder. Then I'm going to write this line, npm install @ AWS SDK, which stands for software development kit. And it uses a library called client-s3. Go ahead and press enter here, and it should install this library. And again, AWS SDK means AWS Software Development Kit, and we're specifically installing the kit for the S3 client, which will allow us to interact with our S3 database that we just made. And once we've done this, I actually want to go and create a new file to handle all of our AWS logic. So right now, if we go ahead and look in our backend, I'm going to close out of all this stuff here, get all this out of the way. If we look on our backend, we obviously have our post routes file for every time we're interacting with the posts from Mongo, and we have the user routes file for any time we're interacting with the users in Mongo. But I want to make a similar thing for any time we're interacting with the AWS stuff. Because again, AWS is kind of like its own collection in the form of buckets. So I'm going to make a separate file, and I'm going to call it AWS Routes.js. Just to avoid us having to rewrite a bunch of code, I'm going to go into post routes here. I'm going to go ahead and Control A this to select all of it. Gotta copy it, and I'm going to paste it all into here. And we're going to delete a lot of this, but I just wanted to not reuse all this code. So I'm going to go ahead and just rename post routes to AWS routes using the Control F. So anywhere where we see post routes, we're going to change that to AWS routes. Go ahead and replace all. And then let's just change some of these around. So I know I'm not going to be using the route to get all of our AWS images all at once. So I'm going to go ahead and just delete this. We're going to keep the retrieve one, create one, update one, and delete one. And we're going to keep this verified token that we wrote last time, just so we can keep our authorization part intact. I'm going to go ahead and just renumber these. This should be 2, 3, and this should be 4. For this file, we're also going to need a couple of essential functions from AWS to make sure this works. There's pretty much a function for each action, like uploading, retrieving, and deleting. And there's also one for initializing the client. So we can import the library that we just installed by going up here. And let's say, I'm actually going to destructure the imports. So I'm going to write S3 client is the first one. We have one called put object command, which creates an object. One called get object command, which gets an object. And one called delete object command, which again, obviously just deletes an object. And to import them from the library, we can say equals require. And it'll be from exactly what we just installed. So AWS SDK / client -S3. And again, just so we're clear, this S3 client initializes the client, put object command creates an object in our bucket, get object gets an object from our bucket, and delete object deletes an object from our bucket. So actually, because we only have these three, we don't want to have to worry about editing images. So I'm actually going to just delete this one here, this update route. And let's just say this third route is to delete. So all we're going to have is the functionality to get a single image, to create a single image, and to delete a single image. Now that we know what functions we're going to need, these imported ones here, we can go ahead and start working on our routes. All of our previous routes that we've had have interacted exclusively with MongoDB, but now we want to work with AWS, so we need to change this functionality around a little bit. With MongoDB, we have functions to get the database and connect to the database, and we're going to need to do something similar with AWS. And for all of our routes here, instead of saying post, I'm going to change these to all to just say images instead. So we'll say images, and then images here. Let me go ahead and zoom this in one more time so it's a little easier for you to see. Now to connect to our AWS database, we can use the S3 client function that we just mentioned. To do it, all we need to write is const. I'll make a variable. I'm going to call this S3 client and set it equal to new AWS, actually new S3 client like this. And this will call this function that we just imported from up here. Inside of this S3 client here, we want to pass in an object that has the configuration settings for S3. So we'll go ahead and write curly brackets. And for this, there's two fields that we need to fill out. The first one should be the region. And in my case, I was in US East 2. So we'll put that as a string. It should be US-East-2. So I'm filling that out for my region string. The next field we want to focus on is called Credentials. And this will actually be an object. And this credentials object is here to verify that we're actually a valid user trying to get into the client. We're going to need two things in this object. We're going to need one called access key ID, and then we're going to need another one called secret access key, like this. We don't have those two things yet, so I'll show you exactly how to get them. AWS uses a service called IAM to authenticate users. So if we actually go back to our AWS page here, and we go to our services, go ahead and search for IAM, spelled like this, and you should see this IAM pop up right here. Go ahead and click it, and then go to the IAM page. Next, go ahead and go over to the Users tab. Then you're going to want to create a new user. I would probably name it something relating to the app. So I'm going to go ahead and go here. I'm going to name this, let's just say blog app, like this. And then I'm going to go ahead and click next. And it'll say add to group. No, we're just going to go ahead and not attach it to anything. Go here. And then we'll go ahead and click create user. And we have just now created a blog app user. Once you've created that user, go ahead and click on it in here. And then once you do that, go over to this tab called Security Credentials. Over here on the right-hand side where it says Access Keys, you should see something that says Create Access Key. Go ahead and click it, and it should take you to a menu that looks something like this, and it asks you what you want to use the key for. We're using it for application code running on our own local machine, so I'm going to go ahead and select local code. Go ahead and check this box and go ahead and press next. It'll ask you for a description tag, and for this, I'll just say used to connect blog app to AWS S3. And then I'm going to go ahead and click create access key. And this will generate your access key as well as your secret access key. I would definitely download this CSV file if I were you to keep track of your access key and your secret access key. Or at the very least, just go ahead and copy this here, paste it, and then write it down somewhere. You can always come back to this page to look at what your access key is, but you can actually never come back to see what your secret key is. Once you click off this page, you're never going to be able to find it again, so make sure you have it downloaded. Or, like I said, at least copied, so I'm going to go ahead and copy this, so it's copied to my keyboard, and then we can go ahead and press done. In our app, just like we're doing with our secret key for our JSON tokens, and like we're doing for Mongo, I actually want to store these in our environmental variables. So I'm going to go into config.env here, and I'm going to add two more things. I'm going to add AWS secret key, and I'm also going to add AWS access key. I'll set my secret key equal to this. I'll paste it in. I will go back to my access key here. Let's go back to my credentials. Go ahead and copy this access key, and we'll go ahead and paste it in too. So now we have our secret key and we have our access key. Go ahead and save this file. And now that we have those two things, we can go ahead and fill in these two fields. So since we're using environment variables for this one, we can just do process dot, oops, it should not be uppercase, process.env dot, and we named this one, it was AWS access key. And then on bottom here for the secret access key, it's the same thing, process.env.aws secret key. Once we have this region in our client, as well as the credentials, we're all configured to interact with AWS S3 in our code. One last thing I'm going to add up here just to help us out is just an alias for the name of our bucket. So I'm going to say const S3 bucket. And I believe, let me just go up here and make sure I have the right name. Let's go back to S3. And the name of it was, full stack blog storage. So I'll make a variable for that. We're just going to say full stack blog storage. Now that we have that, let's focus on making our three routes. And we know our three are going to be retrieving an image, creating an image, and deleting an image. So let's first start with retrieving an image. Let's actually first start with the route to go ahead and create an image. So we'll start with this route right here. Let's start fresh in this route. So I'm going to go ahead and delete all this stuff because we won't be needing anything relating to Mongo. Whenever we create an object like this, just like we did with our post routes and our user routes, we're going to store the object itself that we're uploading in the request body. So just so we can make it easier for ourselves, I'm going to make a variable for that. I'm going to say const file equals request.body. And this file will represent the actual image file that we're going to be uploading to AWS, which we'll be passing in from our front end. To create an object in AWS and put it into a bucket, we need to invoke this put object command here that we imported from earlier, and is taken again directly from the AWS software development kit. However, we first need to give it some parameters to know which bucket it is accessing, and to know what it should name the file. We need to make an object, which I just like to call, I'll just call it bucket params, equals, and it will contain three important things. Number one is going to be the name of the bucket we want to access. So I'm going to go ahead and name this field bucket, and its corresponding value is going to be the name of our actual bucket, which is stored right here. That's an S3 bucket. So we're going to say our name is S3 bucket, just like this. Number 2 is a key field, and this is what the file is going to be named in AWS. We assume our object is going to be a file, so let's make the key equal to file.name from this variable right here, which again is just our actual image file. Lastly, number 3, we need the actual content, meaning the image itself, so that AWS knows what it is that it's actually uploading. We need to call this field body, and its corresponding value is just going to be file. Now, all we need to do once we have this is invoke the putObjectCommand function. We'll also make a variable to capture the result of this call. To do that, I'm just going to say const data equals, and before we call the putObjectCommand, we need to actually put it inside another function, and that's going to be await s3 client.send. So basically, anytime we want to run any of these commands up here, like put object command, get object command, or delete object command, we need to run this line first, s3 client.send, and then inside of here is where we can put the command that we actually want to send. We need to say new because we're technically calling a constructor, and then put, if I can spell it right, put object command, just like this. And then inside of these parentheses, we'll just pass in the bucket params object that we just made, which has everything we need to know in order to upload our file. And then we're still just returning the data to our response through this response.json data. What we've just done now is created functionality in the backend to upload a whole file to AWS, namely an image. Obviously, we'll still need to take care of file submission in the front end, but the backend is looking good so far. Next, let's work on retrieving a file from AWS. So we're going to work on this route right here. I'm going to go ahead and wipe all of this out here. It's actually very similar to this route. So I'm going to go ahead and copy this, and I'm going to paste it in here. And let's just still make sure this should be a get method, not a post method. So we're good on that front. The only thing is, whenever we are getting an image from AWS, we're not going to be passing in a file down to this request body here. Instead, we're just passing an ID for our parameters, which is going to be stored. We'll say const ID, and that's stored in request.params.id. And in this route, we'll also need this bucket params object that basically just tells AWS what exactly it is that we're looking for. The only difference is, we actually don't need this body field because we're not uploading anything. And this key field needs to change to just match the ID of whatever image it is that we're trying to receive, which is stored in this variable here. And the very last thing we need to go ahead and do is instead of put object command, we're just going to change 3 letters and make this get object command so it matches this function that we're importing right here. Assuming this line runs successfully, what this will do is look at the bucket that we specified, and then it will look at the key that we gave it, and it will try to find an image that matches a key that is in this bucket, which means the result of this will be an image, and that will get stored in this data variable, which we are just writing back to our front end. One thing we should note though is that when AWS returns a file with this get object command right here, it returns it as a readable stream, not an actual image, meaning it's not readily available to display on our front end, which is a bit inconvenient for the client. The 2 ways I've typically handled this in the past are using blobs or base64 strings, both of which will allow us to return something a bit more convenient to the front end. For our purpose, we're just going to use a base64 string to return this data back. Base64 strings are nice for images because we can use them as image sources. Before we return anything, we actually want to write 2 lines down here. The first one should be getting the file type or content type of the data that we just grabbed from S3. So we'll just say const content type. I'll set it equal to data.content type like this. And actually the C should be capitalized, so it's just like this. This will let us know whether it's an image, video, or whatever else, and it's going to be used when we're returning our image string. The next thing we need to do is actually convert the data here to base64, which is fairly simple. All we need to do is go ahead and down here, create a new variable. I'm going to call it source string, set it equal to data.body.transform to string, and then we're going to specify base64. And this is technically for some reason asynchronous, so I'm going to go ahead and add the await keyword in front of this. All that this line here is technically doing is taking the body of our response data here, and then it is calling this method transform to string to turn it into a base64 string, and then storing it in this source string variable. Lastly, we just need to return something. When we're returning a base64 string as an image source, we need to do it in a certain format, and that's the reason we got these 2 variables right here. We'll just go ahead and write down here at the bottom, let's make a variable for it. It will be const, I'm going to say image source, image source equals, I'm going to do a backtick character so I can inject JavaScript. And then what I'm going to do is say data, and we're going to inject JavaScript here, and that's going to be content type, and then semicolon to separate out the properties. And then we're going to say base64. We're going to do colon right here, another thing here, and say source string. And actually, wait, this should not be a colon. This should be, I believe, a comma. I know this stuff here probably looks a little weird and might not make much sense to you, but this is just the standard convention for using base64 strings in JSX as image sources. Now that we've specified it in this format, we can directly use this string as an image source in our JSX. So if I were to plug this into an image tag, it would actually display the image that we just pulled from S3. So lastly, let's just go ahead and write the body of our response to our response header here. So instead of saying data, we're just going to pass in image source, and that will return our image to the front end as a base64 string. Great, so now we have the route to create an image in AWS and also to get an image from AWS. And I actually changed my mind. I'm going to go ahead and ignore this delete for now, because for right now, I don't want to actually mess with deleting stuff from AWS. So we're just going to keep it to creating something and getting something for right now, just to keep it simple. Keep in mind that we still have for both of these routes this verify token function, because for these routes, we still want to make sure that the user is verified with their token in the front end. So we're just keeping this in each one of these routes here. So this means that we've got this file all taken care of. So I'm going to go ahead and save this file, and I'm going to go ahead and try and mount our routes now. And next, just like our user routes and our post routes, we have to mount them using Express first. So let's go ahead and go to our folder here. Let's go to the server file, and let's go ahead and import the AWS routes. So I'm going to say const AWS routes equals require. And that should just be in the file, AWS routes. And then down here, all we'll say is app.use AWS routes like this. This will make sure that our backend is able to now see those routes. So I'm going to go ahead and save this. And just for good measure, I'm going to go ahead and restart our server just to make sure it updates. So I go ahead and close this out here. Go ahead and start the server. And now that is back up and running. Let's now get started in the front end with this. So we're going to go ahead and move to the API file that we have in our front end. And this contains, again, all the functions that we use to call all of our backend routes. So I'm actually going to add a function for each one of the routes that we made. So I'm going to make one function down here. I'm going to call it export async function. Let's go down a little bit. And I'm just going to name this create image. And then I'll also do one for getting an image. I'll say export async function get image. And these will be our two functions that call the two backend routes that we just made respectively. For these two functions, we will assume that createImage needs a file argument that will represent the actual file that we're uploading to AWS, and getImage will need an ID, so we know what ID of the image that we're getting. To create an image, let's go ahead and take one of the post routes that we already have. I'm just going to take this right here, and I'm going to go ahead and copy and paste it into here, and let's just change this around a little bit. If we go back to the AWS routes, we can recall that to go ahead and create an image, the path is /images. So let's go ahead and go into here, make sure this is post, which it is, and then we just want to switch this to /images. And then instead of passing in any sort of user, we're going to pass in the file that we're getting from the front end. So we're going to pass in file right here. But wait, before we go any farther, we need to change one more thing. By default, you can't just pass in a file through Axios. We need to convert it to form data first so that the backend can recognize it. To do that, let's just go up here and let's write const form data equals, and we're going to construct a new form data object. And then what we're going to do is just call form data.append, and we're going to add our file. We're going to give it a field called image, and here we can add our file object. This will make sure that our file gets sent as form data rather than a raw file. And this should be comma, not a colon. And this will make sure that our backend can read it properly. So, and then instead of passing in the file, let's now pass in our form data instead through Axios. And then the last thing we want to do here is go ahead and give it a custom header. So we're going to say headers like this, and this will be an object. And this is where we can tell it what content type to expect. So we'll say content type, and this will be equal to multipart / form data. And then at the very bottom, we'll just go ahead and now return response. And because we made a couple of changes to this using form data instead of a raw image, we'll need to make a couple of slight modifications in the backend real quickly. There's a library that I like to use that makes handling files in the backend really easily. And it's a library called Multer. To go ahead and install it, I'm going to go into my terminal here. I'm going to go to our backend, and I'm just going to run npm install Multer. What Multer does is handles a lot of the file functionality for us when it comes to managing it in the backend. To go ahead and add this to our project, we'll just go ahead and go into our server here, And then let's just go ahead and at the top here, we're going to add const multer and we're going to import it. We're going to say require, and that will just be multer. And then to initialize this, we can just say const upload equals multer and just call that. And then the very last thing we need to do is just mount it like we would all these other routes. Before we actually mount these routes, we're going to say app.use and we'll call upload.any. So what this multer library does is allow us to send files to the backend using form data. And these couple of lines of code that we just wrote in here are simply initializing it. The only other change we'll need to make is in our AWS Routes file. Let's go ahead and save this and navigate over there. Now, right here, where we're capturing our file, instead of saying request.body, thanks to multer, we can use something called request.files. This is part of what multer does. It automatically adds a files field to your request so you can access it like this in the event that you have sent a file. To capture the specific file that we're looking for, we'll need to access the 0 index, meaning the first file, because it treats it as an array and there could be multiple files in here. But once we go ahead and save this, we've now taken those steps and now we can move on to getting an image. Getting an image is a lot easier. All we need to do is just capture the response here, and we're just going to call a simple Axios get. We know we're just going to be doing our base URL. Oops, not base URL, it should just be URL. And then we want to have /images, and then we need to pass in this ID right here as part of this path. So we're just going to do this and pass in the ID. That way, this request is matching the format that we specified right here in the backend. And just so I don't forget, we'll make sure to add the await keyword in front of the request. And then last thing we'll do is go ahead and return the response. Now we should be all good to go in this file. Before we go any farther, there's one thing we need to think about practically when we're trying to get an image, so we're wanting to use this function here. For getting an image, we need its ID, but where are we getting this ID from? For example, if I want to display a blog post that has a header image, where am I supposed to get the image ID from so I can query AWS for the actual image itself? Well, here's probably the easiest way that we can do that. If we go ahead and head over to Mongo, we know that we're already storing all the essential stuff for each post, like title, description, and content, etc. And we also know there's going to be one header image per post. Therefore, what we could do is just add an image ID field here in Mongo that would store the ID that corresponds to the image in AWS. If this doesn't make sense yet, I think it will in just a moment. Let's first head into our post.routes.js file. I'm going to save this first. Let's go into post.routes.js and let's go down to where we are creating a post. And we're going to add another field here and we're going to call it image ID. I'm going to say image ID. And then we're going to assume that in request.body, there will be another field called image ID. So we're going to say request.body.image ID. We're going to go ahead and copy this, scroll down, and we'll want to add this here for the update as well. So for all new posts and anytime we update a post, we're going to be adding an image ID field. This will be how we know what ID to query from AWS. Now that we have an image ID field in Mongo, let's think about how we need to rework the code for when we upload a blog post to Mongo. So let's go ahead and go here where we are creating a post. We need to do two things now. First, we need to upload the chosen image to AWS, which will return to us the ID of that image. And then second, we will then upload our post object to Mongo right here, just like we're doing before with the new image ID attached. So I'm going to go ahead and make some space right here. And what we're actually going to want to do is we're going to want to call the function we just made to create an image first. So let's go down here. We see this file is called createImage, and we need to pass in, the function is called createImage, and we need to pass in one file argument. So let's go back up here. Let's go ahead and add another Axios request. So we're going to go ahead and add a call to that function. So we're going to call createImage, and then now we need to pass in a file here. I'm going to go ahead and add the await because this is asynchronous. Whenever we capture the image from our React code, I'm going to assume we're going to store it in a property called file. So I'm going to say post.file. And what this line of code will do is call this createImage function down here, and we'll actually upload the image to AWS in the bucket that we chose. And if we go back to our AWS routes here, where we go back to where we're creating a file here, we know that we're getting this response whenever we are uploading the object to the bucket, and we're just returning that as JSON data. If we navigate to the AWS SDK documentation, we can see what the response actually looks like whenever we use this put object command in conjunction with send. And if you can see it, it is this right here. It is an object with an e-tag field as well as a version ID field. Now, I believe this version ID field is the actual ID of the file that we just uploaded. So in that case, since it's stored in something called version ID, what we can do is go back into our code here. we can navigate back into our API file, and then we can capture the ID of the newly uploaded image by just saying, we can do variables, say const image ID equals data dot version ID. And actually, give me just 1 second. Whenever we create a image, it's going to return it in an HTTP response, which means that that's going to be in our data field as well. So it's actually going to be 2 nested data. So it should be data.data.version ID. I believe this is correct, but we can change it later if we need to. Now what we should do is go ahead and add this image ID to the post that we're sending to Mongo to ensure it gets added to Mongo correctly. So let's go down here, and then I'm just going to go ahead and add field on our post object. So I'm going to say post.imageID equals image ID. That way, whenever we're passing it down to our post where we're actually creating it in Mongo, we're also adding the image ID to it. Now this is done, let's go ahead and change how we are also getting a post as well, because now we'll need to include getting the image from Mongo and AWS. So this is done. Let's go ahead and go up here to get post. And we're going to do a very similar thing in this function. We're going to say const data equals await, and we're going to call the get image function. But wait, whenever we're calling get image, remember that we need to pass in an ID here. And that ID needs to be the ID of the image that we're getting from AWS. And that ID is stored in Mongo. So we actually need to call this after we call this here. So let's make space up here. And this response is going to represent the post that we got back from Mongo, meaning that ID would be stored in response.data, because it's always stored in data field, and then in ID. Actually, no, sorry, it would not be ID, it would be image ID. We know that the information for the post is going to be stored in response.data. So let's go ahead and make a variable actually for our post. We're going to say this just equals response.data. And actually, just to make this easier, I'll go ahead and replace this with post. I'm going to put this declaration above this one. And for right now, just to get this out of the way, I'm going to go ahead and delete this stuff right here. So now, what have we actually done so far? Well, this const response equals await Axios.get line here is just retrieving our post from Mongo like normal by getting its ID. And then what we're doing is setting a variable post equal to the data that is returned from that request. And then what we're doing is we are calling the get image function we made a second ago to actually get the image from AWS. The last thing we should do is actually append the image itself to this post before we return it back to the front end. We can do that really simply by just saying post.image equals, and we're going to say data. And then lastly, we just need to return the post to the front end. So we're going to say return post. Not sure why I wrote it like that. Let's go ahead and return post just like this. Now that we have these two things done, we're ready to implement these functions in our React code. So let's go ahead and save this file. And let's first deal with the React logic that we need to upload an image to AWS. The only spot right now in our code where that would make sense is the page where we are creating a post. So let's actually close out of some of these files here just to free up this top bar. And we're going to clear out this create user as well. And we're going to go to the CreateBlog page. On this page, we already have most of the functionality already written to handle uploading a post to Mongo. All that we actually need to add is functionality to upload an image as well. So the first thing I'm going to do is go ahead and make another field in our object here. And that field is actually going to be file, because if you remember in our API here, we specified that we're going to expect a post.file. So we're going to make sure that there is a file field right here. Let's go ahead and make a piece of React state for this file. So I'm going to go up here. I'm going to say const file, set file. And for right now, that will just be empty. And whenever we submit our object here, let's just submit that as file. Let's actually now add a field in our JSX to capture this file object. So we'll go down here to the bottom, and let's go right below this text area where we're getting content. I'm going to go ahead and add another label, and I'm going to say insert header image. And then all we need to do is make another input tag here. And the easiest way that I found to go ahead and get file input is just to specify a type equals file when you're getting an input tag like this. And I can actually show you this real quick if I go ahead and save this file and I go over here. Let's just separate these tabs out. Get this a little readjusted here. And you'll see, even though it's not formatted very well, we have this insert header image, choose file. And if I go ahead and click this, it'll open up my file explorer. If we want to set this file state to whatever we're uploading in this choose file right here, what we can do is just add an onChange property. And whenever we do this, we're going to call a function. I'm just going to call it handle file upload. And we're going to give this a required as well so that we can't submit our form without submitting some sort of image. Let's now actually go up here and define that function. So we're going to go up here and we're going to say a function handle file upload. First things first, let's get the file out of the event object that is triggered whenever we do this on-chain event. So we'll add an E here. Oops, not export, just E for event. And then we're going to get the file. We're going to say const file equals, and then we're going to do e.target.files. And this line right here is how you always extract a file from an input field like this one here. Before we set our file state as being equal to this file, we should check a couple of things. First things first, we should check to make sure this file is actually an image and not something else like an audio file. If we allow the user to upload anything like we're theoretically doing right here, and we want to actually display the image, let's say they've actually uploaded like a video or something, that's going to cause problems when you try to render it in our React. So we need to check for that to make sure that it is an image. Second, we should probably put a size limit on the file so users don't try and upload a like 10 gigabyte file or something and eat up all of our storage. So first, let's make sure the file is some type of an image. We can go about this in a couple of different ways, but we'll figure this out by looking at the name of the extension. If it ends in .jpg or .png, then for right now, we'll say it's valid. I know there are more image types out there, but we'll just support JPEG and PNG for right now. Next, we can easily grab the extension of a file. The typical method for this is to use the substring and last index of method. Here's how we do it. We'll make a new variable, let's just say const file extension, and set it equal to the name of the file, which is just stored in file.name. Next, we can call the .substring method, which can be used to divide the string into smaller parts. Inside of here, let's access file.name again. And then we can call the last index of method, and then we're going to pass in the string of a period for the argument. What this chunk does right here is it basically selects every index and beyond where we see whatever this character is. So if let's say I upload a file that is just myimage.png, what this line will do is extract just the PNG from there, so that PNG will be stored in this file extension variable. Now let's go ahead and check. We're going to write an if statement down here, and we're going to say if file extension is not equal to .jpg or file extension is not equal to .png, then we want to do something. If this block runs, we should tell the user this file isn't in the correct format. So I'm going to go ahead and alert. I'm going to say files must be JPG or PNG. And actually, since we're allowing JPEG, let's also include that as well. I know we have JPG here, but we can also have JP where we have JPEG. So let's do that too. Let's take this line, copy it. I'm going to do or paste this here. And I'm going to add the E in JPEG just so we cover 3 file types instead of just 2. Now, one thing we should be aware of is that this handle file upload is not the actual function that is called when we're submitting our object to our backend. It is merely going to set the state. So what we should do is if this is wrong, in addition to alerting the user that it is wrong, we should also wipe out this input field so they still aren't allowed to upload it to Mongo and AWS. If we want to directly modify the JSX content, but actually in JavaScript, we can use something called the useRef hook from React. So I'm going to go ahead and import useRef just like this. And then let's make a reference. I'm going to say const, I'm going to call this input file equals useRef, and we'll make the original ref equal to null. And then we're going to go down here to our input field here, and we're going to just put a ref here. And for ref, we just named it input file. Now that we have this ref embedded in this input, we can modify this input however we want, which now will allow us to wipe out the input if the image is of the wrong type. To wipe it out is actually pretty simple. We'll just need to reference the ref that we just made, input file.current, because that's how React stores its current refs. And then we'll say .value equals, let's just set it to an empty string. And then we want to make sure we retain the type as well, so it stays as a file type. So we'll say current.type equals file. And now let's go ahead and actually test this. So I'm going to save this, and I'm going to go into my file explorer here, and I'm going to choose a file that is not an image file. I'm going to select the CSV here, go ahead and do that. It'll say files must be JPEG or PNG, and you'll see it still says no file chosen right here. However, if I go and reopen it, and I go into somewhere down here, and I find an actual, let's say an image here, I can go ahead and open this, and it's actually still telling me there's an error. So let's go ahead and open up our console here and do some quick debugging. Let's go to console, and let's see. I think these may be errors from earlier. Let's go ahead and wipe these out here. Let's go ahead and refresh this page. Let's make sure we're not getting any errors when we try and do the file upload. And actually, I'm just going to go ahead and console log out file so that we can see what the file looks like when we upload it. So save that. Let's go ahead and go into our console here. Let's go to the upload, and let's just select a random image right here. And you can see it says this is the file right here. And we can see the name here does end in .jpeg. So let's actually check to make sure that file extension is pulling properly. I'm going to go ahead and print off file extension as well. Save this, refresh the page here. And I'm going to go ahead and retry this. I'm going to use the same thing here. And it says it is .jpeg. You know what? I think I messed up the logic. This should not be ORs. These should be ANDs. So we should be checking to make sure they're not any of these, not a single one. Make sure these are ANDs here. Let's save this, wipe this out, and let's actually go ahead and try this again. So we'll choose this file right here. We'll do this, and you'll see now we have this file selected. However, let's try going for an invalid file now. Let's go here. I'm going to go ahead and select a CSV file, and it'll say files must be JPEG or PNG, and now it'll say no file chosen because it wiped it out. So that's exactly the behavior that we want. Let's now handle the rest of this function here. So right here, we have this if statement like we just checked to make sure it is of the right file type. I'm going to go ahead and delete these console logs here just to free up some space. And then let's go down here. Actually, in this if it hits this, I don't want to keep going in this function. I actually want to stop its functionality. So I'm going to go ahead and return. However, assuming we get past that, that means that the file is valid. So let's go ahead and actually set the file state to whatever our file is. But wait, let's actually check one more thing. Let's check the file size to make sure it's not too big. I'm actually going to go up to the top of our component here. I'm going to make a new variable, a constant. I'm just going to say const, I'll call it max file size. And let's set it equal to something. For now, I want to limit the image to 15 megabytes. So I'm going to say 15,000,000. This is because file size is measured in bytes, not megabytes. And 15 megabytes is just 15 million bytes. Then let's go ahead and scroll back down to this file upload here. And then I'm going to go ahead and say if file.size exceeds max file size, then what do we want to do? Well, let's do the same thing kind of like we're doing up here. Let's alert and let's say file size exceeds the limit. And I'll say 15 megabytes. And let's do the same thing. We're going to wipe out that file so the user can't work with that file anymore. So we'll just add this code in here. This first check, again, is just checking if the file extension is of the proper type to make sure it's an image. And the second one is checking the file size to make sure it's not too large. If we've made it past these two things and we've gotten to this line of code, that would mean that we are safe and we are ready to go. So we can go ahead and set the file to the file that was uploaded. Now let's actually go ahead and save this file. And I want to run some testing so we can do some debugging as needed. So with that being said, let's go ahead and fill out some of these fields here. I'm going to go ahead and enter just some random letters for these just so we can get them filled out quickly. I'm going to go ahead and open this choose file. And let's just select a random image that I just downloaded and go ahead and press submit. It looks like we got a connection refused, which means our server most likely crashed. I'm going to go ahead and open up our terminal. Let's do some quick debugging. Let's head here into our backend. And it looks like we did in fact have an error here. And it says no values provided for this label here. Okay, so off screen, I did some super quick debugging, and I realized that whenever we change this to the files here, we need to change these fields here. So this should be file.original name, and this one should be file.buffer, because the actual file content itself is stored in buffer, and the name, which we're using as the key here, is just an original name. And when I went ahead and changed that, and I look back at our AWS here, we can see the image that I picked here is actually uploaded here. And I can refresh just to make sure. And actually, I'll expand this a little bit so you can see. And you can see that the file is now sitting in here, which happens to be the exact same file that I just uploaded. Let's check Mongo to see if the image ID uploaded successfully with it. So I'm going to go ahead and go to our Mongo here. Let's refresh our post. And let's go ahead and take a look at it. So we can see here, it looks like we have our post, but our image ID is set to null. I just did some quick checking. And because we are actually hosting our item using the name of the file, instead of doing data.data.version ID, what we can actually do is just say post.file.name, and this will capture the image ID properly. Now that we've made this change, let's go ahead and save this file. Let's go ahead and test this out again. Let's go into Mongo. I'm going to change these around a little bit. I'm just going to do some random letters here. Same file we're going to upload. I'm going to go ahead and press submit, and let's see what happens. Looks like we had no errors so far. So let's go ahead and check Mongo and see if the post uploaded correctly. Go ahead and scroll down here, and we can actually see here on this image ID, we now have the image that we just uploaded, which you will notice if we go ahead and zoom in here a little bit so you can hopefully see a little better. This highlighted name right here of the image file matches exactly the name of this file in AWS, and that's how we're going to be able to retrieve the items or retrieve the images when we need to. Now that we have all those errors ironed out, we can go ahead and move on to the last part of the video where we'll actually pull an image from AWS and display it on our page. When it comes to loading an image, the only place right now on our site that we'll need to do that should be on the ReadBlog page, because that's where we're actually displaying the images for that particular blog post. We already have pretty much all the functionality needed to get the information for a post. We just need to add the image now. The first thing we'll want to do is go ahead and import the get image that we just made in the API file. And just so we know when we're doing the right thing, let's go ahead and go here and let's go to the post that we have uploaded. And the only thing we should actually need in this file to make this work is to go ahead and add an image tag down here. So let's have it so where we do our title and description, and then we'll do our image and then our date. So we'll insert our image here, and let's just give it a source of, and I believe it should be just post.image. Let's go ahead and save this. And it looks like we have just an image here that is blank. Just for the sake of debugging, let me real quick go up here. And before we set our React state, I'm actually going to console log out this data just so we can see if I'm accessing the right field, because I may not be. So if you go in here, it is in the image field. Okay, sorry. So it should not be .image, it should be .image.data. So let's go ahead and do .image.data, save it, and you can see now our image displays on our page. It's rather huge, but it is displaying. Now that we know the image uploading and fetching is good to go, we'll officially wrap up this video on media management. In this episode, you'll learn how to use a cloud service like AWS S3 to store images for your website, how to connect that functionality to Mongo through your app, and how to pull these images and render them in your React app. In the next video, we'll focus extensively on styling the website with CSS to make it look professional. Take care, everyone, and I'll see you in the next one. Hey everyone, and welcome back to the final episode of the MERN Stack crash course. In this episode, we're going to take care of all the CSS styling to make our site look nice. We'll add all sorts of colors, spacing, fonts, and more to make it look like an actual functional website, instead of just looking like a super basic template site. For this project, we're going to use a tool called Shadcn. It's a CSS tool that's kind of like Bootstrap if you're familiar with that. Basically what it does is it just gives us a bunch of pre-built components that we can copy and paste into our code, and they're all available on the website here. That way, we don't have to become graphic designers. After all, I'm not a graphic designer and I don't pretend to be, so I'll leave it to the actual designers to take care of the CSS and we'll just implement it in our code. How Shadcn works is a bit unique when compared to other CSS frameworks. It's not actually a library like Tailwind, and we're not actually installing some big library in our code. Shadcn has a bunch of different components like the one you see here on the left-hand side, and they're all available on the website with the code attached to them. Let's say, for example, I want to access the alert dialog. I can go to this page and see an example of what it looks like. Pretty nice, right? I can open this, has this window here, and this is just a basic component of a alert dialog. If I want to get the code for it, I can click on this code thing here, and it'll tell us how to implement it in our code. The only steps that we need to take for each component is to actually install the component in our library by using this command here, and then we can use this code however we please to add it into our own code. Shadcn uses Tailwind, and it will set it up by default whenever we set up Shadcn. Tailwind, if you're not familiar with it, is a very popular CSS framework that basically just allows you to write CSS inline very easily, removing the need for CSS files. You'll see how it works in just a minute. Let's go ahead and get Shadcn set up first, which will set up Tailwind as well. And before we add any components, we need to configure our environment to work with Shadcn. We use Vite to create our React app, and if we head to this page here, it tells us exactly how we can get that set up with React and Vite. And we're actually going to follow these steps exactly, except for step 1, because we've already done that when we first created our project. So let's start at step 2. So first, it tells you how to get Tailwind set up. Before we do that, we're going to make sure we're CD'd into our frontend folder, because we want to install it in the frontend folder itself. And then I'm literally just going to take these commands, copy them, and I'm going to paste them into our terminal, and I'm going to run each of these individually. So we went ahead and ran that command. Let's run this command next, npx tailwind css init, which should actually initialize our project as a Tailwind project. The next thing we'll need to do is step 3 right here. And by default, since we're using JavaScript, we don't have a tsconfig.json, but we can actually make our own. I'm going to make one. I'm going to call it, actually, make sure we're in our front end folder here. I'm going to make a new file. I'm going to call it jsconfig.json. And then I'm going to take all this code here. I'm going to copy it, and I'm just going to paste it right into this file. Next, let's move on to step 4. And we have this command here, npm i-d types node. Copy that, paste it into here as usual, and we're going to go ahead and install that. Next up, it's telling us to go into our vite.config file. So let's go ahead and head into there. And you see here that we have a file that looks somewhat similar, but we need to go ahead and add a few things here. So first of all, we need to import this path from path. So let's get that added. And then we just need to add this chunk of code right here. And this is actually just to resolve the paths. So whenever we import our Shadcn components, there isn't any errors when we're trying to import them. So let's do this. Go ahead and add that here and save this file. And now this file looks exactly like this one over here. So we should be good to go. Next up, we actually initialize our Shadcn project. To do that, we'll just copy this line here. And we're going to go ahead and paste it into our terminal just like before. And this will actually create our project as a Shadcn project. And here it's going to ask us a bunch of questions actually. So first it says, would you like to use TypeScript? And we're using vanilla JavaScript. So I'm going to say no. Which style? Let's go with default style. Which color? I'm going to go with zinc as a color here. Global CSS. Let me double check this path here. So this is in this file. So global CSS should be in, let me see, should be / from the front end folder. It is /source/index.css, just like this. CSS variables, I'll go ahead and say yes for this. Then it's asking if we're using custom Tailwind prefix, which we'll just leave blank. We'll just say no. Tailwind.config.js, it should just be in this same directory. So it should say tailwind.config.js like this. Alias, we'll keep this at components here. Keep this the same. React server components. We're not using Next.js, so I'm going to go ahead and say no because all of our stuff is client side. Write configuration to components.json, proceed, press Y, and we should now be good to go in just a moment. And now we're good to add Shadcn components as we see fit. So let's go ahead and shrink this down here, close this out, and let's actually get started now with styling our website. But before we do anything else, let's get started with a clean slate. Let's see here, I'm getting an error on the import. Go ahead and refresh that. Looks like we're back to normal. And you can see here our page already looks drastically different because of what we've imported from Shadcn and gotten Tailwind installed. I'm actually going to go into app.css here, and I want to start on a completely clean slate here. So I'm going to erase pretty much all of this here. I'm going to get rid of all this. The only things I'm going to keep are text align center, and I'm going to keep the margin as well. But I'm going to do everything else gone. And now if you look at our page here, it looks even worse. It looks pretty bad here. Everything sitting at the top of the page, kind of just chilling out. But starting on a clean slate makes it a lot easier for us. So everything else besides these two things has got to go, and we're going to start right here. This means that pretty much 100% of our styling is gone, but now we're ready to do with it whatever we'd like. Before we work on any specific pages, let's do one more thing. Shadcn allows you to customize your colors however you want. If we actually open up here and go to our index.css file, you'll see it added a bunch of stuff in here whenever it first configured our project. All of these values that you see here are different color values, and these are all HSL values. This background right here is going to be white, and foreground is going to be black or pretty close to black. We're going to keep those two the same, but I'm going to change this primary right here. For our primary, I'm going to roll with a somewhat darkish blue. I looked at some color codes earlier, and one that I liked was 219, I believe it was 83, and then 40. And we're going to save that and use that as our primary color. If you want to get more creative with the colors and add more stuff with the palettes, feel free to. But now that we have these out of the way, let's start customizing our pages, and let's get started with the landing page first. This over here looks pretty hideous, so let's spice it up. First things first, let's get this stuff centered right in the middle of the screen. So I'm going to go ahead and make an outer div here, and let's add some Tailwind. And this is where you get to see where Tailwind actually works in action. Basically, we can just write inline CSS using class name, and then writing whatever properties we want. So I'm going to make this a flex box, so I'm going to say flex. I'm going to give it justify center to horizontally align our items. Item center to vertically align our items. And then I'm going to say, I want the width to be the entire screen, and I want the height to be the entire screen as well. Now I'm going to go ahead and save it. This is going to make the view the entire screen and should put the item somewhat nicely here in the middle. But all of our form stuff is still out of whack. We want this to be going vertically, not horizontally. So I'm going to go ahead and make these divs as well so we can do some styling. And the only reason I'm adding divs here and not doing like the empty brackets is because we can't add a class name property to an empty fragment. We have to have something in front of it, which is why I'm adding div. So let's add this. Let's give this a class name as well and give this one some styling too. What I'm going to do is say, I'm going to give it flex call, which stands for flex column and gets it to go vertically. I'm going to give it a width of 96. This makes sure we're setting up in a column-like format, and we're setting our width to be something convenient. And I'm going to actually go ahead and take this same class name, and I'm going to go ahead and copy and paste it into here, and we'll make this a div as well. That way our create new account view is the same thing. This still looks pretty wacky, so we'll need to customize the actual login and create user components to make this look a little better. But first, let's actually import a button component from Shadcn to make this button look nicer. And here's where I get to show you how Shadcn actually works. So first things first, we'll go over here and we'll look in the component library and let's find button. So button is right here in Shadcn, and we see it looks something like this, which will do, right? So I'll go here and go into my terminal, make sure we're looking in the front end folder, and it gives us the command to install it into our code. So I'm going to go ahead and copy this. I'm going to paste it right here, and we're going to add this component into our code here. And you will notice that what it actually does, if I shrink this, go to our file explorer, is it adds inside of our components folder this UI folder. This is where it actually stores the Shadcn components that we need. So that's what I meant when I was saying it's not a traditional library, because whenever you install it, it basically just adds it as if it's just another React component. So let's go ahead and close out of this and let's head back to our landing page here. And it actually tells us exactly how to import it. We just saw it's in the components and UI folder, and this is how we're going to import it into this file here. So we're going to go ahead and copy this, and we're going to paste it at the top of the landing page. And then literally all we need to do to change this is you see here that this button is capitalized. So let's change this B to button because it's an actual component. And we'll make sure we change the end tags as well. So this should be capital B, and this should be capital B as well here. And if I go ahead and save this page, look back at our site, you can see we now have a button that, although this form still looks messed up, this button does look quite a bit nicer. But let's go ahead and fix this form real quick. So I'm going to go ahead and go into the login page, or the login component actually. Go ahead and open this, and let's get started in this file. First, I'm going to go ahead and import that same button that I just got. And this should be, it's not autofilling, should be button from, and this is @/components/UI/button. So we're going to import this, and I'm going to import something else from Shadcn as well. So if we go ahead and go over here and we look at the input one, I want to make our input fields look a little bit nicer for our form. And this actually looks quite a bit better than the default. So I'm going to take this as well. So I'm going to go back to our terminal here and let's actually install this component. So right here, you see is this command right here. So we're just going to copy it. We're going to paste it right into our code. Go ahead and run it. And that will be installed in our code. And you'll see that it should have added it right here in our UI folder. To import it, we're just going to take this command here, import input right here, go ahead and copy and paste it, and save the file. And now let's get back to the page. And just like last time, all we need to do is go down into our JSX, and we'll change these to be actual components instead of just the default JSX tag. So this will be capital I with input, this will be capital B for button. And these fields, what's nice about Shadcn is that these fields will all stay the same. I don't need to make any other changes to them. So we're going to make this button as well. Make sure this is all looking good. Go ahead and save this file. And here you can see our form changed quite a bit and looks nicer. We want this to stay as a nice column. So let's go ahead and add class name equals flex and flex column for our form here. And now it'll make the buttons equal size. Lastly, let's make them a little less clumped up together by adding some margins. So I'm going to go actually starting at the, the password right here. I'm going to add a class name, and I'm going to add a bottom margin, which I can just say is MB. And I'm going to set that equal to, let's say 4 for right now. Let's do that right there. And you can see it separates those two out. And actually, I'll set it to each of our things here. I'll do this for the email as well. And then also the login button. So we have bottom margins on all of them, and it separates out our form a little nicer. Now, this looks nice, but if we go into our create new account, this still looks pretty bad. So let's actually go into our create user page and let's make the exact same changes that we just did with the other file. So let's go ahead and import the input. We're going to import the input, and I wish it would help me out here in autofill, but it's not. So I'll do from this should be components /UI /input. And then we'll do the same thing here for button as well. So let's import this as button. And this should be from the button file. And then once we have that, we'll go down here. This is what we did last time. We will change these from lowercase inputs to capital inputs to show that they are Shadcn components. Go ahead and do button here and button here, save, and we're looking a lot better. And I'll do the exact same thing where I'll make it flex and then flex column to make the buttons the same width. And then I'm going to add some bottom margins on all of these as well. So we'll do class name equals, we'll say bottom margin 2. And then actually, I think I did 4 in the other one. I'm going to change that to 2 as well, because I think this looks a little nicer. Let's just space that out. And then we'll add 1 here as well. So they're all looking a little bit spaced out. So let's actually go back here, and yeah, I'm gonna change these back to bottom 2 instead of 4. So let's do margin bottom 2, 2, 2, and those are looking a bit better. And we'll keep this one spaced out just to keep it kind of on its own. Now that we've done that, let's log into our app and let's get started with the bulk of the styling. So I'm gonna go ahead and log in like normal. And the great thing is that all the styling won't change the functionality at all. So I'll go ahead and go here, log in. And wow, this looks absolutely terrible. Let's get started with a few things right away, starting with our navbar. So I'm going to go ahead and navigate to our navbar component, and let's get started in here. Let's actually go into Shadcn, and let's find their navigation component. I believe, yeah, it should be here, and it should be called navigation menu. So just like we've done before in the past, I'm going to go ahead and open up our terminal here. And then we're going to take this command to add the navigation menu component into our code. Go ahead and paste that in here. And that will install it. And here it tells us how to use the code. And this time, unlike the other ones, it actually has multiple imports for different components. So I'm actually going to take this whole thing here, this whole import statement, shrink this down here, and I'm going to import that whole thing into our code. So let's go ahead and scroll down. I'm actually going to get rid of this navbar and nav item because obviously you wiped our CSS out, so these don't apply anymore. Once we have all these things imported, let's actually wrap a bunch of our elements in these tags. We're only going to use a few of them. We're going to use navigation menu, we're going to use menu list, menu item, and then menu link, and we'll delete what's left. So first off, I'm going to start with navigation menu. So this should be the outermost one. I'm going to say navigation menu, and we'll make this navigation menu as well. And the nice thing is that when we do this, it'll automatically apply Shadcn styling. And then I'm going to do right here, I'm going to do navigation menu list. This will be where we're mapping stuff out. So this will be our list of stuff. Take this here and let's enclose this whole map statement in the navigation menu list and tab it just to make it look a little bit nicer. And then for each thing that we're returning from the map statement, each of these should be a navigation menu item, which there's actually one for that navigation menu item right here. So let's go ahead and add that. We'll just go around here and we'll say navigation menu item. We'll take this, that, and we'll go ahead and paste it into here. And then at the very bottom here, right where we have our button, instead of saying button, what we're going to do is we're going to give it the navigation menu link here. We're going to replace that on the bottom as well. And this will be all the filling in that we're going to do with Shadcn components. So if we go ahead and go back to our page, you can see it actually doesn't look that much different still. So let's actually add some Tailwind to this to make it look a little bit better. First things first, we're going to go into navigation menu and we're going to give it a class name. We're going to give it this. And then the first thing we're going to do is set it to primary so that the whole thing becomes blue. Next, I'm going to do a few things to make it look like an actual navbar. I'm going to set it to fixed. I'm going to set it to the width of the entire screen. We're going to set it to be at the very top of the screen and the very left side that was aligned. We'll give it a height of 20 and we'll give it a padding of 2. Go ahead and save it. And it looks like this. Now it's stuck at the top of the screen like an actual navbar, but it still looks really messed up because this stuff is still right next to it. So it's not looking like an actual proper navbar yet. One thing we could do is edit the actual navigation menu component from Shadcn itself. So I'm going to go in here and let's actually make a change here. Let's find the original navigation menu here at the very top. And let's actually remove this max width here. And then once we do that, that will actually make it look like it is a proper navbar going across the entire screen. And actually one thing I forgot to add is right here on the menu link, there's actually a class name thing from Shadcn that you have to add to make it behave properly. I believe it is, yeah, it's this right here, this navigation menu trigger style. I'm going to go ahead and import this as well because it's not part of our original import list. Go ahead and import this. And then what we need to do is just add that as a class name to our menu link to make it look like it is actually a real link. So we'll do this, add it here, go back to our page, go ahead and save. And you can see it now actually makes these as buttons and it makes them look quite a bit nicer. Here's another problem though. Right now our navbar is overlapping with our actual site content and it does look really messy. So let's go ahead and fix that. To go ahead and fix that, we can go ahead and head over to our layout component here. Because if you remember, this layout file right here is the parent component of all components that have a navbar. One easy way we can fix this whole overlap issue without having to correct every single page individually is just going in this component here and adding some custom Tailwind styling. So right now we're rendering outlet. I'm actually going to wrap this in another tag. I'm going to call it main. So let's go ahead and take this and let's render outlet inside main. And then I'm going to give this main a class name, and we're going to add a couple of custom Tailwind properties. We're going to do flex. We're also going to do, let's say, width screen. We're going to justify its center so it's horizontally aligned. And then we're going to give it a top margin of 24. And this top margin of 24 should give us enough breathing room, hopefully with our navbar. If we save it, you can see that our content is now sitting in the middle and it's below our navbar, so it's not interfering and overlapping. Since we're on this home page, let's go ahead and get our BlogCard component cleaned up since we have no styling right now for that. So let's go in here, let's go to our components, and let's find BlogCard. First, let's get the actual card component from Shadcn. So we're going to go up here, we're going to find card, and here's the command to actually install it. So we'll go ahead and copy it. We'll open up our terminal, and we will go ahead and add that component to our project. And then just like with the navigation menu, I'm going to take these imports here, and we're going to import all these different things. So we'll go up here, copy it, and paste them right here. Since card here is the base layer, let's go ahead and wrap this entire thing in card. So we'll take this, cut this, and paste it right here. So this whole thing is now wrapped around card. And then what we're going to do is we're going to make our title and our description both wrapped around card header. So we'll add these, we'll wrap both of these around, and then we're going to do card title and card description respectively for each of these. So we'll say card title, and we're going to wrap that with here. And then we're going to give this one card description. And we're going to obviously wrap this one as well. Go and space these out, so this looks a little bit cleaner. And then just for the sake of this card looking decent, as you can see here, it looks a little better. I'm just going to go ahead and wrap our date as being part of the card content. Even though our card doesn't really have a whole lot of content on it, we'll just do this for organization's sake. Go ahead and save it. And you can see our cards look decent now. It's looking a lot better, but we're still not done. For each card, I'm going to go ahead and add a class name here, and I'm going to make it, I'm going to say flex and then with full to make sure it fills its entire container. Then I'm going to do justify center. I'm going to do margins on the y-axis of 8 to set the vertical margins. And then I'm going to give it a hover property as well. When we hover over it, I actually want to set the background to muted. Muted is one of the Shadcn default colors for things like highlighting. I'm going to go ahead and save that. This looks a little different now. And I can see if I hover over them, they highlight that kind of off grayish color. Also, if we hover over them right now, notice how I have the cursor as a pointer right here. But if I go to the edge, it's not fully covering, which means this link here isn't fully part of this card. So I'm going to go ahead and into this class name here. I'm going to remove this post, and I'm going to add with full. That way, the link will cover the entirety of the card. I'm also not really a huge fan of how this header right now looks in the card. I mean, it looks decent, but I want to change it a little bit. So I'm going to go into Shadcn, and they have a tab here called typography that basically has the customizations for different inline components like header 1, header 2, paragraph, and so forth. So I'm actually going to scroll down, and I'm going to find the code for header 2, which looks something like this. And as you can see here, this is like header 1 here. This is header 2, header 3. I'm going to look at header 2 actually, and I'm going to grab the code for here. These aren't actually pre-built components that you install, but rather you can just take the code from them. So I'm going to take this class name here. I'm going to go ahead and copy all this. And then for our post title, I'm going to paste that in here. Let's look at our page. If I save that, you can see now it looks a bit bigger and a little bit nicer in my opinion. And just to make it look a little cooler, we're going to make it blue. So we're going to do background primary. Oops, not background primary. There should be text primary to make sure this gets set to our primary blue. And now I honestly think we're probably good to go for these cards, at least for the moment. But since we're on this page, let's quickly navigate to the home page since that's the card's parent component. So we'll go ahead and navigate to the home page here, and we'll just make a couple of small changes here. For this outermost div right here, let's just give this class name a couple of properties. I want to make this flex. I'm going to give it flex column, item center, and then I'm going to do with full, and then go ahead and save. And this makes sure that we have nice column cards and they are centered. Although now if you notice the cards are taking up the entire width of the screen, so I want to go ahead and change that. So let's make a quick change to the inner div here where we're mapping our posts. I'm going to make that div right now. I'm going to make this div like this, wrap it around here. And I'm going to give this a class name of a couple of things. I'm just going to say width 1/3 because we don't want it to be the entire width of the screen. I'll just say I want it to be 1/3 of the screen. And then I'm going to also add top margins of 4 here just to separate it out from the navbar a little bit. Go ahead and save this. And now we should be good to go. The 1/3 might look a little goofy because the screen is shrunk here, but if we expand it out, the 1/3 looks a little more natural. So let's go ahead and take this back here and go back to our split tabs here. So what happens if we actually click on a blog DAO? We get to this page and holy hell, it looks really bad. If we go ahead and go over here and full screen this page, we can see what's actually going on here. The obvious problem is that this picture is huge and needs to be shrunk down. But also notice how all of our information here is in the form of a row. We have our button over here, our back button, our title right here, our description, our picture, and then all of our content right here. So it's basically just flowing from left to right rather than from top to bottom. To fix that, let's go ahead and go in here and let's go into our ReadBlog component. So we'll go into here. And the first thing I actually want to do is add an outer div to this JSX here so that we can add some styling. The most basic thing we could do here to get it into a column format is to give it a class name of flex and then flex column. Go ahead and save it. And now if we go back to this page here and save it, we can see that it's now going from top to bottom. Now we can obviously see that this picture is still huge and needs to be fixed. However, it is in a column format instead of a row format, which is a good first step. To go ahead and fix the styling of this image, I'm going to go ahead and wrap it in a div here. So I'll take this closing tag, surround this image tag here. I'm going to give this a class name. We'll give it a flex, so it's flexbox. Let's say width full. And then let's say justify center. And then for the actual image itself, I'm going to go ahead and extend this class name here. And I'm going to give it a max height of 96. So it never exceeds that. And then we'll give it margin Y of 4. So it gives these as 4 pixels of vertical margins. Go ahead and save it now. And we're already looking a lot cleaner. If you want to mess with the max height, feel free to, but I'm going to go ahead and take this tab here. I'm just going to resize this back to our screen here. And let's get back into the code and let's do some styling changes starting from the top with this back button. To start with the button, let's first import the button from Shadcn. So I'm going to go up here and I'm going to import button here from the components. And then for this back button here, let's actually go and implement this button. And all we need to do that is just change this to a capital B so it knows we're talking about the component we just imported. Go ahead and save this, and this button now is styled like Shadcn. Next, let's just do some basic Tailwind. I'm going to make this parent div right here. I'm going to give it a width. Let's say a width of 1/3, similar to our cards. I don't want massive amounts of space being taken up, so we're making our view a little bit smaller. Go ahead and save this. And here, it does look a little bit goofy if we're on this view of half the page here. But again, if we full screen this, it looks a little cleaner. Let's actually now clean up this button so it doesn't take up the entire width. So I'll go ahead and bring this back here. Move this over. And I'm actually going to do the same thing for the button. I'm going to give it a width of 1/3. So I can add that in here. I'll say class name equals, I'll say width 1/3, just like this. Save it. And to get it in the center, all we need to do is go into our parent div. And we need to type items-center. This will actually center the button right in the middle. Next, let's get back into our typography on Shadcn. And I want to copy a few of these things. So I'm going to go down here. I'm going to look at the H1 code. And I'm going to copy this Tailwind right here. And on our, actually I'll copy this whole thing here. And then on our H1 in our app, I'm actually just going to paste this in and go ahead and save it and head back to our page. And you can see the typography now looks a little bit different. And I'm actually going to do that same thing for each one of these headings here. So for heading 2, I will take the heading 2 typography. And this is just for a convenience thing because it already has some pre-built stuff. So it saves us some time having to figure out the styling. So I have this in here for header 2. Let's do this here for header 3. So we'll copy this, paste the header 3 in here, and then we'll do P as well. So we'll go P here. Let's go class name, copy this, and let's just put it right in here. Let's go and look at our page. Go ahead and save it. And now typography looks a little bit cleaner. Lastly, let's just get this text figured out on this page. If we go ahead and look on this page, you can see that this text is just one giant big blob, and it's not very readable. So let's go ahead and go into our code and let's fix that. All we need to do on our p tag here in our class name is just add another property. And that's just going to be white space, and that's dash pre, -wrap. Go ahead and save it. And now you can see we have actual division of our text. We're going to go ahead and make a few stylistic changes based on what we're seeing on this page here. First of all, I still think this back button is a little bit too large and it's also too close to the navbar. So let's go ahead and fix those two things. Let's go to the back button. And for class name, I'm going to give it, let's just test what 48 looks like. Let's save that. And that actually looks a lot better in my opinion, so it's not quite as wide. Let's also go in here and let's add some margins to this button. Let's add vertical margins, let's say of 4. That way it is a bit separated from everything else. The next thing I want to change is this text here. Notice how this text is kind of centered in the way where it's not really left aligned here, it's kind of center aligned. Let's go ahead and actually left align it. So all we need to do that is make sure we're in our p tag here where our text is actually located. Let's give it a property of text left and save it. In that way it looks a little bit cleaner. So now it is all left aligned. Let's also space out this title and this description here so that they're not so close together and so clumped up. So let's go ahead and go into, let's say our title header here. Let's give it some bottom margins. Let's just say bottom margins of 2. And then we'll actually do the exact same for this one as well. So that way we can space it out a little bit more. And then just to play around with the colors a little bit, let's make our title here actually blue instead of black. So let's go into our title header, which should be this first H1 still. And let's just give it a, let's say primary, or sorry, should be text, primary, go ahead and save it. And now the text is blue and in my opinion looks a little bit better than the black text. The very next thing we should do is go to our create blog page in order, because right now if we go ahead and navigate to this page here, you can see it looks pretty rough, not a whole lot going on this page. Before we do that, let's go ahead and just fix this screen here so we can have this screen again. And let's go ahead and navigate to the create blog page. First things first, I want to import a couple of our Shadcn components. So I actually want to use 2 components. I first want to get the inputs from Shadcn, and then I also want to get button as well. So we'll import those 2 just as normal. And there's actually 2 components I actually want to add from Shadcn as well. If we go into our components right now, we can see we just have button, card, input, and navigation menu. But I actually want to add 2 more, and that's label and text area. So I'm going to go to Shadcn's website, and I'm going to find label. Let's get this one here, and let's add this one. As usual, we'll go ahead and take this command here, and let's copy it using npm. And let's go into our terminal. Let's open it back up. Open up a new one here. Go into the front end folder, and then let's just copy and paste this command here, and that will add the label from Shadcn. Let's do the exact same thing for the text area component. So I'm going to take text area, go ahead and copy this as well. And let's paste that. So we add text area as a component as well. And just like every other time, whenever we run that command, it should add a file here in our components/UI folder that adds the text area as well as the label. Let's go ahead and go back here and let's go back to our create blog and let's import those 2 components. So first we'll import label. That should be from this folder. And then next we will import text area. And that should be from this folder as well. Once we have those things imported, all I'm really going to do is go ahead and scroll down here and let's change all of our fields from being these default labels and text areas to being the Shadcn version. So I'm just going to take all these, change these to capital L so it's the Shadcn version. I'll do that for labels, and I'll also make sure the ending tags are correct as well. It's a little bit tedious, but should make it look quite a bit nicer. Now I'm going to do the exact same thing for inputs and text area and button as well. So let's actually do it for all of these. So let's do inputs, inputs. And again, remember that the reason why we do this is because the Shadcn components are always capitalized. So whenever we capitalize it after importing Shadcn component, that's what actually gets it to be Shadcn and not the default. Once I've done that, I'm going to go ahead and navigate back to this page here. I'm going to save it. And here, this page looks a little bit nicer than it did before. Next, let's just add a couple more things. Let's go ahead and wrap this whole form in a parent div to do some more styling. So let's take this closing tag, paste it down here, and let's give this div here a class name. And I want to give it a few properties. I want to say flex, justify center, and I want to do width 1/3. Go ahead and save it, and it should not really do anything for right now, but you'll see what I'm doing here in a second. For the button at the very bottom, I'm going to give it its own class name. I'll scroll down here a little bit so you can see it better. And I'm just going to give it some top margins of 4. That way it's not touching this last file field here. So I'm going to say margin top 4, save it, and the button's now a bit separated. Lastly, I want to take the labels that we have here, and instead of having them centered in the middle of the page, I want to have them on the left side of the box. That way I think it looks a little bit cleaner in my opinion. So what we can do to do that is for each label here, let's give each label a class name. and I'm going to give it flex, let's say left 0, that way it's fully left aligned, and then we're going to give it a padding of 2. I'm going to go ahead and take this class name and put it into each label. We can avoid having to retype all of it, and go ahead and save it. And you can see now the labels are on the left side and have a bit of padding. And let's actually add one final thing to this page here. For the file input, I want to add a few properties. So in this input here, we'll scroll all the way to the end here. Let's go ahead and add a class name. And I want to give it, a couple of things. I just want to say cursor pointer, and then we're going to give it a hover colors. That way when you're hovering over it, it looks a little bit cleaner. So we're going to say hover, and then let's just give the accent for the background. So go ahead and save it. And that way, what you can see is whenever you hover over this thing now, it highlights a little bit of a gray color so you can see what you're actually about to click on. Just so you can see what this page looks like full screened, we'll go ahead and full screen this. And you can see it looks like this. These boxes are still a little bit small, so let's go ahead and actually fix this thing here. When I had this flex justify center and width 1/3, let's make sure this is working properly. Just so we can test and find out what's actually going on here, let's go back to our page and let's actually open up the console here. And let's go ahead and look at what's actually being displayed on the page. So if we look at our main here, we can see the main is actually the entire width of the screen. And then this width 1/3 class here, which is the div, which is what wraps around this form here, you can see that this takes up this space here. But it looks like because there's all this empty purple space that's open here, what we actually need to do is go in, we'll go into here. And instead of doing this, I'm actually going to say this should be full width, so it takes up the entire width of the page. And then I'm actually going to give the form a class name, and this one will say width 1/3. And now if we go ahead and save it, there we go, it looks a lot better. Now it's actually 1/3 of the page instead of just being 1/3 of that small container that it was already in. And actually, because this whole main thing is taking up the entire width of the page anyways, we actually don't need this div like I thought we would. So I'm just going to go ahead and I'm going to go ahead and just delete this just to have what we had before, where we just have the form. And this should look the exact same. Let me go ahead and save it. And yeah, you can see it made no changes. So it was a bit of an unnecessary step to add that div in here. So we'll just leave it like this and call this good. The next thing I want to focus on is doing the About Us and the contact pages. And then we'll save the profile page for last. So as first with our About Us page, I'm actually not going to import anything really special. I'm going to go ahead and navigate. I'll just full screen this since we have both in full screen anyways. Let's go here and let's navigate to the About page. And then here, all I really want to do is take the typography that we have in the ReadBlog page. So if I go over here, remember that we copied some typography to make it look a little bit nicer. So I'm actually going to take this typography here we have for P, this class name. I'm going to copy it, go back to our About page, and everywhere where we have this, I'm just going to paste that in here. That way, it matches what's on our ReadBlog page. If we go ahead and save this now and go back, the text looks like it is the Shadcn styling rather than the default styling. And then for this top label here, for this About Us, I'm actually going to go in here as well and take the typography for H1, because that's what we have in the About page. I'll take this, copy all of it, head back here. Let's just paste it in here. So like I said, we're not actually taking any Shadcn components and importing them and then rendering them. All we're doing is taking the typography from it and then just copying and paste it into our code to make it nice and easy. Go ahead and save this, and you can see now we have this nice little label that has the same styling as the other page. And I actually want to do the exact same thing with the contact page. So I'm going to go ahead and I already have the H1 copied on my clipboard. So I'm going to head and find the contact page here. And then for H1, I'm going to make that this. I'm going to save it. And then I'll go here in the P tag as well. And just like before, we're going to copy and paste these, save it. For this form, however, that we have right here, right now it doesn't look very good. So I'm actually going to use some Shadcn components for that as well. So let's go ahead and import a few at the top of this page. The ones I want to use for right now are button. I want to also use label. I want to use input. And then I also want to use input here. And then lastly, I want to use text area. We're going to do a very similar thing on this page like we did with the CreateBlog page. And that's changing all these here to the Shadcn equivalent. So for label, I want to change these all to capital L, so it's the Shadcn component. And we're going to go through this for each one of these and do that just like on the last time. That way we make it just look a little bit nicer. So we'll make sure input is like that as well. Capitalize these. We have 2 more, just the text area and the button. And we'll make sure the closing tags are good as well. If I go ahead and change those, save those, head back to the page. Doesn't look perfect, but it looks a lot better than it did before. And we'll also do the same thing just to give this button a little bit more space here. We're going to give it class name of margin top 4. So now it's separated from the box and it looks a bit more nice and spaced out. And one thing I'll do as well, like we did last time, is just giving these a width of 1/3. So I'm going to go ahead and make class name here. Let's say width of 1/3 for this page, save it. And now it's a bit more spaced out. Then I'm also going to go into the about page and do the exact same thing. So say width of 1/3. And you can see now both the about us and the contact pages are centered, or not centered, sorry. They are with 1/3. But one thing we should still try and do here, like I just said a minute ago, little 48 slip, was centering. So right now it's a little bit awkward because the forms are centered and the text is left aligned on both of these pages. So let's go ahead and fix that really quick. A simple fix would be just to go into, let's say, the contact page here, and let's look at these p tags. And I'm just going to add, let's see, these all have text left. So let's go ahead and make these text center. Save it. And if we go back to our page, now they should all be centered. Let's go ahead and actually give this one some bottom margin as well. So that way it's not so close to the form. So let's just say margin bottom. Let's give it 8. And that separates out the form a little bit from the text. Let's also go into the about page and change the same thing. So these all say text left. But that's not what we want. We want center instead. So let's go ahead and replace all these lefts right here with center. Save it. And now on both of our pages, all the text as well as the form is centered, which is exactly what we wanted. One final thing on this contact page. Notice how on the CreateBlog page, we ended up fixing these labels here. So they're on the left side and they have a little bit more padding. Let's go ahead and do the exact same thing for contact as well. So I believe the things we added last time, if we go ahead and go to the labels, is we just added class name and it was flex, left 0, and I think it was 2 padding. So let's go ahead and copy this, paste it into these labels here, and we can see this is what our page looks like right now. If we go ahead and save it, this is what our page looks like afterwards. So now all the labels are just on the left side, and we have a bit more space between each text area here, which makes it look a little bit cleaner. Now that we've finished up with this page, we have now taken care of the contact page, the about us page, the create blog page, and the home page, as well as the page where we can read a particular blog. However, there's one more page that we haven't touched yet, which is the profile page. So let's go ahead and finish this one last. For this profile page, I'm actually not going to use any Shadcn components here, just the typology. So I'm going to go into the, I think it's the ReadBlog Page, and I'm going to go ahead and take the typology that I had for header 2 here. I'm going to copy it, go back to our profile page. I'm going to copy in that for our labels. So I'm going to go ahead and paste this in here, here, and here. Go ahead and save this page. And you can see this typography looks a little bit better now. However, as you can tell, the obvious problem with this page is that it's all in one really ugly looking row format, not the column format. And there's actually a super easy fix to this. If we just give this an outer div here, instead of having it be these empty tags, it should apply our base CSS, and we go in here, and now it's in a column format, so it's a lot nicer than the row. One thing that might be a little bit hard to see right now is below each of these labels, there is this gray line here that is a bottom border. And we actually don't want that, so I'm going to go into our code, and for each of these, just delete this border B to get rid of that bottom border so it doesn't look as weird. So yeah, now those are gone. And just like our other pages, I actually want to make this width of this page 1/3 of the screen size. So in our div here, I'm going to give it a class name of width 1/3. Go ahead and save it. And now we can see it is now 1/3 the size of the screen instead of being smashed into a much smaller container. Next, let's say for whatever reason we don't want these labels and this user information to be right centered in the middle of the screen, but rather aligned with the left side of the container. One way we can do that is to just go into our class name here and give it properties of flex, and we'll say left 0. That'll make it a flex box and make sure it's on the very left side. So if I just take this flex and left 0 I added, and I go ahead and copy and paste it into the others here and save it, you will see now our labels are aligned to the left-hand side. However, just so it's not awkward, we also want to shift over the information to the left-hand side as well. So let's also add a class name to each of these header 2s, and we will add the same thing with flex and left 0. So we'll just go ahead and paste that in. I'll go ahead and just copy this whole thing, paste it here, and paste it here, so that now everything should be aligned to the left-hand side. Just so we can generate some space between some of these entries, I'm going to add some bottom margins to each of our information headers here. So I'm going to give this one, let's just say bottom margin of, let's say 2. I'll copy and paste that into each of these, and we'll save it, and we'll see how this looks. And I do think it looks a little bit better, but we could maybe go a little bit higher. Let's try bottom margin of 4. And there we go. In my opinion, it looks a little bit nicer than margin 2. And now we have this page mostly fleshed out. I'm not going to mess with it for right now, but if you wanted to, you could take this date and convert it into the actual date format, kind of like we did on the pages where you can actually read the blogs. Like here it says February 14th, 2024, instead of having this long string. But since we already did that on the code for the ReadBlog page, I'm not going to mess with it on the profile page, but that's something you can feel free to add if you'd like. Before we start wrapping things up with this styling, there's one more thing I actually want to fix, and it's kind of bugging me. If you notice at the top of the page here, this logout button has no border or anything around it, and it's kind of just awkwardly sitting there. So let's actually head into the code for our navbar, if I can find it, right here. And let's change the code for that login button so it looks a bit better. And actually, I'm curious to see, because in our navbar, we have the Shadcn navigation menu link, I'm curious to see what that would look like for this button here. So I'm actually going to change this to navigation menu link. Oops. Should be this one. And we'll do the same for the closing tag. And go ahead and save it. And it didn't make it much different, so let's add some modifications. We may have to add this thing as well, so let's add this class name in here. We'll do it right before our onClick property. And save it. And you can see now it looks much more similar to the actual other buttons. But it still looks a little bit weird, and you want it to actually stand out from the rest of the buttons, so let's add some of our own styling. If we want to add styling to this function here that we already have, we can just add basically like a plus sign here to add more of our own styling. So if we do a class name here plus this current styling thing, we can say, let's give it some left margins. Let's say 2, go ahead and save it. And you'll see it adds a class name on top of this already existing function. And let's also give it, let's say, I think we should give it a nice little red color so that it stands out from the rest of the buttons, so you know that it does something like logout. So let's give it a, let's say background red. Let's go 500, a nice like medium red. Go ahead and save it. And oh, I forgot the space here. Go ahead and save it here. And now the logout button should be red and spaced a little bit more apart from the rest of the buttons. This isn't perfect, but it gets the job done. We could easily make some improvements to this navbar or to any of these other pages, but let's review all the styling we've done so far so that we can wrap up this episode. Let's do a quick scan of all the pages that we have so far, starting with the landing page. So I'm actually going to go and log out, take us back to the landing page, and here we're met with the first page that we get when a user enters the site. On this first view here, we have the login view where our user can enter their email and password, and we have the login and create new account buttons. If we click create new account, it opens up a field where we can actually create a new account, which as we know will upload a new user to MongoDB. Let's go ahead and just log into the site so we can start testing our other things. Well, I believe this should be the correct login information. Let's log in here, and it takes us to the main page, which we are calling this the home page. On the home page, in a super simplified format, we just have all the blog posts displayed as a card, where whenever you hover over them, we can click on each one. Let's click on a blog post called The Power of Solitude, and it takes us to a page where you can actually read the blog itself. So we have all this text here. We have information about it, like its title, description, its image, and the date it was created. And of course, we can go on this back button to navigate back. Let's say we want to access another page. We can go to Exploring the Art of Mindful Cooking, and we can read this blog instead. Those two pages, the home page and this ReadBlog page, are the bread and butter of our application. Let's check out the other ones that we have. We have the CreateBlog page where you can actually write a blog. So we can do the title here, the description here, fill out all the content, which can be just as much text as we pretty much want. And then we can insert a file here to be uploaded to AWS that will display whenever a user wants to read a particular blog. After this, we have the profile page, which we just did, where you can see your name, email, join date, and all the blogs that you yourself have posted. Then we have, of course, the About Us page, which is just a super simple page with some text telling us about, whatever the site is. And this obviously is kind of this filler text. And then we have the contact page where we have a mock form. It doesn't actually do anything right now, but if we wanted to, it could. Where we just fill in some form data like name, email, and message if we wanted to contact the owners of the site. And of course, we have the logout button, to get us logged out and back to the landing page. If you would like to get more creative with this site, please feel free to do so. This wasn't meant to make our site look professionally deployable, but at least give you a basic understanding of what styling a website looks like, particularly if you're using Tailwind and a collection of pre-built components like Shadcn. There's one thing I didn't include in this episode due to it being a little bit outside of the scope, but it's very, very important if you want to actually do styling in the future for an actual website, and that's designing styling for multiple screen sizes. The site you're seeing right now looks nice when I'm on this computer, but if I were to access this site from, let's say, a mobile device right now, I can pretty much guarantee that the site would look pretty bad, because it's all styled to fit this screen size and not the size of a mobile screen. If you check out this page on Tailwind's website, this responsive design page, it gives you a guide on how to make a responsive design, meaning a site that will change its look depending on what screen size the user has. It revolves around using prefixes like small, medium, and large before styling properties within the class name, in order to give different properties based on size. I highly recommend checking this page out if you want to make a website that has responsive design. Now that we have that understanding and they've covered pretty much all the bases, I'm going to end this episode here, and that is going to draw this series to a close. When we first started, we were just getting a bare bones React app working and just learning how to set up a server. Now that we've gone through this series, we've learned everything from handling database interactions to front-end and back-end interactions via HTTP, user encryption, and all sorts of other things. I really hope this course was able to help give you at least a basic understanding of how full stack development works and how you can handle all of its moving parts. I highly encourage you to keep practicing stuff on your own and come back to this course as a guide if you ever need it. Thanks so much for watching, everyone, and I'll see you soon.